Hi.
Good morning. Welcome to day 3 of Google I/O and what should be a fun conversation about machine learning and artificial intelligence. My name is Tom Simonite. I'm San Francisco Bureau Chief for MIT Technology Review. And like all of you, I've been hearing a lot recently about the growing power of machine learning. We've seen some striking results come out of academic and industrial research labs, and they move very quickly into the hands of developers who have been using them to make new products and services and companies. I'm joined by 3 people this morning who can tell us about how this new technology and the capabilities it brings are coming out into the world. They are Aparna Chennapragada, who is the Director of Product Management and worked on the Google Now mobile assistant, Jeff Dean, who leads the Google Brain research group here in Mountain View, and John Gianandrea, who is Head of Search and Machine Intelligence at Google. Thanks for joining me, all of you.
Thanks.
We're going to talk for about 30 minutes, and then there will be time for questions from the floor. John, why don't we start with you? You could set the scene for us. Artificial intelligence and machine learning are not brand new concepts. They've been around for a long time. But we're suddenly hearing a lot more about them. Large companies and small companies are investing more in this technology, and there's a lot of excitement. You can even get a large number of people to come to a talk about this thing early in the morning. So what's going on? Tell these people why they're here.
What's going on? Yeah, thanks, Tom. I mean, I think in the last few years we've seen extraordinary results in fields that hadn't really moved the needle for many years, like speech recognition and image understanding. The error rates are just falling dramatically, mostly because of advances in deep neural networks, so-called deep learning. I think these techniques are not new. People have been using neural networks for many, many years, but a combination of events over the last few years has made them much more effective and caused us to invest a lot in getting them into the hands of developers. People talk about in terms of AI winters and things like this, right? I think we're kind of in an AI spring right now, where we're just seeing remarkable progress across a huge number of fields.
OK. And how long have you worked in artificial intelligence, John?
Well, we started investing heavily in this at Google about 4 years ago. I mean, we've been working in these fields like speech recognition for over a decade.
OK.
But we kind of got serious about our investments about 4 years ago and getting organized to do things that ultimately resulted in the release of things like TensorFlow, which Jeff Team's worked on.
OK. And we'll talk more about that later, I'm sure. Aparna, give us a perspective from the view of someone who builds products. So John says this technology has suddenly become more powerful and accurate and useful. Does that open up new horizons for you when you're thinking about what you can build?
Yeah, absolutely. I think for me, these are great as a technology, but as a means to an end. They're powerful toolkits, but to help solve real problems, right? And for us as building products, and for you guys too, there's 2 ways that machine learning changes the game. One is that it can turbocharge existing use cases, that is, existing problems like speech recognition, by dramatically changing some technical components that power the product. If you're building a voice-enabled assistant, the word error rate that John was talking about, as soon as it dropped, we actually saw the usage go up, right? So the product gets more usable as machine learning improves the underlying engine, right? Same thing with translation. As translation gets better, Google Translate, it scales to 100+ languages, right? And photos is a great example. You've heard Sundar talk about it too, that as soon as you have better image understanding, the photo labeling gets better, and therefore I can organize my photos. So it's a means to an end. That's one way, certainly, that we've seen. But I think the second way that's personally far more exciting to see is where it can unlock new product use cases, right? So turbocharging existing use cases is one thing, but where can you kind of see problems that really weren't thought of as AI or data problems? And thanks to mobile here, right, 3 billion phones, a lot of the real-world problems are turning into AI problems, right? Transportation, health, and so on. That's pretty exciting, too.
OK. And so is one consequence of this that we can make computers less annoying, do you think? I mean, that would be nice. I think we've all had this experience where you have a very clear idea of what it is you're trying to do, but it feels like the software is doing everything it can to stop you. Maybe that's a form of artificial intelligence too, I don't know. But I mean, can you make more seamless experiences that just make life easier?
Yeah, and I think in this case, again, like one of the things to think about is how do you make sure, especially as you build products, how do you make sure your interface scales with the intelligence, right? Like the UI needs to be proportional to AI. Like I can't believe I said some pseudo formula in front of Jeff Dean, but I think that's really important to make sure that the UI scales with the AI.
Okay, and Jeff, for people like Aparna and building products to do that, we need this kind of translation step, which your group is working on. So Google Brain is a research group, works on some very fundamental questions in this field, but you also build this infrastructure, which you're kind of inventing from scratch, that makes it possible to use this stuff.
Yeah, I mean, I think, obviously in order to make progress on these kinds of problems, it's really important to be able to try lots of experiments and do that as quickly as you can. There's a very sort of fundamental difference between having an experiment take a few hours versus something that takes 6 weeks. It's just a very different model of doing science. And so one of the things we work on is trying to build really scalable systems that are also flexible and easy to express new kinds of machine learning ideas. And so that's how TensorFlow came about. It's sort of our internal research vehicle, but also sort of robust enough to take something you've done and done lots of experiments on, and then when you get something that works well, to take that and move it into a production environment. Run things on mobile phones or in data centers, on our TPUs that we announced a couple days ago. And that seamless transition from research to putting things into real products is what we're all about.
Okay, and so TensorFlow is this very flexible package. It's very valuable to Google. You're building a lot of things on top of it, but you're giving it away for free. Have you thought this through? Isn't this something you should be keeping closely held?
Yeah, there was actually a little bit of debate internally, but I think we decided to open source it, and it's got a nice Apache 2.0 license, which basically means you can take it and do pretty much whatever you want with it. And the reason we did that is several-fold. One is we think it's a really good way of making research ideas in machine learning propagate more quickly throughout the community. People can publish existing, of something they've done, and people can pick up that thing and reproduce those people's results or build on them. And if you look on GitHub, there's 1,500 repositories now that mention TensorFlow, and only 5 of them are from Google.
Right.
And so it's people doing all kinds of stuff with TensorFlow, and I think that free exchange of ideas and accelerating that is one of the main reasons we did that.
Okay, and where is this going? So I imagine right now that TensorFlow is mostly used by people who are quite familiar with machine learning, but ultimately, the way I hear Google talk about machine learning, it's just going to be used by everyone, everywhere. So can developers who don't have much of a background in this stuff pick it up yet? Is that possible?
Yeah, so I think actually there's a whole set of ways in which people can take advantage of machine learning. One is, as a fundamental machine learning researcher, you want to develop new algorithms, and that's going to be a relatively small fraction of people in the world. But as new algorithms and models are developed to solve particular problems, those models can be applied in lots of different kinds of things. If you look at the use of machine learning in the diabetic retinopathy stuff that Sundar mentioned a couple days ago, that's a very similar problem to a lot of other problems where you're trying to look at an image and detect some part of it that's unusual. Mm-hmm. We have a similar problem of finding text in Street View images so that we can read the text. And that looks pretty similar to a model to detect, diseased parts of an eye. It's just different training data, but the same model. And so I think the broader set of models will be accessible to more and more people. And then there's even an easier way where you don't really need much machine learning knowledge at all, and that is to use pre-trained APIs.
Right.
So essentially, you can use our Cloud Vision API or our speech APIs very simply. You just give us an image, and we give you back good stuff. And as part of the TensorFlow open source, we also released, for example, an inception model that does image classification. That's the same model as underlies Google Photos.
Okay, so it will be possible for someone, maybe they're an experienced builder of apps, but don't know much about machine learning. They could just have an idea and kind of use these building blocks and plug them together. Yeah,
actually, I think one of the reasons TensorFlow has taken off is the tutorials in TensorFlow are actually quite good at illustrating, 6 or 7 sort of important kinds of models in machine learning and showing people how how they work, stepping through both the machine learning that's going on underneath and also how you express them in TensorFlow. That's been pretty well received.
Okay. And Aparna, I think we've seen in the past that when a new platform of mode of interaction comes forward, we have to experiment with it for some time before we figure out what works, right? So, and sometimes when we look back, we might think, oh, you know, those first generation mobile apps were kind of clunky and maybe not so smart. How are we going with that process here? We're starting to have to understand what types of interaction work.
Yeah, and I think that's it's one of the things that's not intuitive when you start out, like you rush out into a new area like we've all done. So one experience, for example, when we started working on Google Now, one thing we realized is it's really important to make sure that, depending on the product domain, some of these black box systems, you need to pay attention to what we call internally as the wow to WTH ratio. That is, as soon as you kind of say, hey, there are some delightful, magical moments, right? But then if you kind of get it wrong, there's a high cost to the user. Mm-hmm. So to give you an example, in Google search, let's say you search for, I don't know, Justin Timberlake, and we got a slightly less relevant answer. Not a big deal, right? But then if the assistant told you to sit in the car, go drive to the airport, and you missed your flight, what the hell, right? So I think it's really important to get that ratio right, especially in the early stages of this new platform. Right. The other thing we noticed also is that explainability or interpretability really builds trust in many of these cases. So you want to be careful about looking at which parts of the problem you use machine learning and you drop this into. You want to look at problems that are easy for machines and hard for humans, right? The repetitive things, and then make sure that those are the problems that you throw machine learning against. But you don't want to be unpredictable and inscrutable.
Mm-hmm. And one mode of interaction that everyone seems to be very excited about now is this idea of conversational interface. So we saw the introduction on Wednesday of Google Assistant, but lots of other companies are building these things too. Do we know that definitely works? Like, what do we know about how you design a conversational interface, or what the limitations and strengths are?
I think, again, at a broad level, you want to make sure that you can have this trust. So narrower domains make it easy. So it's very hard to make a very horizontal system work that works for anything. But I'm actually pretty excited at the progress, right? We just launched, open source the sentence parser, Parsi McParseface. I just wanted to say that name. But it's really exciting because then you say, okay, you're starting to see the beginning of conversational, or at least like a natural language sentence understanding, and then you have building blocks that build on top of it.
Okay. Right? And John, with your search hat on for a second, so we heard on Wednesday that I think 20% of US searches are now done by voice, so people have clearly got comfortable with this, and you've managed to provide something that they want to use. Is the assistant interface to search going to grow in a similar way, do you think? Is it going to take over a big chunk of people's search queries?
Yeah, I mean, we think of the assistant as a fundamentally different product than search. And I think it's going to be used in a different way. But we've been working on what we call voice search for many, many years. And we have this evidence that people like it and are using it. And I would say our key differentiator there is just the depth of search and the number of questions we can answer and the kinds of complexities that we can deal with. I think language and dialogue is the big unsolved problem in computer science.
Right.
So imagine reading an article and then writing a shorter version of it. That's currently beyond the state of the art. I think the important thing about the open source release we did of the parser is it's using TensorFlow as well. So in the same way as Jeff explained, the functionality that's in Google Photos for finding your photos is actually available open source, and people can actually play with it and run a cloud version of it. We feel the same way about natural language understanding, and we have many more years of investment to make in getting to really natural dialogue systems where you can say anything you want, and we have a good shot at understanding it. So for us, this is a journey. Clearly, we have a fairly usable product in voice search today, and the assistant, we hope, when we launch it later this year, people will similarly like to use it and find it useful.
Okay. Do you need a different monetization model for the assistant dialogue? Is that something?
We're really focused right now on building something that users like to use. I think Google has a long history of trying to build things that people find useful, and if they find them useful and they use them at scale, then we'll figure out a way to actually have a business to support that.
Okay, okay. So you mentioned that there are still a lot of open research questions here, so maybe we could talk about that a little bit. As you described, there have been some very striking improvements in machine learning recently, but there's a lot that can't be done. I mean, if I go to my daughter's preschool, I would see young children learning and using language in ways that your software can't match right now. So can you give us a summary of the territory that's still to be explored?
Yeah, I mean, there's a lot still to be done. I think there's a couple of sort of areas which researchers around the world are furiously trying to attack. So one is learning from smaller numbers of examples. Today, the learning systems that we have, including deep neural networks, typically require really large numbers of examples, which is why Jeff was describing they can take a long time to train, and that the experiment time can be slow. So it's great that we can give systems hundreds of thousands or millions of labeled examples, but clearly small children don't need to do that. They can learn from very small numbers of examples. So that's an open problem. I think another very important problem in machine learning is what the researchers call transfer learning, which is learning something in one domain and then being able to apply it in another.
Right.
Right now, you have to build a system to learn one particular task, and then that's not transferable to another task. So, for example, the AlphaGo system that won the Go championship in Korea, that system can't a priori play chess or tic-tac-toe.
Right.
So that's a big open problem in machine learning that lots of people are interested in.
Okay. And Jeff, this is kind of on your group to some extent, isn't it? You need to figure this out. Are there particular avenues or recent results that you would highlight that seem to be promising?
Yeah, I mean, I think we're making actually pretty significant progress in doing a better job of language understanding. I think if you look at where computer vision was, 3 or 4 or 5 years ago, it was kind of just starting to show signs of life in terms of really making progress. And I think we're starting to see the same thing in language understanding kinds of models, translation, parsing, question answering kinds of things. In terms of open problems, I think unsupervised learning, being able to learn from observations of the world that are not labeled, and then occasionally getting a few labeled examples that tell you these are important things about the world to pay attention to, that's really kind of one of the key open challenges in machine learning.
Right.
And one more I would add is, right now, what you need a lot of machine learning expertise for is to kind of devise the right model structure for a particular kind of problem. For an image problem, I should use convolutional neural nets, or for language problems, I should use this particular kind of recurrent neural net. And I think, one of the things that would be really powerful and amazing is if the system itself could devise the right structure for the data it's observing. Right? So learning model structure concurrently with trying to solve some set of tasks, I think would be a really great open research problem.
Okay. So instead of you having to design the system and then setting it loose to learn, the learning system would build itself to some extent?
Right. Right now you kind of define the scaffolding of the model and then you fiddle with parameters as part of the learning process, but you don't sort of introduce new kinds of connections in the model structure itself.
Right, okay. And unsupervised learning, I mean, just giving it that label, it makes it sound like one unitary problem, which may not be true, but will big progress on that come from one flash of insight and a new algorithm, or will it be, I don't know, a longer slog?
Yeah, if I knew, that would be
Okay.
I have a feeling that it's not going to be like 100 different things. I feel like there's a few key insights that new kinds of learning algorithms could pick up on as to what aspects of the world that the model is observing are important. Mm-hmm. And knowing which things are important is kind of one of the key things about unsupervised learning.
Okay. Now, Aparna, so what Jeff's team kind of works out eventually should come through into your hands and you could build stuff with it. Is there something that you would really like him to invent tomorrow so you can start building stuff with it today, the day after?
Auto-generate emails. No, I'm kidding. I do think actually, so what's interesting is you've heard kind of these building blocks, right? So machine perception, so computer vision wasn't a thing, and now it's actually reliable. Language understanding, it's getting there. Translation is getting there. To me, the next other building block that if you can make machines do is hand-eye coordination. So you've seen the robot arms video that like Sundar showed at the keynote. But imagine if you could kind of have these rote tasks, that are hard or like tedious for humans. But if you had reliable hand-eye coordination that built in, and that's in a learned system versus a control system code that you usually write, and it's very brittle, suddenly it opens up a lot more opportunities, right? Just off the top of my head, why isn't there anything for like elderly care, right? Like you are an 80-year-old woman with a bad back, and you're picking up things. Why isn't there something there? Or even something as mundane with natural language understanding, right? I have a 7-year-old, I'm a mom of a 7-year-old. Like, why isn't there something for, I don't know, math homework with natural language understanding?
So I think one of the things we've learned in the last few years is that things that are hard for people to do, we can teach computers to do, and things that are easy for us to do are still the hard problems for computers.
Right. Okay. And do you think, does that mean we're still missing is there some big new field we need to invent? Because I mean, most of the things we've been talking about so far have been built on top of this deep learning and neural network.
I mean, I think robotics work is interesting because it gives the computer system an embodiment in the world, right? And so learning from tactile environments is a new kind of learning, as opposed to just looking at unsupervised or supervised. Like just reading text is a particular environment.
Yeah.
Perception, looking at images, looking at audio, trying to understand what this song is. That's another kind of problem. I think interacting with the real world is a whole other kind of problem.
Right. Okay. That's interesting. Maybe this is a good time to talk a little bit more about DeepMind. I know that they are very interested in this idea of embodiment. The idea you have to submerge this learning agent in a world that it can learn from. Can you explain how they're approaching this?
Yeah, sure. I mean, DeepMind is another research group that we have at Google, and we work closely with them all the time. They are particularly interested in learning from simulations. So they've done a lot of work with video games and simulations of physical environments, and that's one of the research directions that they have. It's been very, very productive.
Okay. So is it just games? Are they moving into different types of simulation?
Well, there's a very fine line between a video game and a three-dimensional video game and a physics simulation of any environment, right? I mean, some video games are in fact full simulations of worlds. So it's not really, there's not really a bright line there.
Okay. And do DeepMind work on robotics? They don't, I don't think.
They're doing a bunch of work in a bunch of different fields, some of which is published, some of which is not.
Okay. And the robot arms that we saw in the keynote on Wednesday, are they within your group, Jan?
Yes.
Okay. So can you tell us about that project?
Sure. So that was a collaboration between our group and the robotics teams in Google X. Actually, what happened was one of our researchers discovered that the robotics team actually had 20 unused arms sitting in a closet somewhere. They were a model that was going to be discontinued and not actually used. So we're like, hey, we should set these up in a room. And basically just the idea of having a sort of little bit larger scale robotics test environment than just one arm, which is what you typically have in a physical robotics lab, would make it possible to do a bit more exploratory research. And so one of the first things we did with that was just have the robots learn to pick up objects. And one of the nice properties that has, it's a completely supervised problem. The robot can try to grasp something, and if it closes its gripper all the way, it failed. And if it didn't close it all the way and it picked something up, it succeeded.
Right.
And so it's learning from raw camera pixel inputs directly to torque motor controls. And there's just a neural net there that's trained to pick things up based on the sort of the observations it's making of things as it approaches a particular object.
And is that quite a slow process? I mean, the fact you have multiple arms going at once made me think that maybe you were trying to maximize your throughput or something.
Right. So if you have 20 arms, you get 20 times as much experience. And if you think about how small kids learn to pick stuff up, it takes them maybe a year or something to go from like being able to move their arm to really being able to grasp simple objects.
Right. And
by parallelizing this across more arms, you can pool the experience of the robotic arms a bit.
I see. Okay. And
they need less sleep.
Right. John, at the start of the session, you referred to this concept of AI winter, and you said you thought it was spring. When do we know that it's summer?
Summer follows spring. I mean, there's still a lot of unsolved problems. I think problems around dialogue and language are the ones that I'm particularly interested in. So until we can teach a computer to really read, I don't think we can declare that it's summer. I mean, if you can imagine computers really reading and internalizing a document. So it's interesting. So translation is reading a paragraph in one language and writing it in another language. In order to do that really, really well, you have to be able to paraphrase. You have to be able to reorder words and so on and so forth.
Right.
So imagine translating something from English to English, right? So you read a paragraph and you write a different paragraph, right? If we could do that, I think that I would declare summer.
Okay. Reading is, well, there are different levels of reading, aren't there? I mean, do you know, I don't know.
If you can paraphrase, then you really
Then you think
can
if you
say
can reach
that
that
you
level,
actually understood
then you've got
the
somewhere.
document. And to a certain extent today, our translation systems, which are not perfect by any means, are getting better. They do some of that. They do some paraphrasing. They do some reordering. They do a remarkable amount of language understanding. So I'm hopeful that researchers around the world will get there. And it's very important to us that our natural language APIs become part of our cloud platform and that people can experiment with it and help.
Right.
One thing I would say is I don't think there's going to be this abrupt line between spring and summer, right? Like, there's going to be developments that push the state of the art forward in lots of different areas in kind of this smooth gradient of capabilities. And at some point, like, something becomes possible that didn't used to be possible, and people kind of move the goalposts of what they think of as like sort of really, truly hard problems.
Right. That's
the classic joke, right? Like, if it's only AI until it starts working, and then it's computer science.
Like if you'd asked me 4 years ago, could a computer write a sentence given an image as input? I would have said, I don't think they can do that for a little while. And they can actually do that today. And that's kind of a good example of something that has made a lot of progress in the last few years. And now you sort of say, OK, that's in our tool chest of capabilities.
OK. But if we're not that great at predicting how the progress goes, does that mean we can't see winter if it comes back?
I mean, if we stop seeing progress,
then you'll know.
Then I think we could question what the future is going to look like. But today, the rate of I think researchers in the field are excited about this, and maybe the field is a little bit overhyped because of the rate of progress we're seeing. Right? Because something like speech recognition, which didn't work for my wife 5 years ago, now works flawlessly. Because image identification is now working better than human raters for many fields. There's these narrow fields for which algorithms are now superhuman in their capabilities. So we're seeing tremendous progress, and so it's very exciting for people working in this field.
Okay, great. I should just note that in a couple of minutes we will open up the floor for questions. There are microphones here and here in the main seating area, and there's one microphone up in the press area, which I can't see right now, but hopefully you can figure out where it is. Sundar Pichai, CEO of Google, has spoken a lot recently about how he thinks we're moving from a world which is mobile first to AI first. I'm interested to hear what you think that means. Maybe Aparna, you could speak to that.
I think it's, I interpret it a couple different ways. One is if you look at like how mobile's changed, how you experience computing, it's not happened at one level of the stack, right? It's at the interface level, it's at the information level and infrastructure. And I think that's the same thing that's going to happen with like AI and any of these machine learning techniques, which is you'll have infrastructure layer improvements. You saw the announcement about TPU. You'll have a bunch of like algorithms and models improvements at the intelligence and information layer, and there'll be interface changes, right? So the best UI is probably no UI.
Right. Okay. John, what does AI first mean to you?
I think it means that this sort of assistant kind of layer is available to you wherever you are, right? Whether you're in your car, or whether it's ambient in your house, or whether you're using your mobile device or laptop, that there is this smart assistance that you find very quietly useful to you all the time, right?
Okay.
Kind of like how Google search is for most people today. I think most people would not want search engines taken away from them, right?
Yeah.
So I think that being that useful to people so that people take it for granted and it's ambient across all your devices is what AI first means to me.
Okay. And we're in the early stages of this, you think?
Yeah.
Yeah. Okay.
Yeah, it's a journey, I think. It's a multi-year journey.
Okay, great. So thanks for a fascinating conversation. Now we'll let someone else ask the questions for a little bit. I will alternate between the press mic and the mics down here at the front. Please keep your questions short so we can get through more of them, and make sure they're questions, not statements. We will start with the press mic, wherever it is.
There's nobody there.
I really doubt the press has no questions. But is that what's happening? Why don't we start with the developer mic?
Ready? Yeah.
43, take 2, second sticks.
Hey there, Polycasters. Rob here. I'm gonna pause for a second. Oh, Twitter notifications.
If a tree falls in the forest and nobody's there to hear it, does it make a sound? More importantly, if your app gets published to the world and nobody's there to download it, was all that work for nothing? These aren't just philosophical questions. Discovery is a major issue for everybody. It doesn't matter if you're a two-person shop or a big corporation. And while there are many avenues for potential customers to discover your app, one of the most common is through recommendations from friends and family. Developers know this, which is why you see referral codes like this in a lot of apps. It's a good way of enticing users to share the app with their friends. But while these kinds of referral codes can be effective, they're also kind of a pain to use. Is your user really going to take the time and effort to copy and paste a referral code into an email, send it off to their friends, hope those friends then find and install the app, dig up whatever code redemption screen they need to redeem this offer, and copy and paste this code back into your app? Well, maybe, but maybe not. And while you could build your own UI to help this process along with, all those spare engineering cycles you've just got lying around, this is also where Firebase Invites can help. Firebase Invites makes it easy for your users to share all aspects of your app, be it a referral code or an interesting piece of content, across both Android and iOS. It looks something like this. Let's say that your app has a referral code that you'd like your users to share with their friends, and you decide to use Firebase Invites to make it happen. When your user clicks that share button, they'll see a dialog listing all their friends and colleagues with some smart recommendations at the top. They choose which friends to share with, click send, and these invitations are sent, along with a personal message, over SMS or email, depending on the contact. Their friends receive a customized, richly formatted invitation, either one you've designed yourself or one you've let Firebase Invites build automatically from your app's store listing. All this recipient needs to do is click on the call to action button, and Firebase Invites will take them directly to the store for their device if they don't. Once they're done installing your app, Firebase Invites can then send the referral code to your app through a deep link. And you can send your new customer the discount that they so richly deserve. And yes, this really does work even if that friend had to install the app first. Traditionally, deep links tend to get lost during app installs, but Invites uses Firebase dynamic links, which are able to survive the App Store installation process. As an added bonus, many developers have found that not only are these kind of invites more successful at driving installs, but that users who join through this kind of personalized onboarding flow are more likely to come back to your app in the future. And Firebase Invites isn't just for referral codes. You can use it to share any content you want from your app. Have a recipe app? Firebase Invites can make sure that killer lemon meringue pie recipe gets the visibility that it deserves. And because Invites is a Firebase product, it works with Firebase Analytics to let you know when a user has opened or installed an app through an invite. So be sure to check out the documentation and give Firebase Invites a try. We can't wait to see what you build.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers: They're all species of iris: setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at scikit provided a bunch of sample datasets, including iris, as well as utilities to make them easy to import. We can import iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the data set is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left. Otherwise, go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise. And remember, the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
So constraints. They're a great way for you as a developer to deal with the ever-expanding number of screen sizes, device rotations, and new form factors like slide over in the iOS world. But one unfortunate casualty in this brave new world of alignment has been the way we animate views. See, it used to be we could go around setting a UI view's position or frame with a fun little UI view animate with duration method and watch our view scoot around the screen. Oh, that was fun. But that's harder to do in a world full of constraints. Constraints don't necessarily play nicely with a view whose frame you're setting explicitly, as you can see here. Well, that leads us to this episode's quick tip sent in by Jacob Cho, a fan of Route 85 and a software engineer at Ensemble, a mobile app developer located in beautiful Vancouver, British Columbia. Jacob notes that many iOS developers forget that in addition to the old way of animating a view's position, you can also animate constraints in iOS. Let's look at how you might do that. Here's my storyboard, and as you can see here, I've got everything set up nicely using constraints. Now to move my UI image view on and off screen, I'm going to want to change this constraint here, the one that sets my image's leading edge to the leading edge of my super view. Right now it's set to -180, so it's off screen. So first I'm going to control drag from this constraint into my view controller to make it an IB outlet of type NSLayout constraint. This allows me to access it in my code. Now I can adjust it with a standard UI view animate with duration call. In this case, I'll change the constant of the constraint from -180 to 0 so that it appears on screen, and now we can give it a try. Well, that's weird. The constant definitely changed, but what happened to my animation? Well, it turns out to get this constant to animate nicely, I need to call layout if needed on my view controller's view within this animation block. We'll give it one more try, and that's much better. I now have a constraint that I can change within an animation block, and everything animates smoothly to its final position, except in cases where I want to adjust something besides my constraint's constant. Let's take a look at another example. Here I want to adjust this center square to expand or shrink to be either twice or half the width of its neighbors. Now I could do that in theory by adjusting the multiplier on the center view's width constraint. But it turns out that changing that multiplier in code doesn't work. See, constraint multipliers are a get-only property, and Xcode will give me an error. So how do I change it? Well, the answer is I don't. Instead, I create two completely different constraints and enable or disable either one as necessary. As long as I'm still calling layout if needed in my animation block, this kind of change will still animate. Now, there are two ways I can accomplish this constraint swapping. One way is to create both constraints in Interface Builder, like so. Now, Xcode will complain that these are incompatible, and it's right. So first step, we'll uninstall one of them by checking this box here. Next, we'll control drag both of these constraints into our code to make them IB outlets. And then I can enable or disable these as necessary in my animation block, like this. Once again, you'll notice I make sure we're calling layout if needed in our animation block, and we end up with a nice, smooth-looking animation. Look at that. The other way to accomplish this would be to create a completely new constraint in code. This is useful when I don't know in advance what I'm going to want this multiplier to be, and I need to create it dynamically. So let's see that in action. This time in my animation block, I'll first remove the old constraint. Next up, I can create a new multiplier. Let's make it slightly random just for fun. Ooh, hey, that is fun. OK, next I'll create a brand new constraint with this new multiplier and assign it to my center view width property. And then I can add it back in again to my view. Finally, I call layout if needed on the super view in the animation block, and I once again have some nicely animating views that use this new constraint that I've created. And because this is all done using constraints, you'll notice this works as intended on an iPhone in landscape mode, or even, say, a slide over view on an iPad. And once you understand that this trick simply involves removing an old constraint and adding a new one, you might discover a whole new world of animation is available to you simply by turning on and off various constraints. For example, on this screen, I can change all my views to be either left aligned or right aligned, simply by adding and removing two different groups of constraints, and then calling our now familiar layout if needed method. Pretty neat, huh? Oh, by the way, one fun little quirk about all this, if you add your new constraints before you remove the old ones, iOS will complain about all the incompatible constraints it has to deal with in those few milliseconds. So always make sure you remove the old ones first before adding the new ones. So thanks to Jacob for the quick tip. Jacob, you're going to get a very stylish Google t-shirt in the mail. But hang on, we're not done yet. You see, now that you know all about constraint animation, I have a couple more quick tips from one of Google's engineers about more efficient ways to implement it. So follow me on to the next video, because we're not done learning just yet. Click here, and otherwise, I'll see you on Route 85. Bye.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer, so you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
The Firebase Notifications console lets you re-engage your users quickly and easily. With it, you can manage and send notifications to your users easily with no additional coding required. Messages can be addressed to single devices, Firebase Cloud Messaging topics, or devices that you select using powerful analytics tools. So, for example, you could send a message to all of your users who have made an in-app purchase, giving them a special offer, allowing you to re-engage with them. The Firebase Notifications console integrates with analytics so you can measure the effectiveness of your messages and explore insights based on your users' activities, so you can grow your application by easily engaging your users through the Firebase Notifications console.
One of the driving principles of the mobile marketplace is that users want new apps, new updates, new content. In fact, over 60% of the users who go on to digital marketplaces do so because they want to try something new. While this is fantastic for user acquisition, this presents a problem for user retention, because if you are not keeping the user's attention, they will quickly be looking for something that will. In this episode, we will learn how to create a good retention strategy. Ready? Let's get started. The key to effective user retention can be broken down into 3 things. 1. Understand users' behavior in your app. 2. Identify roadblocks to retention. 3. Use tactics and tools to re-engage users. Now, of course, all of this starts with understanding your users. If you don't understand what they want, how they act, or their opinions, you can't really craft a strategy on how to keep them happy. The good news is that Google Analytics has a set of tools to give you insight here. First, check out your cohort analysis report. Why? Because cohort analysis is a powerful report that allows you to measure and compare users based on their specific customer journey. For example, what pages they visit, what they do, how they behave in each stage, etc. So you could measure the impact of your marketing campaigns on specific days, see how effective they are in generating loyal users, and compare which campaign performed best. Another good report is active users. Find out how your users interact with your app over time, so you could better understand why they may be staying in or leaving it. It displays your 1-day active users up to 30 days active users next to each other. This helps you answer some important questions regarding your users' retention. For example, if your 30 days active numbers is much higher than the 1-day active number, most users are not coming to your app more than once during a 30 days period. This can indicate that you need to add fresh content on a more regular basis, and maybe you need to re-engage users through marketing campaigns and notifications. The third report is about recency. This report shows how much time passed between app sessions. You might discover users who only open your app once a week. Once you identify users that engage with your app infrequently, you need to figure out how to re-engage that audience. You could send push notification to those users after 3 days to remind them about the app. You could even tailor the message to include incentives. A gaming app, for example, might want to send a push notification with an offer of a free in-app tool to users who haven't opened the app in a while. Now that you have an understanding of your users, you could start think about what their experience is like, and get visibility into what roadblocks they are encountering in your app. Here are 3 basic ways that will help you get this information. Screen tracking will help you learn where users spend their time. For example, if each level of a game uses a different screen, you could track what percentage of people pass through each level. If there's a level that has a massive users drop-off, that may indicate that there is a technical issue associated with that level, or it is just too hard. Monitor your behavioral flow report. It takes your screen tracking, event tracking, and combines it in a visual user flow. Lastly, use the crash and exceptions report to identify possible roadblocks. You could break data out by app version, operating system, and device brand, so you could evaluate your app's technical performance in different environments. Want to take it one step further? Find out how much crashes are costing you. You could do this by creating 2 segments, one for sessions with crashes and the other without. Then compare the conversion rates and the average order value to see if these metrics are lower in the sessions with crash. Now that you've got all the basics down, the final step is building an effective re-engagement pattern for your users. This varies between apps, but the tools we cover today will help you think in the right direction. Do me a favor. Stop spending money on apps installs if you don't have a retention strategy. It's like the dude that sells tomato at a loss and telling his friends that he's going to compensate on it by volume. Game monetization today is more challenging and sophisticated than it used to be. A good monetization strategy depends on your retention strategy. You need to understand your users' behavior, identify roadblocks, and use tactics and tools to re-engage with your users. On the next episode, we will learn how to use in-app purchase househead as part of our strategy to increase revenue. Until next time, eat your vegetables and listen to your partners.
So now Firebase, it's a part of Google, but I hear that you were part of Firebase for a long time.
I've been with Firebase for almost 2 years now, and I was a big user back in the early days. And when I first discovered it, I was building a lot of apps, and so having something that just made making apps so easy, I was kind of like, my God, they've done it. Like,
wow.
They've built the holy grail of development. And then one day they posted up a developer advocate job, and so sent my resume in on a Sunday. They called me on Monday, took a coding test on Tuesday, flew out on Wednesday, brought my whole family too, my wife and my 16-month-old son.
Wow.
Got the job that day.
So the only thing faster than the database is the hiring committee.
Yeah, no, it was a pretty fast process, just letting everyone know. I was like, oh, by the way, I'm moving to San Francisco.
See ya.
Yeah, pretty much.
Wow, and so now you're a developer advocate at Google, and Firebase is a part of Google. How is that?
That's been great. Like, it's been about 15 months ago that we were acquired, and it's been a really awesome experience because Google's just sort of thrown a lot of resources into us. We've expanded the team so much, and we've been able to focus on the core product and making Firebase better. We are in the middle of releasing a Unity plugin that's out there for beta for people to test out. Yeah, no, there's some pretty cool samples.
So lots of cool stuff there, David, but I mean, how does a developer get started with that?
So the best place to get started is just like right on the Firebase website. So firebase.com, and then you can sign up, but also firebase.com/docs. Our docs are one of the things that we really pride ourselves on. So by just reading our quick start guide, you can already get a gist of how to get started. And then and each platform integrates totally with whatever dependency manager it has. So with Android, it's great with Gradle. With iOS, you can use CocoaPods, and web.
Web's web, right? Now, one of the things I remember about Firebase is that you guys used to do these epic hackathons where you gave out really cool swag. Right,
yeah.
So is that something you're still doing?
Well, we used to make a joke that Firebase was actually a swag company, and we just were kind of put on a front that we did.
So it's a swag company that makes software.
Yeah, that was pretty much what we used to say.
It's a good business plan.
So yeah, we used to make, or we still do actually. We make tons of like pieces of swag. We did Firebase hot sauce was pretty awesome. Yeah. But yeah, we did hot sauce. We did my favorite is headbands. So you have these sweatbands. And so I was at a hackathon once, and I saw this guy who was like, hey, can I have a couple? And by couple, he meant 16. And then he started putting them on and kind of mummified himself and then just sat down and started hacking. And I was like,
did he?
I don't think so.
In all seriousness, though, I'm a developer. Middleware is really hard. If I want to have some kind of a database, if I want to have some kind of synchronization of data, it's a case where I can just go out and use Firebase today, right?
Yeah, no, that's what we're doing. We always say our mission is to help people build extraordinary applications. And so there's so many pieces of building something, and the back end is just so easy to get wrong, or so easy. You can just spend so much time. I remember one time I was building an Angular app, and I was so excited. It was I'm going to write directives, and I'm going to build this cool web app. And then I spent an entire month just building out the back end for it. And then I realized I haven't written a line of JavaScript yet. And so with Firebase, you don't have that problem. You can just immediately start doing what the user is interested in, because the user's only going to see the client-side stuff. I always say, you're never going to get an email from an app reviewer or someone saying hey man, your app is so good. I can tell you use so many databases. It's really awesome. They're just going to tell you.
I'm going to review your app with that now.
Yeah, if you ever get that review, let me know. I would love to see it.
So the people that write code in that language are also called gophers quite often. It's the stupid thing that techies do. The thing I noticed, it's when I saw it in pictures, I thought it's ugly as hell, and then you see it in reality, it's so cute. It's to be honest, it's one of the only. I'm not on right. One of the only good.
Your microphone.
Out your mic sometimes, so.
Good morning, everyone, and welcome to the third day of Google I/O 2016. Thank you. I haven't even done anything yet. I hope everyone has enjoyed the past 2 days. Met a lot of interesting developers, designers, and tech enthusiasts, and learned a lot about what's new at Google. If you're like me, whenever you come back from an event like this or a conference, your team and your boss always want to know what you learned while you were away. They want to know they got their money's worth. And especially because this is a developer conference, not only will your team want to hear about what you learn, they want to see what you learn. They want a demo of all of those cool new technologies you learned while you were here at I/O. So, when you get a text today at 5 o'clock, because you all will, from your boss or your teammate asking you to demo 9 a.m. on Monday, how are you going to get from 0 to app? If you didn't come to this talk, you might go home and start building something that looks like this. Your mobile client makes a bunch of REST requests to some application server. Maybe it's a Rails app or an Express app. And you'll spend a few hours tonight setting it all up, and by midnight, hopefully you'll have an app that makes some successful GET requests. Now, this application server handles all of the hard pieces of your app, such as authentication, authorization, and all of your app's business logic. You'll spend Saturday adding Passport for handling OAuth and fighting to sign your SSL cert so that your app is secure. In between your VMs going down and constant maintenance updates, because they always strike at the wrong time, by Saturday night, you should be able to log in a user via Google or Facebook. But you still need to store app data. You're missing this huge part of your app, your database. So Sunday morning, you'll wake up with a head full of database schemas and immediately start creating tables. And because you don't always get that right on the first time, Sunday afternoon and evening are going to be wasted making schema changes and migrating data. By Sunday at midnight, though, you'll have something that you're proud to demo to your team. But when you get in and demo on Monday, your team is going to have some questions. How are you handling authentication and authorization? What happens when your app goes offline? And most importantly, what about performance, and will it scale? If your team loves this concept, how quickly can you get your app into production? Luckily, you guys all came to this talk. So I'm going to teach you the secrets to create powerful apps that solve all of these hard problems. Firebase applications are not traditional apps. Firebase eliminates the middle tier and lets your devices talk directly to powerful managed services. We handle authentication and authorization, so there's no need to implement your own OAuth or build middleware. And Firebase scales automatically, so the app you build on Monday can go into production on Friday. Our smart clients handle all of the hard pieces, so you can focus on building applications that your users love. Now, we've provided several core features that allow you to do this. First, a real-time database that stores and synchronizes JSON data in milliseconds. Couple that with a serverless authentication system that handles complex social OAuth flows and session management with ease. And our newest feature, a highly scalable file storage solution that lets you upload petabytes of user-generated content. But listening to me talk isn't going to help you demo come Monday morning. Because Allo and Duo weren't enough, we're going to build another messaging app. Yeah. And since Firebase is fully cross-platform, and we're on stage at I/O, we're not just going to build an iOS app. We're going to also build an Android and a web app. But since I can't type on 3 keyboards at once, I've invited a few of my friends to come out and help. Frank, Alfonso, and Kat, let's build an app. Clicker? Frank.
Thanks, Mike. Let's see where we are. Hey, everyone. So what Mike said, we're going to be building a cross-platform chat app today. Chat app because this is Firebase, right? So we're going to be building it for iOS, web, and Android. And that requires some prep time from the guys. So let's solve our first problem. We need a place where we can store the data, the chat messages that everyone types. And we're going to do that in the Firebase database. Now, you've heard a lot about it already in the past 2 days. and I see quite some familiar faces who've known us before. So this is the executive summary for your team on Monday. The Firebase database is the first Firebase feature we built. We released it over 4 years ago. It's the original magic. It's a cloud-hosted JSON database. Let's break it down for your team. It's cloud-hosted. That means that all your data is stored in the Google Cloud, and all the apps will be talking to the same database. And that's great because that solves problem 1, right? We can now share the data. And it's a JSON database. And that really just means that it's a tree of values. But that is great because it being a tree allows us to model the data very flexibly. Let's look at our data model for today. So this is the JSON tree we'll be using today. At the top, we have a node called chat, and under that, we keep a list of the chat messages. For each message, we keep the name of the user that sent it and the text that they sent. Now back to the database itself. The Firebase database is not your regular database. With most databases, you work with a request-response model. So you build a query, you fire the query to the database, you wait until the messages come back. Our database is different. We ask the database to tell us when the value changes at a location. And that means that whenever the value changes, that change is synchronized to all other connected clients within milliseconds. This is the original magic of Firebase. We make building collaborative, real-time applications effortless. Let's see how. Can we switch over to the split screen, please? Cool. Now you know why they put us on the big stage. OK. So we're going to be coding all these apps in parallel. It's sort of synchronized programming that we're doing here. And I recommend that you follow along with the technology you're most comfortable with. At the top left, Alfonso is building an Android app with Android Studio. At the top right, Mike is building an iOS app with Xcode. And at the bottom left, Kat is working on a web app. I think she's using Atom, right? I think so. OK, we've already done some prep work. We've built the basic outlines of the chat app. So we've created the layouts, made sure that all the elements are available in our code, and we've even wired up the send button to add the message to the local screen. So you see that all of them are basically the most sad chat app you can ever imagine. Everyone's talking to themselves. Happens a lot in tech. Let's see if we can make it a happy chat app by adding Firebase. In the bottom right, you see the Firebase console. This is where you manage all of your Firebase projects. I've already selected the 0-to-app project, which is going to be the backend for all of our apps today. We've also already taken the configuration data and added that to all of our apps. And that means that these apps can now find the Firebase project. Thank you. So Alfonso took Google Services.json and added it to Android Studio. Mike took the info plist, added it to Xcode. And Kat took the snippet of JavaScript and added it to her web project. With that, all these apps are ready to connect to their backend. We've already included the SDKs in each of them. So we added the Gradle dependency, did a pod install, and added the JavaScript snippet. So we're all ready to start writing the actual code. Are we? I think we are. First thing we need to do is wire up the services. So we're going to add some code that looks up a Firebase app and gets the configuration data from the files we added. Then we're going to get the 3 Firebase services we're using today. So we're using the database, auth, and storage service. And these are the main entry points into the Firebase features. If you're using more features, you would just wire up more of these services. That's it. You'll see how similar this is across all the platforms, unless you're only watching the one platform you care about, of course. This is a common thing in the Firebase SDK. We make sure that the SDKs are consistent across platforms. We're going to be using the database. So in the console, I'm quickly going to switch over to the database tab. And you see that we have a very empty database here. Makes sense because, remember, we were all talking to ourselves. You might remember that we were going to use the chat node. So that's what we're zooming in on. OK. Let's make sure the apps are also looking at the same location. If you've used Firebase before, you know what we're doing, but the syntax is going to be different from what you're used to. So we're taking the database service and asking it for the root of the database, and then for the chat node under it. We do that in all the apps. So they're now looking at the same location in the database. With that, we're ready to start sending messages. You remember from before that we were actually showing the message on the local screen when the user clicks the send button. We do that by calling the add message helper function. And it's really just a tiny function that creates the layout elements and shows them on the screen. But we're going to rip that out. We don't need it until probably in 2 minutes. Now we're going to send a message to the database. To do that, we take the reference that we have to the chat node. We tell it to create a message under it. We do that by calling push or child by auto ID. Now we have a location for a new chat message. We're going to take the message that the user entered and send it there with set value. This is all that it takes to send a message to the Firebase database. While the code is compiling, let's think for a moment of all the things we didn't have to do here. We didn't have to check for network connectivity. We didn't have to spin up any background threads, and we're going to be doing networking here. And we also didn't have to do anything like async tasks. This is the easiest you've ever talked to a cloud-based backend. If we now send a message, it shows up in the database. I quickly want to check who was first. Who won?
Cat won.
Cat always wins. Cat is the fastest here. Thanks. Hold on, who were you clapping for, Cat or me, actually? OK, this is pretty cool, right? We have half a chat app. We went from talking to ourselves to all talking to the clouds, which on Wednesday was a challenge, but today there's plenty of clouds for all of us to talk to. So it's chilly here. So let's fix this, because there's nothing showing on the local screens anymore. Let's get the data back into the apps. You'll remember from earlier, our database, we don't request the messages and wait for them to come back. We actually tell the database, I want you to tell me when a new message is added to the chat node. And when that happens, the database fires a so-called child added event. With that event, we get a snapshot of the data for the new chat message. So we take the name of the user and the message that they entered, we add it to the local screen. You might recognize our old friend there, add message. We essentially do almost the same as before. Remember, when we click the send button, we would add the message to the local screen. But now instead, when you click the send button, we send it to the database. And when the database tells us that there's a new chat message, we add it to the local screen. We essentially added a little loop through the cloud. If we run this app, all the messages from the database show up on our screen. Notice how little code this was. Also notice that the existing messages show up straight away. So child added fires for all existing data instantly. But when we add a new message, it's added to the database, and child added gets fired again, and the new message shows up on all screens. I think we have a pretty basic chat app working there. But wait, these are mobile applications, right? Firebase does a lot of things that you might not even realize here. For example, let's say that Mike is on the BART going home tonight, and the train goes into a tunnel. Mike, are we going to cut the Wi-Fi?
I like to live dangerously.
Let's try this. This was the most debated thing about our talk. So Mike is in a tunnel. He doesn't have network connectivity, because not even in San Francisco is there cell coverage in a tunnel. OK, so Kat and Alfonso can continue chatting. Their messages will show up in the database and on each other's screen. But their messages don't reach Mike. You also notice that Mike's message doesn't reach the database. That makes sense. But it does show up in his own screen. So his child edit event is being fired already. And this is great because it means his app stays responsive. There's no error message about not having a network connection. This is all hidden from you. It just does what the user expects it to do. The messages are kept in memory and are queued up to be sent to the server. So when Mike comes out of the tunnel, I think I see light, Mike. I think I see light. Head for the light.
I'm trying.
OK. Fingers crossed, everyone. We need the network to restore. Mike's messages were sent to the server and sent to Kat and Alfonso. And the messages from Alfonso and Kat showed up on Mike's screen. He didn't write any extra code for this. Just those works out of the box. This is a common thing with Firebase APIs. We make simple things simple. We hide a lot of the complexity for you. Let's switch back to slides. Can we switch back to slides? I really hope so. Cool. So in the past, what was it, 10, 15 minutes? We've created a minimal chat application. It doesn't really do a lot yet. And if you want to learn more about our real-time database, I highly recommend that you check out the YouTube recording of a talk yesterday, deep dive into the real-time database. There's also, if you want to be more hands-on, there's code labs that we're hosting outside. You'll easily find them if you get out of the amphitheater, turn left or right, and you'll see a ton of computers. And Googlers ready to help you. So with that, you'll be pretty well prepared to write your app over the weekend and show your team on Monday that you're at least not at 0 anymore. But they'll notice one thing straight away. Because I've been calling them Alfonso, Mike, and Kat. But the app calls them Android, iOS, and Web, and that's not very friendly. So we want to use their real names. And in order to do that, they need to sign into the app. And Alfonso is going to tell us more about that.
Right. Thank you, Frank. So going back to our application, in something like 10 minutes, we built an application where Frank, Mike, and Kat can already send messages to each other, and they get synchronized in real time. This is already pretty amazing, but it's got two fundamental flaws. First, as Frank just mentioned, the application is anonymous. And if, for example, someone downloaded your application for Android, their messages would be sent for the username Android, which is not very compelling for a chat application. Second, Kat could go ahead now and edit Frank's messages, because they're not secure. Also, Mike could go ahead and impersonate Kat, and there's no security enforced to protect from that. So we need a login system to help us solve these problems. In the next few minutes, I'm going to show you how to use Firebase authentication to get your users signed in very fast to your application, without any knowledge of all the intricacies that authentication requires. At the same time, we're going to see how to solve the two problems I just mentioned. On this year's I/O, we released a new version of Firebase authentication with a revamped set of APIs, some exciting new functionality, and built on top of Google infrastructure. Let's see what Firebase can help you do. With Firebase, you can get your users signed in using multiple options, from Google login or Facebook login to your own email and password accounts. No matter what sign-in method you use to get your users signed in Firebase, we always create a unique user record that represents them in your database. This is what we represent at the bottom of the picture below. Also, as a new update this year, something that many of our Firebase customers asked for, now Firebase users can have more than one sign-in method attached to the same account. This is very useful, for example, if you want to let your users sign in with Twitter, and later on you want to attach other credentials, such as an email and password account. Now both are stored under the same user record. With this, we've got the basics, and now let's actually build an application that can get our users signed in and personalize the experience for them. Let's switch to the console. The first thing we need to do is we need to go to the console and enable which sign-in methods or sign-in providers we want to enable in our application. For this demo, we're going to be using email and password, Google Sign-In, and Facebook login. OK, once that's enabled, we can actually go ahead and write some code. So for this demo, we're going to be using different sign-in methods in each of the screens. If you look at the Android screen, we will be signing our users using email and password accounts. If you look at the iOS screen, we will be using Facebook login. And if you look at the web screen, we will be using Google Sign-In. And we're going to be writing the code in 2 steps. As a first step, we will be getting our users' credentials and signing them in your application. The key function call to look for here is sign in with email and password in the case of email and password, sign in with credential, which takes the Facebook token in the case of iOS, and sign in with pop-up in the case of web, which signs you in with Google. And with this, we will already be signing our users into Firebase. But we need to do something else in order to do something useful with this. We need to detect when our users sign in to our application. The way you do this with Firebase Auth is very similar as what we did in the Firebase database. We're going to be listening for changes in the authentication state of your application. And when an event triggers, we're going to react to the event and update the user interface to personalize it for our user's username or email address. And with that, we're ready to run our applications and actually get our users signed in.
Not myself.
OK, so we can see how now some of our users have a username. We already personalized the experience for our users, which was one of the 2 problems we wanted to fix. And this took us something like 3 to 5 minutes. If you've ever implemented a sign-in system for your application, you will appreciate the sheer amount of building and debugging effort Firebase saves you. You don't have to break your head with complicated auth flows or any of these other things. There's also another problem we wanted to fix, which is securing access to our database using Firebase. For that, I'm actually going to refer you at the end of my section to another talk that really explains this in detail. Also, some of you in the public, I'm sure, will be thinking, these guys are pulling our leg. They implemented part of the authentication system, but they actually hid all the complicated parts of building your own UI, interacting with third-party signing SDKs, and all of that work. Well, for that, I'm also going to refer you to another talk at the end of my section, in which we show you our newest open source components that help you do all of this with a great UI with a few lines of code. So with that, we actually built an application, and we got our users signed in. But in order to actually present this to our boss, we actually should probably test and ensure that everything is working. So for that, I'm going to go back to the console and see if our users are created. We built the users panel in the Firebase console to help you, especially when you're starting to build your authentication system for your application. Here, you can see the user accounts that have been created. And you can also create and delete test accounts that will greatly help you debugging your application. And with that, let's switch back to slides. With that, we've actually built our sign-in system. But there's many other things that Firebase Authentication helps you with that I'm eager to tell you about. Sorry. All right. Session management. Your users hate signing into your application. If every 2 or 3 weeks you tell your users, now you have to sign in again, I guarantee you one day they will not come back. So you want to keep their sessions alive for as long as possible. At the same time, however, if a user's device gets stolen, you better clear the session and not leave it open. This is very tricky to handle on your own. But I'm very happy to announce that the newest version of Firebase Authentication automatically handles this for you. No line of code required. Password resets. If you support email and password accounts in your application, your users will forget their password. And what are you going to do about it? You're going to create a one-time code. You're going to email this code to your user. And there you're going to have some UI in which the user has to enter the code and somehow change their password. And this, once again, is a pain. With Firebase, with one line of code, we trigger the whole password reset flow. We send an email on your behalf, which you can fully customize to better match your app's branding with your own email and whatever you want. And we also, optionally, host your own UI for resolving password resets under your own domain using Firebase hosting. This is also very easy and saves you a lot of time. And finally, anonymous accounts. With Firebase, you can create user records which actually don't have any credentials attached to them. These are very useful if, for example, you're building an application where you want your users to start storing information into a shopping cart, but you don't want to ask them to sign in yet. Later on, when they check out, then you ask for their credentials. And you can attach those credentials to the already created user record. This way, all the data for that user will already be there in the database, and you don't have to handle any data migration or anything like that. Again, this massively simplifies your life. You should definitely check it out. And these are some of the features that Firebase offers to make your life easier and get your users signed in with lots of ease, with very easy. If you want to learn more of how to secure your users' data using Firebase authentication, check out the key to Firebase security, which is already in YouTube. If you want to learn more of how to build a full authentication system for your application, all the UI, with best practices and with as few as 10 lines of code, check out Best Practices for a Great Signing Experience, which we'll be hosting today at 1 p.m. And with that, I'm going to leave it to Kat, who's going to help us take our application to the next level.
Thanks, Alfonso. So now we've used authentication and the real-time database to build a basic chat application. But what if I want to share a picture of the weird fruit I ate last night? If it was strawberries or bananas, I could use emoji, but this was an orange spiky fruit with green insides. This is where Firebase Storage comes in. With Firebase Storage, the new feature, you can select an image, pick a file name, and just upload it. And if you're a fan of the real-time database, you're probably thinking, yes, oh my god, I no longer have to base64 encode my images. And if you're coming from Google Cloud Platform, you're probably thinking, wait, I thought I already had Google Cloud Storage. Yes, Firebase uses Google Cloud Storage, which means when your app grows, we'll scale with you if you're uploading large files or a large number of files. It also means that you can do cool integrations, like use the Vision API from Cloud Platform to detect when an image of food has been uploaded, and use Kubernetes to add a filter to it. By using Firebase, you get the power of Google Cloud Storage with a simple API, and you don't even have to write backend code. This means you can focus on developing the features you want to focus on, to share photos, videos, audios, documents, whatever files you have. You can even use it for application data backup for your users. So how can we actually add photo sharing to our app? Let's get down to the code. Here, we're first going to create a reference to the folder we'll be uploading to. This, if you're familiar with the database, is very similar to how we created a reference to the chat node. We're selecting here the chat photos folder. Then, once a user selects the image, we'll go ahead and create a reference to where we want that file to live. And we'll just go ahead and upload it. Now, if only there were some way I could magically let everyone in my app know of all the file names as soon as they were uploaded, I would be done with my photo sharing feature. Good thing we have the real-time database for that. So we're going to add one more piece of code which checks when the file has been uploaded. And when that happens, we'll go ahead and grab the download URL and put it in the text box. This download URL is a public URL. That means anyone who has it can download my image. But it's unguessable. That means even if you know I've downloaded and if I've uploaded and stored the file kittens.gif, you won't be able to access it unless I let you to. So let's go ahead and run the code and see how this works. We'll select an image, upload it. That'll give us the URL to put in the text box. We'll hit send, and that'll use the real-time database to transport it to all of the other devices. And on each one of these devices, when we detect that we've been given it an image, we'll go ahead and display it as such. It's just that simple. So what else does Firebase Storage give us? Let's go back to the slides. We'll help you deal with user access. By default, we'll check if your users are logged in with Firebase authentication, but you can configure this however you would like. You can make it so that each user has their own private folder that they can read and write to, or you can make it such that only images can be uploaded, and they have to be less than 1 megabyte in size. We'll also help you deal with network failures. And so when Mike heads into the mountains and hits those areas of spotty connectivity, we'll go ahead and continue the upload once he gets connected again, so that his files get to Firebase storage and shared across the app. And if you're interested in learning more, you can go ahead and check out our code labs today that Frank was mentioning, and I highly recommend checking out the key to Firebase security to secure access to your files that Alfonso mentioned. So, Mike, what do you think of our app?
I think your team's going to love it. Thank you. By building your application on Firebase, you've saved yourself and your team valuable time and money. And when your boss or your team member asks you those they think they're tricky questions on how you identify and authorize your users and what happens when your app goes offline, and more importantly, will it scale to production, you'll have a single answer: Firebase. With Firebase, your team is able to focus on building the killer features your users love. But the integration doesn't end with the developed products. Firebase is a suite of integrated products designed to help you develop your application, grow your user base, and earn more money. And Firebase products are backed by Google infrastructure, so Firebase scales as you scale. This ensures the app you demo Monday morning goes into production on Friday and scales a year from now. And if you get stuck along the way, we're here to help. Firebase has a number of other tools that will keep you moving quickly. Our high-quality developer docs teach you the essentials and provide actionable steps with lots and lots of sample code. An integration with Android Studio puts Firebase directly in your workflow. Just update to the latest version of Android Studio, and you can drag and drop those same examples and run them live. And lastly, if you have questions that the docs can't answer, have a feature request, or just want to talk to someone on our team, we have high-quality free and paid developer support. I actually see all these people who I know answer questions on the Google group, answer the support questions that you ask, and we're very active on Stack Overflow. And lastly, when you go home and go from zero to app, reach out to us and let us know what you build. We love to see what you've created. Thank you all very much, and enjoy the rest of Google I/O.
Hi there, I'm Timothy Jordan, and I'm glad that you're still here on the Google I/O 2016 live stream. Stay here between sessions because we're going to have great conversations like this one with Jamal Eason, a product manager on Android Studio. Jamal, Android Studio 2.2 was announced and launched today. Can you give us the highlights? What are the changes from Android Studio 2.0 that are going to make the most difference in a developer's experience?
Well, there's three key things. First, we talked about new testing tools, and so the new test recorder is a really amazing feature. Got a lot of excitement from the developers.
Yeah.
Number two is about the new layout editor. So it actually introduces a new layout. So instead of worrying about all the different nested layouts, you have one flat layout that's actually more performant and more dynamic. And number three, enhanced C++ support. We've already had great editing support already. Now we support hybrid debugging and support for NDK build and CMake builds.
That's really great. I think one of the things that we've been hearing from developers for a long time is more C++ support. It gives them a stronger ability to build cross-platform and make sure that that code that they're building can apply more to their Android apps as well.
Absolutely, absolutely.
Yeah. In fact, especially game developers have been asking that as well. I can't wait to see what they'll do with it.
Absolutely, yeah.
So what are the next steps for Android Studio?
Well, today is a preview release.
Okay.
And so we're looking for people to download today and give us feedback. Mm-hmm. So as we typically do, we have a canary release today, and we'll soon launch a stable release this summer. And in that time period, we're looking for feedback from developers about what they should use and what they like about the product.
Great. Is there anything else that developers should do besides downloading Android Studio 2.2 and giving us feedback?
I think that's it.
That's it. Jamal, thanks so much for joining us today.
Not a problem.
Where are we actually?
Okay, glad you asked, because I did think a little bit further than you, since you've started driving and you've no idea where you're going. I thought since we went to the Boozer in England, we could this time continue the trend, but go to a vineyard.
Ooh,
yes.
that's...
Keep it classy. See now, look at this, right? I kind of feel like, yeah, all right, like we did the pub before back in England, but I do think this is a slightly better view.
How qualified do you feel?
Not at all.
Yeah,
I know you're going through this. I know it's red or it's clearish kind of colour.
It's nice and it's not nice. It's one of those very binary with my wine tasting.
And I have an upper limit of about £5 or $8, and if it's more than that, it's probably not worth it. Anyway, right. So since we're here,
yes.
we tend to talk about the web, and today I think is no different. I want to talk about libraries and frameworks.
Ah, yes, because you're not big on the frameworks, are you?
No, and neither are you.
And on the other hand, I am not big on the frameworks.
Yeah, so I don't think there's going to be much of an argument, but I do want to talk about it because it bothers me that I perceive that the default state of developers is, I've got a blank page here, how am I going to fill it out? I need a framework. Which one do I use?
That is a problem I have with frameworks, that they have a way of starting projects. Like there's a kind of expectation to use them from the offset. And I think if you're thinking, what combination of frameworks should I use to render this blank page, then I think something has sort of gone wrong. Yeah. For me, it's entirely from a performance point of view. Well, no, it's not actually. But okay, step one, performance. If your page has to load a ton of JavaScript in order to make a request for the actual data it's going to display, you've lost performance.
Yes.
And you can sort of say, oh, but next time it's going to be cached. It might not be. You might have changed the code, busted the cache.
And it's an assumption that somebody's going to come back again. Right?
Well, it's your goal, I would say.
It's your goal, but you don't know that somebody's going to. It's like paying a big, fat, hefty tax on the assumption you're going to get a repeat view. And
That's
you
true.
might not.
That is true.
You might not.
Yep. And stuff falls out the cache all the time.
Yeah, exactly. So
not the service worker cache, though.
Oh, you and service worker. Here we go again.
Service worker!
Da, da, da. One trick pony, Jake Archibald.
Come on, but it's got a cache, you can rely on it.
All right. Okay, performance that notwithstanding, I think for me, it's about code ownership somehow. It's about a level of trust that I don't necessarily feel. And what I want to do is I want to be able to feel like my application code is the thing that's running, that I'm not running through something else that I don't necessarily understand.
Running through something else is fine, because that's what a library is, right? Like you've got you've got hold both ends, and you're running through bits of library that you don't understand.
Yeah.
But that's fine, because if one of them starts misbehaving, rip it out, either code it yourself or find a replacement library.
But when you're going through something else,
well, you're in something else, I think, with a framework. And the framework will vend you little bits of, it'll give you scraps, and then you do something.
Can I have some more? I'd like to work with this application.
Can you please send this data over
here? More? Get out.
But then the frameworks, you're sat in a tiny bubble of the overall application with a framework. And I feel like to get the most out of a framework, you need to understand how the framework is built. Like, and these frameworks are huge, so it's
They
really
are.
difficult to do
I actually feel maybe this is wrong, but it feels to me like it's a kind of, the decision is an ergonomics one. Like a developer's saying, my ergonomics trumps the user's requirements. I want to feel like, my job is easy, and what the user gets is what the user gets. And my whole approach is very much the other way. I'd rather go the extra mile, and all my users benefit, than my life is a bit easier, and I'll take some of the bad performance or the tax of using that framework. So I don't think that frameworks are inherently evil and to be avoided, but I think you want to be able to transition to one and say, yeah, now it feels like we're getting to the point where we're going to reinvent that. And I think you can only do that when you've got to a certain point with the build.
So for you, it's start light, start with libraries as when you need them, and then make the jump to frameworks only if you have to.
Agreed.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right? And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of Service Worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the Service Worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support Service Worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of like actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get like a really good first paint, even in like Safari and like mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, like super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into the sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
there's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I roll.
Pretty much. Impact. That's worth checking out.
That's the format of this show.
It's a mediocre article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about AppShell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
Yep. And in that article, we also link out to tools that can help you get started with the application model really quickly that we're working on. So check that out.
Yeah, build a weather app.
Firebase makes authentication easy for end users and developers. Most applications need to know the identity of a user so they can provide a customized experience and keep their data secure. Firebase supports lots of different ways for your users to authenticate. If your users want to authenticate with their email address, you can build that for them. Firebase Auth has built-in functionality for third-party providers such as Facebook, Twitter, GitHub, and Google. It can also integrate with your existing account system if you have one. You're given the choice about how to present login to the user. You can build your own interface, or you can take advantage of our open-source UI, which is fully customizable and incorporates years of Google's experience in building simple sign-in UX. No matter which one you use, once a user authenticates, 3 things happen. Information about the user is returned to the device via callbacks. This allows you to personalize your app's user experience for that specific user. The user information contains a unique ID which is guaranteed to be distinct across all providers, never changing for a specific authenticated user. This unique ID is used to identify your user and what parts of your backend system they're authorized to access. Firebase will also manage your user's session so that users will remain logged in after the browser or application restarts. And of course, it works on Android, iOS, and the web. That's Firebase Auth, allowing you to focus on your users and not the sign-in infrastructure to support them.
Hi, I'm Timothy Jordan, and this is The Developer Show on location at Google I/O 2016. And I'm here with Noah. We're going to talk about Project Tango. I'm still overwhelmed by how cool Project Tango is.
Absolutely, blurring the lines between the real world and the virtual world.
Now, there is a Project Tango game that people are playing with here in the sandbox called World. Can you tell us a little bit about it?
So this is a game that's being done by a new company called Phenomena, but with some very old and experienced game developers, including a designer called Keita Takahashi. Mm-hmm. He worked on a game called Katamari Damacy. And it's
an awesome game.
Oh, just great stuff, but very playful approach. Mm-hmm. And he's brought that to World. It's a game where you can actually set up little things in a virtual world that are situated in the real world. So as you move around with the Tango device, you can actually see them from different angles and set them up on the real walls and floors of your room.
Now, you were telling me a little bit earlier about the first steps you take into the game. What is that like?
Sure. Well, at the beginning, one of the things that you do, for example, is you're given a little seedling, and you can plant that in the ground, and then perhaps on a nearby wall, you can take a cloud, but the cloud is actually on a spring, so you put it on the wall, and it goes boing, 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 and you can click on the cloud, and it starts raining, and suddenly the seed will sprout and turn into a flower. So it's stuff everybody understands intuitively, but then you can play with the stuff, put the flower on top of another flower, have them start rotating, make them bigger or smaller. Mm-hmm. The whole thing just sort of opens it up as a playground for you to try.
Something I've heard you talk about before, which I really love with Project Tango, is the ability to make any space a play space, which seems to be evident in this game.
So one of the great things is that you can use the Tango device to actually have it be a sort of a magic window into a virtual world that you create or that's been created by the developer, so that as you move it around, it's as if you're seeing right into this other space that isn't even there.
That's really cool.
It's great stuff.
One more general question for you. What is your favorite thing about being a game designer and developer?
Wow, I think the best thing about being a game designer is that you get to make things that you enjoy, that are fun, that please the rest of the world. You know, it's pretty much like other entertainers, just a lot more nerdy than being a rock star, for example.
Awesome. Thank you so much, Noah.
All right, thank you, Timothy.
Hey there, Polycasters. Rob here. Welcome back to the show. As we've been working on Polymer, one of the probably biggest requests that comes in from developers is, when are we going to get a CDN for Polymer and for web components? Because it's kind of a pain in the butt every time you want to sort of like hack on an idea, and you've got to use Bower and install a bunch of packages and wait for everything to download just so you can, you know, play with stuff. So recently, the Polymer team has put out a brand new project, which is called PolyGit. It is a development CDN, which I'll talk about what that word means in just a second. But basically, it is a CDN that includes Polymer, all the Polymer elements, and the web components polyfill. So if you want to hack around using something like JSBin and Polymer, you can totally do that. So if you go to the website polygit.org, you see that it bills itself as the Polymer Magic Server. And what it's actually doing under the hood is it's just using GitHub's rawgit CDN and extracting things from there and pulling them into, you know, JSBin or wherever you want to use the CDN. So what I want to do here is just sort of like show you some examples of how you can use the CDN, how you can configure it to actually pull in your own packages as well, and basically just get hacking really quick. So over on jsbin.com, I've already set up this little sample bin. And the main thing to notice here is I'm using this base tag right here. And if you're not familiar with a base tag, in HTML, a base tag or a base element, it just allows you to set a URL. And then any sort of subsequent URLs that you use, like for script tags or imports, they will all be relative to that base. So what we're saying here is we want the base URL to be polygit.org/components. This components directory is where Polymer and all the Polymer elements and all that good stuff lives. And from here on out, if we have any relative URLs, it'll just pull stuff from that directory. So I'm pulling in web components.js. It's coming from that directory. I can import polymer.html. That'll also come from that directory. And so since we've got all this working off of our CDN, now we can actually sit here if we want. We can just create our own Polymer element right on JSBin. So I'm going to do that, write out a DOM module here. I'll give it an ID of like xfoo. And I'll give it a template that just says like, hello from xfoo. And I'll also give it a little script tag. And inside of here, we will call the Polymer constructor. And we're going to say it is an xfoo element. And then the last thing we want to do is we want to just make sure that we use our xfoo tag somewhere in the page. And now you can see it showing up over there in our output. So this is really great if you're, you know, hanging out on the Polymer Slack channel, you run into a bug or some issue and you're not quite sure how to explain it to folks. You can just go throw together a JSBin using PolyGit and then share that JSBin with people so they can help you get unstuck. Now, I also mentioned that all the Polymer elements that we built are included in this CDN as well. So what you can also do if you find maybe a bug or an issue with something like paper tabs is you can go over here and you can just write an HTML import for paper tabs. So instead of just Polymer, I'll also pull in paper tabs. And then you can just start using that element in your page here. So I'll say I want a set of paper tabs. And then inside of here, I will write out maybe like 2 or 3 paper tabs. So we'll say this first tab is called foo. Second one is going to be called bar. And the last one will be baz. Foo, bar, baz. And there we go. Now over here in our output, I've got these 3 paper tabs working just as I was expecting. And you know, if I had some issue, I could then take this, I could save this JSBin, I could go file a GitHub issue and point the engineer at this particular JSBin. And that way it's going to help them triage that issue a lot faster and help them debug the actual problem that you're running into and hopefully get things fixed. Now, one of the coolest things about PolyGit is that it is configurable. So not only does it pull in Polymer and the elements that that team has created, but you can add your own GitHub repos to it as well. So if you go back to the polygit.org website, you scroll down here to the bottom, you can see that there is this sort of interesting configuration syntax. And it might look a little weird when you first see it. It took me a few times kind of working through it to understand what it's doing. But basically, what you want to do is when you are defining that base URL, you can configure it by saying, oh, I would also like to include this component. And this component might live like inside of some particular org. And maybe you want a particular version, like version 1.2.3. Or maybe you want a branch, right? Maybe you want like the master branch. That's some good handwriting right there. Or maybe you want just the latest tag. So if you include an asterisk, instead of pulling a particular version or a branch, it'll just give you whatever the latest tag happens to be. So to show you an example of that, I've again got a little JS bin here. And I'm just going to paste in a better URL here. So what I've done is I've configured Polygit to pull in 2 additional dependencies. The first is the markdown.js library, which is in the chjj org on GitHub. And I've told it to grab the latest tag. And I've also told it to pull in the mark-down element, which is something that I wrote myself. That lives in the Rob Dodson org on GitHub. And again, I've just told it to pull in the latest tag there. So now both of those are available in that CDN components directory. So I can just go ahead and write an HTML import to pull in the markdown element. And then over in my body, I can just start using it. So I can have a markdown tag. And we'll just drop in like a hello world for the header there. And we can see we're getting this sort of like huge H1 rendering over there in the output. So if you're working on an element or a project or something like that, and you want to show that to folks on JSBin, you can absolutely do that using Polygit as well. The one caveat there is that it has to have been published for at least 1 hour for it to be picked up by the rawgit caching CDN. But once it's been published for about an hour, it should be available to you on Polygit. Now, the last thing I want to mention here is at the very beginning of the show, we said that this is a sort of development time CDN. And what I mean by that is it's not a CDN that you want to use for production. And the reason is because we're not doing any sort of like vulcanization or anything like that to optimize the elements that we're sending down. Instead, you're getting an individual dependency for everything that you import, which is actually pretty expensive in terms of HTTP requests. So it's great for development time. It's great for hacking on ideas. But when you get to the point where you want to launch something into production, you still want to use a package manager like Bower. You still want to use a process like Vulkanize to make sure you're sending down the absolute smallest payload possible. But if you just want to mess around with some ideas, it's perfect for that. So that about covers it for today. If you have any questions, please leave them for me down in the comments. Or you can always hit me up on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time.
Welcome back. We've covered a lot of ground already, so today I want to review and reinforce concepts. To do that, we'll explore 2 things. First, we'll code up a basic pipeline for supervised learning. I'll show you how multiple classifiers can solve...
Come on. 5,000. God damn, Annie.
I've been a star, holding a light up in the dark, while I try to keep clear of all the waves in your atmosphere. All my life I've been a star, holding a light up in the dark, while I try to keep clear
Yeah, you're gonna push me out? I like the big, look at this, yeah. Damn it, I've done bookstore.
Oh, oh, yay. Hi.
Hi, Dan.
Hi, Chris.
So,
oh, okay.
Every pour, every single pour.
It's amazing.
Yeah. Hi, everybody. I'm Chris DeBona, but you're not really here for me. You're here for our friend Dan Lyons. So, say hi.
Hi, that's terrifying. Thank you. Thank you for coming. And I don't know if can we do questions or not really, right? We'll talk.
Yeah,
okay.
Talk, yeah.
I did a talk at Google Cambridge recently. It was really, really fun, really good. And it was full of, I learned a new word, Greyglers.
Greyglers, yes.
Which is what the people who work at Google who are over a certain age, let's say, are, either they call themselves Greyglers or people call them that behind their back. I don't know, but
No, they've been calling themselves that as long as I've been here. So, yeah, I mean, like 12 years.
And it was a lot of Greyglers because my book is sort of about, being old and trying to work in tech and in a startup with young people. So I had all these like old Google people. It was very skewed, very old, and it was really not very old. I mean, 40. Yeah, there's a guy with gray hair. See, look at him. He's like a Greygler. And it was great. It was really, really fun. It was really a really cool, interesting group of people. So, yeah.
We don't actually need you to like us, but it's nice that you do.
No, that's the other thing. I forgot. I had a little. I opened up my presentation there. So I really just sincerely mean this. Like, I really love Google, and I know people hate Google and think it's like the evil empire, and I've always felt the other way, and my whole life is built around Google products. I realized this recently. Like, I've been using Android for years. Everything on my computer is on Chrome. I have Google Calendar, Gmail. Like, basically, my whole online life is based around Google. And I started out, I should do the same here, by just thanking all these people, because I know it's really hard, and I could never make any of these things that I use every day, and I don't know how you guys make them. But seriously, like Google Maps and navigation and Waze, so my whole life, I realized recently, was more or less based on Google Cloud, I put my photos there. So I do sincerely feel grateful to all of you for everything you do.
I hope we continue to earn that from you, I think I said that earlier with the Android stuff.
For me, there was a moment, I was in Germany several years ago, like 2012, and we were
So I'm so resisting making old person jokes, right? So I'm 44, but so I'm old by your definition. But I was like, so was this before the wall came down, or? Sorry, I just got to get it out there, but
This was when there was still an Austro-Hungarian Empire.
Yeah, the Habsburgs,
Right before they killed the Archduke.
It was fake Franco.
That's my first alter ego. And but we were driving into the Munich airport, and I had an Android phone. I had put a SIM card in it, and I remember thinking, I don't know if this is going to work or not, but we had a reservation at the Holiday Inn Munich airport.
Which are much nicer in Europe. Holiday Inns are much nicer in Europe,
it was still pretty cheap. But anyway, we were sitting at the airport, and we were flying in the morning, so we had booked this hotel at the end of it was the last night of our vacation, and my wife said, we're all stressed out, and the kids are there, and we have to, everything's a rough day. And I said, I don't even know where the hotel is. I don't know where we are. And I said, hold on, I had the phone, I said, navigate to Munich Airport Holiday Inn. And it went, okay, you're on the right road. Well, I was like, oh my God, this stuff works, right? It was amazing to me.
Wow.
And I know that's stupid, right? But it was so
it's not
simple. I remember and I thought, like, how did a bunch of human beings in Mountain View make that happen? How did that, anyway.
Wow.
I feel like the unfrozen caveman, like that. You're crazy.
I'm just a simple caveman lawyer.
It confuses me. Anyway, let's talk about. I'm sorry.
Yeah. You shouldn't apologize.
Yeah.
I mean, they're here to listen to you talk about random things in Europe.
Random things on vacations. No, but thank you.
So, congrats on the success of the book. I mean, you're all New York Timesy bestsellers.
Yeah.
Right.
Yeah.
So one of the things I sort of wanted to ask you is it sort of bittersweet to have a very successful book in print, when print is a medium? I searched my email for the earliest mention of Dan Lyons, both how we first met each other through our friend Erica, but But when I first heard of you, and it was actually in a Google alert, or the equivalent in 1999, I was on the PR Newswire stream. And basically it came down to an article about how Forbes is retracting a bit in their print, right? And so the entire publication has been a redesign slated for a September debut. Smaller, basically, but then they see nice things about what they're doing, but it's a much smaller publication, because it's starting to sort of wane, right? So you write a book. You're like, I know what I'll do. Print's dying, I'll write a book. I mean, do you ever does this ever hit you? And
Not until just now, actually, just now. Thank you for
Yeah,
that. Well, I mean, most of the sales are ebooks, to be honest. I would say the vast majority are ebooks, and I think, and audiobooks. A huge.
Did you record it yourself? Or
Yeah,
did you have
I did it myself. They wanted me to do it because I have this Boston accent, and they thought it would. They like to have the author do their own book, apparently.
Yeah, no, they do.
And so I spent like a week in a recording studio and did it. But those are most of the sales. I think that sells way more than print right now, at least on my book. And the kind of people who would buy this book are probably ebook readers. And I think in some ways, it's a better thing for authors because it's a real impulse buy. You can see something, hit the link, and then bam, download it to your Kindle or your tablet or whatever.
Download it to your tablet, just because you've heard of it here. You see what I'm trying to do?
Yeah. Sorry. But I mean, I think there are a lot of impulse buys by people, with ebooks. So no, I think books are still, it's not completely over. But it's it's a tough bit. The book business is obviously
Really
challenged.
Yeah. So, I don't know how many of you have read the book. Just raise your hand.
Oh my God! Yeah.
Live streamers, raise your thumb. Whatever you do. So it was in fact sort of the trials and tribulations of print that led you to go to HubSpot, which is the subject of the book.
Right. So, in a nutshell, it was that I went from Forbes to Newsweek, and I knew Newsweek even when I joined, which was 2008. I knew they're not going to be around forever. But I really wanted to work at a place like that before the media business completely blew up, because I had very high regard for Newsweek and what they did, and the people who were working there were fantastic journalists. It was really, honestly, I would pinch myself when I would walk in there and see the people I was working with. And so I got laid off, and I thought not only was my company kind of going out of business, my whole industry was going out of business. And
heartbreaking, really.
It's very, very sad. Yeah. So and I have young kids. I have twins who are now 10. They were 6 or 7 then, and I thought.
And you were about to go on a trip that was going to be so much fun.
We're about to go on this big vacation.
To Munich.
Yeah, that trip that I was talking about, and I thought I have to do something. I have to start a new career, but I'm 50 years old, and I mean, it's not that big a leap. You can go into public relations. A lot of journalists do that. And at the time that I was looking at this, there was this big trend. It's still kind of going on. It's kind of played out, though, where companies were hiring journalists to build their in-house newsroom. So they had, Intel, Oracle, Microsoft all have little news operations. Qualcomm has one. And I thought, I could get in on this corporate journalism thing and maybe start a new career out of that. And that should have a 10 or 15 year run. As it turns out, I don't think it's really working out. A lot of journalists who have gone for and VC firms are big ones. They're all hiring like their pet journalist who then writes about the industry in a way that kind of benefits their worldview, right? And Andreessen Horowitz is probably the best at this. They have this incredible operation. They have basically a content factory with podcasts and analysts and the whole thing, and they will churn out stuff to their advantage, I guess, right? So it's sort of quasi-legitimate when I thought, there were no other good journalism jobs. It wasn't like I called Time. A lot of Newsweek people who had left landed at Time, and I called them and they're like, sorry, but I thought, okay, but no, but they were like, no, done. It's like musical chairs in the media business now. Everybody is clinging to their jobs, and every year there's a fewer chairs, and people my age are just getting spun out. So. And I read all these stuff about reinvention, and you could start over and be a lifelong learner. And I thought, that's very exciting. I'll do that. And I always wanted to work at a tech company because I thought covering tech companies, you get very jealous of the people you're covering. And you think, man, it's like being a kid with your nose pressed against a glass, looking at this fantastic world. Yeah, like you go in and you talk to them, but you never really find out what it's like behind the curtain because it's all stage managed and PR. But I thought, it always looked like so much fun. I had friends who went to Microsoft early on, had a really good time. Yeah, so I went to work at a little company. Instead of going to a big tech company, I went to a little one in Cambridge called HubSpot. And
really close to where you were living. I mean, it must seem like a dream. You know?
Right. So I lived in Boston. So that's the other problem. It's like, well, what tech company? We're going to have to move, and that was kind of disruptive to our family. And I like it out here, but anyway, I happened to get lucky and found a place right in my backyard. So I thought, okay, that's a good, easy step, and it's a younger, smaller company, so maybe there'll be more opportunities. It'll be growing. They haven't even gone international yet, so there's all this growth ahead of them. So that might be a good place to be.
So was it in your HubSpotter? What did they call themselves?
HubSpotters.
Yeah, because
they were very much influenced by Google. So they wanted to be HubSpotty, like you guys talk about being googly. There's a googly way of doing things. There's a HubSpotty way of doing things. We had those. What do you guys?
Something you need to clean off like fabric, like with those Tide pens.
Yeah, yeah, exactly. It's HubSpot.
Oh, you got a HubSpot on you.
Oh, you. I do have one. And then they had what is the thing you guys have for quarterly evaluations or annual evaluations?
So we have the whole 360 evaluation.
No, but it's like not KPIs or DRIs.
Oh, OKRs.
OKRs.
Yeah.
So at one point they said,
key results.
Yeah, we're going to have OKRs just like Google, but they didn't really know how to do it. But they were like, well, Google does it, so it must be good. Let's try doing that.
And we got it from someone out of Intel.
It was John Doerr, right? Wasn't it John Doerr?
It was one of those guys. Yeah. But he put it across the valley and everywhere.
So we tried. Yeah, so we had all this stuff. So that was really cool and foreign to me, but it was like interesting to learn about it. And so yeah, that was the idea.
So you're in this thing, and you said this in the book. You said, look around the room. A year from now, a lot of the people around you won't be here anymore. Did they really go down this road?
There's a lot of brainwashing. So it's like very culty. And so, journalists tend to be very cynical. And it's the culture from one newsroom to another sort of is the same. If you meet journalists from wherever they are, they generally all kind of, it's a tribe. And
they like drinking the brown water,
Yeah.
Whiskey.
They're all negative and cynical. And like that was the thing I couldn't get used to at HubSpot. Everybody's so positive and so upbeat. At one point in the meeting, I was like, you guys are all so cheery. Like, I just can't stand it. And they were like, well, would you rather be with like negative, angry people? I was like, yes, dude, that's why I spent my whole life with negative, angry people.
The whole world is
like negative, angry people. Yes. So it's very relentlessly upbeat, but we had training, and the training was like supposed to learn how to use the product, but it really was like, you don't know how special you are to be here. Like thousands of people competed to get this job that you have. It's harder to get in here than to get into Harvard. That's how exclusive it is here. Now, they're all right out of college, and they're young kids, and they're all, like freshly scrubbed, and they're like, okay, I'm gonna do it. And they're like, but this is only half. The next step is whether you can make it here. And like, half these people aren't gonna be here in a year. That's how hard it is. And I'm just like, old. We went around, they said, talk about what makes you special. Let's all introduce ourselves. What's your superpower? They used to talk about having superpowers and being rock stars and engaging in delightion, which meant delighting customers
so
and stuff.
That's how you pronounce it, delightion.
Delightion.
It's
like delight turned into a noun. Delight is already a noun. Delight is a noun, but then they made another noun, delightion, which is the process of delivering delight to people. I don't even know. No, I don't think it's a gerund. Anyway, so they went around, they're like, what makes you special, unique? And I'm like, I don't know. I'm the only one in the room that's had a colonoscopy. I
know what my PSA level is.
I have high cholesterol. I have to take a statin every day. I take Lipitor. Because they're all like, people don't know this, but I play guitar. So I was like, oh, great. So it was like,
I own a corgi.
Yeah, the main guy, the training guy, his thing was he played in a rock band, a heavy metal, a hair metal cover band on weekends. I was like, oh, cool. And then the company would hire his band for like every event. I think they got them for free. So we had the same hair metal band at every corporate event, playing the same songs. And
was it like mostly Duran Duran covers?
No, yeah, it was awful. It's just really bad. But he's a nice guy, so I should say he'd probably watch this now and hate me. So it was like that. It was
filled with nice people. I mean, it's no matter where you go. I mean,
no, they're nice people, but
mostly. Somewhat.
Just very chaotic and disorganized. And so the long story short is I did this thing, it didn't work out. I realized after a while, I don't belong here, and I really should just be a journalist or do something, and that's really what I had to do. And then halfway through it, I got this call out of the blue to go work on Silicon Valley, the TV show on HBO, and I was like, it was like going from the Steve Jobs line about the ice water to people in hell. It was like that. It was like, oh shit, I was at the Adobe digital marketing summit in Salt Lake City. I was going to kill myself. I'm seriously thinking like, if you commit suicide in like Salt Lake City in a hotel, like in a Marriott, I don't know, it's kind of a horrible way to die. It doesn't leave, but I'm thinking, okay, I'll do it.
And a little bottle of 3-2 beer.
Yeah, I got a bottle of Ambien. If I took it all, probably could do it, right? I don't think that's a cowardly way out, right? You got to do it, So,
but I'd imagine the Marriott has like a special elevator for all the suicide victims.
Suicides. Yeah, they get you out the back. So I'm like, I seriously sitting there thinking like, this is the worst moment of my life. This is as low as my life has ever. Like 6 months ago, 8 months ago, I was working at Newsweek interviewing like really cool people, and now I'm like here. And I got this call saying, do you want to work on a TV show? Because I had developed a show based on Fake Steve back in 2010.
So Fake Steve Jobs, I don't know if you're old enough to remember Fake Steve Jobs.
See, one guy, yeah. So I did this Fake Steve Jobs blog.
Namaste.
But people don't know this, but I wrote a book based on Fake Steve Jobs that nobody bought. And then, it got developed. A guy from Curb Your Enthusiasm, the guy who made Bruno and Borat, Larry Charles. He read the book and he was like, oh, I really like this, let's do a TV show. So I worked with him and we developed it. We sold it to a cable network called Epix. We wrote all these episodes and then it never got shot and it kind of all just died away. But then the Silicon Valley guys, the main writer in Silicon Valley was also on Curb, and those two guys know each other. So when that show got picked up, Alec Berg. Yeah. So Alec Berg, and I had meetings with him about Fake Steve that never worked out. But so he said, oh, come out and work. Do you want to come out and work on season 2? So I worked on season 2 and then on season 3, which is the one that's airing now. I did go back to HubSpot briefly after season 2, but just for a couple months. It really went downhill fast. But I had always wanted to see this. You know the story people tell, like every friend of mine who works in corporate America has a story of either they did this to someone or had it done to them or both, where the company doesn't want you anymore, but they can't fire you, or for whatever reason they figure they can't fire you, so they have to just make you miserable so you'll leave. Like just make your life worse and worse and worse and worse, so finally you just go, right? And they started doing that to me, and I was like, this is awesome, right? Like, this is so cool. Like, I had this crazy boss who had been like a really good friend of mine, but clearly had got the message, like, no, he's got to go. And I was like, every day I would come in like thinking, like, what is he gonna do today? Like, this is so amazing. Like, what crazy?
Is this when you started bringing Molly into the conversation?
No, that was earlier. There was, that was a moment when I knew I didn't fit in. So a few months in, I had we got a message that the co-founder, the CTO, had written this big article about management for LinkedIn. He's a LinkedIn influencer, and this is our.
We're not really going to take questions from the audience, but
the Gopher.
This is the Gopher. I'm sure you're familiar with him.
So you can find this article if you look up online, Dharmesh Shah, and the headline is "Your customers are not selfish, ignorant control freaks," something like that.
That's what leadership is for. Yeah.
And his point was that he had come up with this great breakthrough, which was you should bring a teddy bear to meetings. He was bringing a teddy bear to meetings, and the teddy bear would sit in a chair, and it would be a stand-in for the customer. So that in the meeting, you would always be thinking of the customer. You'd always be solving for the customer by having the teddy bear there, right?
I'd like that you address the Gopher when you talk about this.
Because he's the customer.
This is our
and he had a picture. He had a real picture of a real meeting with the teddy bear sitting next to our CMO, right? Drinking a Red Bull. There's like a little Red Bull in front of the teddy bear. The Red Bull looks really. The teddy bear looks really pissed off, and her name was Molly. And
the teddy bear was named Molly, and she was a single mother from.
Well, they had buyer personas. So we had Mary Marketer and we had Ollie Owner, who's a small business owner. So they combined it and made Molly the teddy bear. So I worked with a guy, my boss, who was a young guy. We sat like screen to screen, at a table, like at a desk, and he was pretty cool. He's like he once wanted to be a journalist. He thought he was pretty cynical, and so this article came out, and I leaned around with scared. I was like, dude, did you read that article? It's like, oh, yeah, it was good. It's like, no, but the teddy bear thing. Did you read the teddy bear thing? And he's like, yeah. And I'm like, okay, that's crazy, right? That's freaking nuts, right? And he's like, well, no, startups are kind of, they're kind of, eccentric. And I was like, no, come on, that's fucking crazy to bring a teddy bear to meetings, right? And he was just not going to agree. This guy had worked at Google, right? Early on, right out of school. So I said to him, are you telling me when you were at Google, if Larry or Sergey announced that they were bringing a teddy bear to meetings and it was going to stand in for the customer and you were all going to take it seriously, like nobody would make fun of that, nobody would mock that? Because I think they would put him in an asylum, right? He's like, well, startups are different. But that's when I knew, like, okay, I got to get out of here. Because I called a friend of mine who had been a journalist and went into marketing. I said, is this normal? normal. Teddy bear thing. It wasn't that the teddy bear was crazy. It was that nobody would laugh at the teddy bear. That's what got to me. Like in any newsroom, there are people. There's occasionally some crazy managing editor who might do something like that. But everyone would go out and buy a teddy bear and put bondage gear on it, or hang it from nooses. Or, would do terrible things. Would sodomize the teddy bears. We would just do terrible things to teddy bears to like mock the guy. But nobody did that. Everybody was just like. Yeah. And this is awesome, teddy bears.
Let's go in for Molly.
And when my book came out, the company published a response to some things, more or less. Like the other thing they had was when they fired people, they called it graduation. Which I thought was crazy, right? And they would say, we'd get this email saying, "Hey everybody, just want to let you know that Derek has graduated and he's going to go off. We're so excited to see what he's going to do with his superpowers on his next big rock star adventure." And I was like, you fired that guy, right? Like you fired his ass, like
a ninja. He's gone stealthy into the night.
Yeah, he's going to take his ninja superpowers. Like, and they would say, literally, those are the words. Those are the real words. And you look over, and the guy's desk is empty. He's just gone. He's just vanished. He's just disappeared, and you never knew he was leaving, right? My first week there, I had lunch with a woman, young woman right out of college who wanted to write a book. She's like, "You wrote a book. Can you talk to me about writing a book?" Yes, we go have lunch. She's really great. She had these great ideas about millennials and marketing to millennials. Great. We talked about it. And that night we get an email, I forget it, I don't want to say her name, but anyway, so-and-so has graduated and we're so excited. She's leaving the company and she's moving on to the next thing. And so I called her and I was like, dude, I emailed her, I said, "How come you didn't even mention this at lunch?" She's like, "I didn't even know." Like, she said, "I just got a call saying you graduated, bye, don't come back tomorrow." Like, that's it, see you later. And after my book came out, someone wrote to me saying, she got her first job out of college, she got hired to work in HR, her life dream was to work in HR, which,
no, there are people.
I'm not judging, right?
Nice.
Okay, so
no, like she really seriously like a good HR person.
Yeah, no, right.
Awesome.
And she had all these big ideas. 3 months in, they called her to a meeting and said, "You know what? You just don't seem excited enough. You're gone. Take your stuff and go."
Where's your delation?
And they didn't, where's your delation? Don't even take your stuff. They said to her, "We'll pack your stuff and mail it to you. Just leave this meeting right now, walk out and go to your car and never come back." Right? 3 months in. And then they called her the next day and said, "We didn't realize you have a lot of stuff. You have to come in yourself and get it. It's too much to mail." And so
really
they made her come into this walk of shame with a box and fill it up and then leave, But it was just like, so it's just crazy. And I called this friend of mine who had been at like a bunch of big companies like Cisco and stuff, and then had gone to a startup, and he had done really well at this startup. And he said to me, "Look, this is the secret, the little secret of startups that nobody knows is that they're all like this. They're all out of control. There's no management. Nobody knows what the F they're doing.
They don't have any processes.
There's no management, and it's like."
And it's like 25-year-olds who are like, "Wait, I have a staff of how many people I have to, and what's a budget? What's a P&L?
Yeah. So he's like, "This is normal, just go with it." And I was like, "Okay." So, and then I was gonna leave, and then somebody else said to me, "You're a comedy writer, you're a satirist, and you've stumbled into like this pot of gold. Like, this is amazing, funny stuff." So I realized, I was so wrapped up in like why the job wasn't working out that I never saw like, oh my God, this is really good stuff. And then, like for comedy. Yeah. And then I started realizing, there was actually even a bigger story about, I think, diversity, about what culture fit, what I think culture fit is kind of an insidious thing. I came to think that it's actually a code word for like lack of diversity, but if we celebrate it and call it something good, it sounds great to have a bunch of just white guys in their 20s.
This is
like,
actually why
you know what I mean?
We used to talk about googliness of incoming candidates, and I got tired of it. I was like, no one actually knows what this means. It's just bullshit,
Oh, really?
In some ways. I mean, in the context of hiring, because it's like, it's a way for people to hire people who are like them.
Right.
And it's like, how about you find me somebody who you think is the exact opposite of googly, or the exact opposite of what you are, within the realm of engineering, right? So it's like, it's these terms that they throw around so blithely, and we all chuckle and think it's funny, but in the end, it's like it's people's lives you're talking about, you know? And so much of our lives are spent at work, and it's like, we want a wonderful place to work, but not at the cost of, our humanity. Sorry, I don't want to go off on that.
I agree, and I think, they said that when I first met some of these guys. They said the line that you hear a lot in Silicon Valley with startups anyway, is like, we like to hire people that I'd like to go for a beer with after work. Right? And I think that's a terrible reason to hire someone.
Or finger paint with them.
Yeah, we did finger painting. We had a thing called Fearless Friday. We got this email one day. Do you want me to tell the story? So saying, okay, one of the people on staff had read Sheryl Sandberg's book, and there's something in there about, her advice was do what you would do if you weren't afraid.
Yeah.
Like,
Which is decent advice.
It's good advice.
Yeah.
So she said, next 2 weeks from now on Friday, it's going to be Fearless Friday. We're gonna all stop work for the whole day. That was the other thing. They like the Google idea of the 20% off, which Google doesn't do anymore, right?
No, we do it, but it's honestly, for most people, this means 120% of time.
Oh, yeah. So
actually, I did the math early on in my career. It was like 2007, where I added up like all the tech talks that you could go to and the 20% time and all the rest, and you end up working about 14 hours a week. If you take like all the breaks and all the lunches.
Sounds great.
And I'm like, that doesn't sound like it's real, And,
so it doesn't really.
And so obviously people don't go to every tech talk.
Yeah.
Not everyone does 20% time, or even, I'd say single percentage points. But that's okay. I mean, it's there for them. But reality is our jobs are there for us too. I'm a big believer in doing the job that you were hired to do. I mean, we talked about this earlier, and it's the honor of that. So when things like Fearless Friday come up, and what do you think? You're like, wait, you want me to come to work and not work?
Right, we have to do, the only rule was...
And in a newsroom, they're like, where's the article? This is the deadline, produce.
Unfortunately now in newsrooms also it's become like, you got to hit numbers, you got to get clicks, and you're trying to drive page views, and you're rewarded based on that. So that's part of the reason that this coverage of tech and everything else has become so bad.
That's
and I think
fan fiction,
Well, it's just that if you're working for a tech blog or the New York Times, whatever, if you cover Apple and you're very pro Apple, so you get a little bit of access, you're going to get page views because you're going to get people will read your articles and they'll love it. It's like the easiest. That's why Fake Steve took off. It wasn't because like I was writing anything good. It was just like there's such a huge Apple base. Then I realized, oh God, and I've seen reporters tap into that. If you tap in and become like the Apple fanboy reporter.
It's very appealing because those numbers go up and you're like, look, I'm popular, and it fills you with a
not only that, you're getting bonused
feeling.
at work. You're getting, you're straight up bonus based on your traffic. I mean, if you're not getting traffic, you're going to get fired. Like the way to get traffic, like if you're stuck covering enterprise, like but it's important stuff to cover, but it doesn't drive page views. So you end up having to do like 10 articles a day. You're just trying to win with volume, right? So then you can't do any real reporting. You can't do any kind of real journalism. You're just aggregating other stories and putting some top spin on it, and maybe trying to be the other way. You can try to get attention by being outrageous. You see the bloggers who are like very combative and love to pick fights. So you get all this like it's just entertainment, and that's actually a very serious problem in the media business, and I don't know how it gets fixed, because unless people stop measuring and rewarding people on traffic, on numbers, it's going to be very hard to. It's a race to the bottom. It just becomes a complete.
Do you think we've hit a bottom yet? I mean, it seems like they keep on trying.
Well, Donald Trump is the Republican candidate for president, so. So I don't know. I think we're still heading.
I assure you, my fingers are long.
Believe it or not, it's 2016. Let's just put this on the record. I mean, he is. No, I mean that happened, right? That really happened, and the media, I think, is complicit in that. I think there's a reason for it, because Trump gets ratings. They love putting him on TV. It's driven by, it's the same thing. It's clicks and views, right? And he's the best thing that ever happened to TV news. Yeah. And I think print journalism didn't used to be like that, but they've been dragged into it now. And if you're a reporter, it's a reality. It's part of your life. Yeah. And I don't know. Sorry. It's bad. Oh God. No. So this is why writing books is better, because you can actually go off and write a book. You can spend a year. You can do some reporting. You can write what you want to write and publish it, and maybe you make a living. I mean, I don't think 1 in a million books you really make a lot of money on, but at least you can probably make a living and do what you want. So that's what I found when I was doing this. Is like, well, at least I can write what I want to write, and it's far from perfect. And I would rewrite things. I would always go back and rewrite anything and fix it. But whatever, you can do your work and do something you believe in, and maybe that's a way out for a media person. I don't know.
So in the description of the book, you say, look what happens when an old guy goes to a young company, right?
Yeah.
And so if we want to go to the next slide, so in some ways you were anticipating, the criticism, but in some ways, when you said that, you sort of drove the criticism in that direction. I mean, you don't present as especially, Grandpa Simpson sort of. We can switch back to the slide.
But I actually have one of my epigraphs. I have two. One is Dante's Inferno, which is essentially a book about midlife crisis, right? And then, midway through this veil of whatever, I stumbled into a dark path. But then the other quote is from Grandpa Simpson, saying something like, I used to be what's it, but then they changed what it is, so now I'm not with it. Oh yeah, I used to be with it, but then they changed what it was, and so I wasn't, what I'm with isn't it, and what it is I'm not with it anyway. So I get it. No, I felt really old, and I never had felt old before, but like one guy at HubSpot used to call me Grandpa. That was like his name
Seriously?
for me. Yeah.
That's really...
Yeah, I know. He's like,
hey. That guy was kind of a jerk.
Yeah, well, yeah. He was not...
Sorry, scalawag. I mean,
he was a young fellow. He was. It was okay, but yeah. So I never felt really old before. But there's little bits and pieces of that felt it, and that was sort of their response was. The people don't like. I think, oh, it's just like an angry old guy ranting about working with millennials, and I don't have any hatred of millennials. It's fine. I actually was excited to work with young people because I loved that people would have new ideas. And the one big problem in the media business where I'd been was that. You're stuck in a legacy company that has a legacy worldview. For better, for worse, you have people inside that want to change, but it's very hard to change an old company and make it do things in a new way, right? It's just very, very hard, and it's not because they're bad people either. I mean, it's just that you're encumbered with this legacy. And I thought, maybe corporate journalism, maybe what people are doing there is going to be some part of how media gets reinvented. I don't think where I was specifically is going to be part of that, but things like BuzzFeed are easy to sort of dismiss as silly, but then maybe they're doing some good, interesting stuff too.
Yeah, but every once in a while they'll do an article that's just like astonishingly good, and you're like, where did that come from?
I mean, somebody's got to reinvent the media business. I don't know where it's going to come from, and it needs a business model. I mean,
so when old media called you, HBO says, hey, we could really use you. You're like, I'm out. TV's calling. I mean.
Yeah, and TV, mind you, I think the TV business model is challenged in a way, or is about to be the way the magazine business was 20 years ago, say. I think they are heading into a period of disruption that even maybe people in Hollywood are aware of it. I think a lot of people who work there are not. They're like what we were like in the magazine business in the late 90s, like, well, this internet thing's coming, but yeah. I mean, they've fought it off for a long time, right? They've really, really fought it off and protected their model. But I do think that TV business is going to change, and it's going to change the same way ours was. A monopoly model that threw off huge amounts of money becomes a model that now throws off, 1/10 of what it used to generate, and then has to adjust to a newer, lower cost base, right?
So it's funny because if you look at your work on Silicon Valley, what would you pull out of season 1, season 2, season 3, where you're like, I'm so glad I got to tell that story, but then they stopped you and they said, if you keep going and basically turn it into reportage, people actually won't believe that this is happening in the startup world. I mean, did you ever hit that in the because I know that when I was,
you should say that Chris also.
It's about you though.
No, but you consulted on the show too. The one thing that I think they've done that's really, really smart and really cool is they reached out to a lot of people in the industry, and they'll ask Chris, come talk to us about blank and tell us this and explain this and how would this happen. If we had a situation where the guy wants to do this, but then this happens, would that be at least plausible? And guys like you would say, and then maybe kind of not so much. And so at least they know when they're stretching reality or keeping reality. No, but they
I mean, you must have had things where you're like, not even about HubSpot, but about some of the other things you've covered, and you say, and then this would happen, and they're like, no one's going to buy that.
Yeah, definitely. There are things that are like so funny in reality that are like, if you put it into a show, people would think it was made up. Yeah. But there are lots of elements of
like
real
the teddy bear thing. I mean, you couldn't just bring that in. And people are like, what? Well, that's contrived.
Yeah, that's like not going to work. Yeah. So. But like in this year's show, there was basically an arc where they bring in an old guy to be the CEO, an old guy, and his ideas are he wants to go enterprise, he wants to put everything in a box, and he wants to make money real fast. And he has he explains to Richard that the product we're making is not the product you think it is. The product is the company. The product is our stock. And my job, I'm brought in here by the VCs. My job is to take your valuation that now is at 50 million or whatever, 100 million, whatever it is, and make it into 500 million by the end of this year. So whatever gets us to that is that's my product. My product is the company we're going to sell or take public. Whatever you're making in the engineering department is fine, but that's not really the product. And that was, I think, kind of real but very cynical, and that made it into the show. Yeah. But there are other things that I think are. I mean, they've visited Google a bunch of times, right? Haven't they?
That's how I ended up meeting them. They came here and they met a whole bunch of engineers.
You guys have been really good about having them in. Some companies early on, didn't want to meet them, and then after season 1, everybody wanted to meet them. And but then they were disappointed because it's just the writers, the actors don't show up, right? And it's just like. You know, so the writers are not very interesting or attractive
What do
people.
you mean? They're
know?
all wonderful and
They're
beautiful
really
people.
nice, but it's like people always say to me, I get friends who in the industry who call me like, hey, we want to get T.J. Miller to be speak at our conference. I'm like, yeah, of course you do. They don't want the actors, you know, everybody. But the writers are just kind of, you know, you've met them, right? They're schlumpy guys who just like come in. I mean, they're
So
nice.
saying that
really
they're actually very
smart, funny guys, but they're not like, you know, they're not
and
very glamorous.
they're moderately attractive.
No, I don't mean it to say like they're not. Yeah, I mean, you know. Yeah.
I don't want to say any names. There's a couple of very attractive
Mike Judge
writers.
is a very handsome man, very good-looking guy, right?
Yeah,
He is. And everybody wants to meet him because they all love Beavis.
If I were into fellas, I'd take him out.
Yeah, right? Yeah. I mean, yeah, same thing. Alec Berg, a very good-looking guy.
Yeah, very funny.
But as you go down the ladder, you know, it gets... No, but I just mean it's not... I mean, they actually look a lot like...
Nerds.
Yeah, nerds, yeah, and that's the thing, and they really are nerds. The guys who write for that show read all the tech blogs,
Yeah, they're
and
great.
they're, you know, we have I'm not working on the show anymore, but we had a Slack, you know, Slack room, so we'd all be trading links, and then we'd come in and talk about this thing that had really happened and how could we use that. But yeah, no, they're really, really avidly, and some of them never paid any attention to tech before, so it's kind of cool to see them really now get into it and
the
really
craft of comedy writing is applied to the show.
Yeah, but those guys could turn around like next year and go write a comedy that was set on a hockey team, and they'd go learn everything about hockey. They're just really smart guys, but they really love like the field trips to Silicon Valley. One time they had a meeting with, I was with them, but I didn't get to go. It was only the big guys got to go, and I'm like one of the peons on the show. But the big guys got to have a dinner with Reid Hoffman, Mark Pincus, and Drew Houston, I think, from Dropbox.
Yeah.
And they didn't know who those guys were. Like one of the co-EPs went, and he's like a musician. He was in punk rock bands, and like he's a great writer, but he doesn't know anything about tech. And the next day he said to me, yeah, you know these guys we met with? And I was like, yeah, who are they? He's like, tells me, I'm like, no, dude, those are really big guys. He's like, oh, really? I don't know. And how much are they worth? I said, I don't know, like together, $5 billion? He's like, what? And I was like, yeah, that one guy, Reid Hoffman, he's a multi-billionaire. He's like, then he was like, oh my God. You know, actually one day we were walking around Google with Matt Cutts.
Yeah, sure.
And one of the producer guys, who's like not a writer, but just said to me, so how much, these people are all worth a lot of money. I'm like, yeah, kind of. He's like, how about this guy who's giving us a tour? I was like, oh yeah, he's loaded, Matt Cutts. He's like, and he's like, Jesus Christ, like they're all pissed. They all get mad because they think they're like, you know, BSDs in Hollywood because they have like, you know, $10 million. I was like, oh yeah, sorry. You're at Google now, pal. And, you know, I think that's part of the show is like the Schadenfreude, not the Schadenfreude, the reverse, the jealousy that Hollywood has of Silicon Valley. Like they're very jealous of it.
It's funny, you know, because there's this refrain that goes through the coverage of Silicon Valley and Hollywood and movie streaming and all the piracy stories, and it's like they're like, you know, Silicon Valley hates Hollywood, Hollywood hates Silicon Valley, and I'm like, have you seen how much these nerds like science fiction? I mean, do you have any clue how much they love what comes out of Los Angeles and, well, Vancouver for science fiction?
Yeah.
And it's like, you know, I mean, there's like an absurd love. It's almost like a spurned lover.
I mean, the way Silicon Valley feels about Hollywood.
Both.
Oh,
both
yeah.
ways. You know?
I mean,
and Hollywood, they're like, I can't believe that they were making money.
Yeah,
You
no,
know,
when I was selling the Fake Steve show and going around to meetings and stuff, that's what I kept picking up at every network. It was just like, to them it was like this weird, strange world. Like the Googleplex was this hidden
Alien,
fortress, and they really wanted to visit it, but it was like another planet to them. And they were fascinated by it. They could tell that there was some strange culture there that they didn't get, and they thought it would be worthwhile. And I think it's suitable to comedy because they feel like they're not punching down, they're punching up. Like, you guys can take a joke because at the end of the day, you're laughing all the way to the bank, right? So, I mean, I think that's how they feel. Like, you can make up a character like Gavin Belson and make fun of him because, like, at the end of the day, you know, I don't think Sergey really cares, right? He's like, I don't think, not that Gavin Belson is based on Sergey, but he's certainly not. He's more of a Larry Ellison. I always thought he's more of a Larry Ellison.
Yeah, he's
type.
very much Larry Ellison.
Don't you think?
Yeah.
Kind of Larry, yeah?
Yeah, because Larry has the weird... Well,
I never asked. I
don't need to be called to the Oracle trial.
Because the guys who created the show are no longer with the show.
Yeah.
And they created, the main characters, Gavin and those guys all came from them. So I've never been able to find out, like, who are you thinking of then, you know, when you made that character. But I do think they feel like it's fair game. You can make fun of it. And I've been amazed at the way Silicon Valley people actually like the show. And they all kind of like the humor. And some of them say it's like too much, it's too close, it's too...
No, I love it when people tell me this. They're like, oh, you worked on the show. This part here, I couldn't watch it. I just had to stop. It was too painful to watch that mirror up to my career, you know?
Yeah.
And that just makes me feel awesome. I'm like, yeah, there you go. Yeah. So.
Yeah. Or there was a storyline in season 2 where they had a woman that got hired, and then they wanted her and Monica to be friends because like, you're a woman and you're a woman. Oh, and that came from a real story that we met a woman from Dropbox who was really funny and super cool. But it was one of these things where like 10 people showed up for the meeting, and we all wanted to talk to her, but everybody else kept talking. But she was like an engineer.
She's not just from Dropbox. She runs their engineer. I mean, she was.
Oh, you know who that is?
Yeah, she's a serious engineer. She came out of the Python. Sorry,
her company was acquired. Her company was acquired, and that's how she ended up at Dropbox, right? Yeah. So she had these, and she had worked at really teeny tiny startups like Pied Piper. So she had great stories. And one of them was, they said to her, I think it was her who said, you know, or maybe it was someone else. It might have been a woman at Google.
Colleen from Facebook.
No, you know, it was a Google woman who said, look, the worst thing, I don't mind being the only woman. I've always been the only woman. Like from the time I was a computer science major, we came here once and for a visit, and every meeting was all women, and I was like, do any men work here at Google? I don't know. It was like every meeting was like just full of women, and they were talking about being a woman at Google, what it's like to be a woman at Google and a woman in tech, and a woman who's a woman. There's a woman who's an engineer, but she's a woman. She's a woman engineer. Yeah. So we got this message like, okay, you want to talk about women. And, but she was saying, I don't mind being the only woman. The worst thing is when the second woman joins, and then they all look at you and they want you to get along, but I don't have any reason to get along with her just because we're both female. I don't care. I don't necessarily want to be her friend. And that sort of was like, this woman tossed this comment out like as an aside, but they were like, oh, that's such a good storyline.
Do you guys want to share an office? Do you want to sit next to each other?
Yeah, you should get together. You want to go out after work? And it was like really, that was.
I bet you have a lot in common.
So that came out of like a real conversation with someone here. Yeah, but the woman from Dropbox too Skyped in with us later. She was really good, really. I think they should have put her in the show as a cameo. She was like really compelling, very engaging, yeah. But
no, it's really something. But bring it back to the book. One of the things one of the outcomes. So if you read the book, when you get to the end, there's an epilogue. And I don't know if you're a skip that epilogue kind of person. Don't skip it because they went non-linear.
Yeah, we should have called it just the next chapter rather than an epilogue. But after I delivered a rough draft of the book, they announced that they had fired the CMO. They were going to fire another guy, but he resigned before my boss, and then my former boss, and then the CEO had been sanctioned for doing something to try to get hold of the manuscript, and they turned it over to law enforcement. So I was like, what the?
Like Computer Fraud and Abuse Act type investigation.
Yeah, like cybercrime. So I ended up getting interviewed by the FBI cybercrimes guys, and I'm like, but they won't tell me what happened. I had a victim specialist. When you're in one of these, they give you you get a little letter saying, you have a victim specialist, here's your victim number. Like I have a victim number.
That's cool.
Seriously. Call in and use your victim identification number and we'll,
It's probably more secure than your social security number.
Yeah, but when you call, well that's been compromised, that's gone. Like everything's in the wind. Like my social security number is gone. But yes, they did something, and the FBI investigated. My victim specialist won't tell me. The FBI won't tell me. So then I did a FOIA request, a Freedom of Information Act request, and unfortunately the book went to bed and we couldn't get this in the book, but afterwards what came out was that it was also extortion. So somebody there came up with this scheme where like, we'll hack into his computer or maybe use my old company laptop, and we'll read his email, we'll get the book, and then we'll try to dig up dirt on either me or the publisher or somebody, and it was an extortion scheme to try to kill the book. Which is like, the Rupert Pupkin of crime, right? Like just like the most insane criminal mastermind plan of all time. And they totally got caught. So it's like, like the world's worst
Did
Molly
hackers. Not help them?
And until then, right when this happened, I was starting to feel bad because I wrote this book and I was like, kind of making these guys look like doofuses. Maybe that's not.
Yeah, you don't.
Maybe that's unkind. And then this happened. I was like, okay, fine. Assholes. But it was like. Seriously, like the world's worst criminals. Like just, and I still don't know. So I got these redacted documents from the FBI, but you can't, and some of them you can fill in, and there's more documents, but the rest of them I'm still trying to get. I'm still trying to get hold of them from the U.S. Attorney's Office. So I don't know what's behind, probably not much, but there was a funny twist on the book, which is the book started out to be just a funny book about being an old guy and trying to deal with kooky corporate culture, and then has this dark twist. And I'll tell you, it's weird getting hacked and finding out you've been hacked.
Oh, no,
like I realize if you really want to mess with somebody, you don't even have to hack them. You just have to make them think that maybe they've been hacked, but you won't tell them what. Yeah. So you have to assume that everything you own is in the wind, right? Like your bank accounts, everything's out there. Kids' pictures, right? So, and that messes with your head and makes you really paranoid. And I was already fairly paranoid before that, and like it's just my
I
tendency.
mean, did you get many during the fake Steve Jobs days in your Forbes days? I mean, I remember I used to do a publication, and it attracted death threats for a while, and so I learned really early on in the late
open
90s.
source, right?
No, I used to work for the State Department. I published something called The Patterns of Global Terrorism. This is before terrorism was cool.
Jesus.
Yeah.
Really?
And so I would get these death threats. But so you learn early on, if you're lucky, how to manage your persona.
Yeah.
So we have about a minute left. But I mean, did it
No,
ever
no,
get
no,
that dire? Or
No. I mean, I had like, who's that guy? Oh, John Gruber at Daring Fireball didn't like me. He used to write a lot of bad stuff on his Apple blog about me being a jerk. And Paul Carr at Pando Daily, for whatever reason, I don't know why, just hates me. And so for a while, it just was like, yeah, no, but
And
never,
'cause, you know, Pando's leadership has been under this kind of ridiculous, silly threats. You know, I mean,
yeah, well, that's right. Because they had the Uber thing, and that was a big deal. I actually thought about hiring bodyguards. When my thing happened, I wanted to go get bodyguards and show up on CNBC with like Sarah Lacey did, but then like go everywhere with two guys with earbuds in, like, okay, all right, it's clear. But
we have a 5140 over in the upper.
But no, I never had any death threats. I mean, even now, I mean, the book's just a funny book. It's not. Yeah, there's no reason to kill me. I don't think. But they
that's good.
Someone put that on the record.
So that's a great place to wrap up. I think.
Yeah, we'll wrap up with that. There is no reason to kill me. Thank you.
Yeah. So thank you so much for coming.
Thank you for having me. Thanks.
The
I'm
conference
happy
and
to
talking with
answer
us
any
and-
questions later. But yeah.
Yeah. Well, you can find us walking around.
Thank you. Oh, the gopher.
I can give you one.
Okay. Oh, okay. Thank you.
Build sort of a sample application. This is the app that I have thrown together. It is called Polymeal. It's a social network for foodies, and I guess people that like stir fry, because there's a lot of pictures of stir fry. And you can either go to the sort of the browse section, and you see here that I've got all sorts of yummy photos. Or you could go to the activity feed, and you could see maybe like I'd be posting status updates from all the cool, awesome restaurants that I am eating at, right? Now, the main thing to take away from this is that these two sections have very, very different content, right? This one is a whole bunch of cards with some paper buttons on it, right? And this activity feed is instead just sort of these like little status blurb things. So there's no reason to load all of this, all these card elements if the user is just starting off in the activity feed, right? It would just make more sense to load that at runtime to kind of like reduce the bandwidth for our total application. So to do that, we're going to use import href over here in our code editor. So this is my XApp element that I have started off with. And what I'm going to do is I'm going to have an XApp element inside of XApp. I will chuck in a little iron pages here. And inside of iron pages, we'll have sections for the different bits of our app that we are interested in. So I've got a browse section and an activity section. And we've also got the page.js router loaded into XApp as well. So if we go down to the JavaScript definition, we can see that I've got kind of a basic route stubbed out. And what I want to do is when the route changes to either the browse section or the activity section, I'm going to call Polymer's import href method, load in my element definition. Once that's loaded in, I will then tell Iron Pages to switch over to that section. Now, the first thing I want to do, though, since we're starting off just at like slash, right now what we're doing is we're actually just loading a shell that looks kind of like this, right? We don't have, we're not hitting either the browse or the activity section, so the user's kind of got, nothing to look at. So we'll start off by redirecting them, page.redirect, over to the browse section. So this way we just have kind of like a nice starting point. I'm going to write another handler for browse, so page/browse. And you'll notice here that I'm using ES6 fat arrow functions. That just makes it a little bit easier to deal with the scoping of the this value inside of these handlers. So I'll say page.browse. And what I first want to do is see if the element has already been loaded. Has this page been loaded before? Because if it has, there's no reason to import it again. So we'll call Polymer's isInstance method. And this is something that I don't even think it's well documented. It might seriously not even exist anywhere in our docs, but I spoke with our tech writer. This is a thing. You can use it to sort of check to see if an element is an upgraded Polymer element. So because both our browse element and our activity element have IDs, We can reference them using automatic node finding. And we could say this.$.browse. So if this is already a Polymer element, let's just go ahead and return. No reason to do anything. No importing or anything like that is needed. But we will set the selected value to browse. And then what that's going to do is that's going to tell our iron pages up here to switch to that section. So you can see we're binding its selected attribute to that property. OK? Now, if the element has not been loaded, if it hasn't been upgraded yet, now we're going to import its definition. So we'll call polymer.base.importhref. And we're going to pass it a path to the HTML import for the browse section that we want to load. So elements/xbrowse/xbrowse.html. And then we'll give it a success handler to run. So we're going to say, all right, cool, the element loaded in. Let's now set this selected state to browse. That'll tell iron pages to update. And now we can return, exit our route here. We should be good to go. If we go back and we look at our application now and we refresh the page, it should redirect to the browse section, and it should start loading in all of those cards. Awesome, right? Now we need to do the same thing for the activity section. So I can just grab this entire route right here and do some dangerous copy and paste work here. We're just going to go through, and any place where it says browse, we'll just flip it out for activity. Activity. Thank you, spell check. So when we go to /activity, we're going to check to see if the activity element is upgraded. If it is, return. If it's not, import it. Let's go give that a look. So refresh the page, and we see our browse section looking good. We go to the activity section, and boom, we got our status feed showing up right there. Now, there's still a lot of unanswered questions to this. I kind of showed you the quick and dirty version of using import href, but what we didn't talk about was, do we need to vulcanize these things into different bundles? And if so, how do we exclude common dependencies? Or can we just use HTTP2 to maybe like server push all the things or multiplex stream all of our dependencies? So there's still a lot of things that remain to be worked out. And what we're going to do is we're going to talk about those in an upcoming episode of Polymer. But today, for what we've done here, if you have any questions, please leave them for me down in the comments. Otherwise, you can always ping me on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time. Otherwise, you can ping me on a social network at Take2. I'll keep all the fun stuff up here, top 2/3 of the screen.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the Bald Club. Instead, use the thread pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database writes, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what thread pool executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread pool executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. See, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs, but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that render script might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android performance patterns videos. And don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right? And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, you know, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of Service Worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the Service Worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support Service Worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of like actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get like a really good first paint, even in like Safari and like mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, like super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into the sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I
pretty
roll.
much. Impact. That's worth checking out.
That's the format of this
It's
show,
a mediocre article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about App Shell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
Yep. And in that article, we also link out to tools that can help you get started with the application model like really quickly that we're working on. So check that out.
Yeah, build a weather app.
Hey gang, did you know you can send notifications to iOS devices using Google Cloud Messaging? Well, you can. Why would you ever want to do that? Maybe that's a better question. Let's find out the answer on this episode of Route 85. So, notifications. They're a great way for you to engage with your users. They let your customers know you have important new information for them, and when used responsibly, they can be a great way to keep users coming back to your app. But they're not super fun to implement. There's a lot of steps required to set up notifications in the first place. You need logic on both the client and the server, and if you're developing a cross-platform mobile app, and most of you are these days, you have to do this for Android and for iOS. And I'm not just talking about two sets of client logic either. It turns out sending notifications to iOS and Android devices requires different logic on the server too. See, if you've done any notifications work in the past, you're probably used to talking to APNS, that's the Apple Push Notification Service, to deliver notifications to iOS devices, and to GCM, that's Google Cloud Messaging, to deliver notifications to Android devices. And while sending notifications through these two services is similar, they each have slightly different features, use different protocols, accept different message payloads, and return different responses, all of which means that you got to keep track of what kind of device each of your users has and use two completely different code paths to send a notification. Or do you? Well, no. No, you don't. You see, one pretty great feature about Google Cloud Messaging that a lot of people don't know about is that GCM can relay to APNS any notifications you want to send to an iOS device. Now, granted, you'll need to do some setup work like upload your APNS certificate to GCM and make sure your client sends its device token to the GCM service. But once you've done that, you can use GCM to send all of your notifications, no matter what platform your target device is, and GCM will deliver your notifications to the correct device using the appropriate service. What all this means is that you don't need to care about what device your user has anymore. You just have to write and maintain one code path, and as we all know, less code means less room for mistakes. But it's not just about using less code. By using GCM to handle your messaging for you, you can take advantage of some of the other nice features that GCM offers to developers, like topics. Topics allow your app to subscribe to notifications about any particular topic that you or your users want to. For example, let's say you've got a weather app and I, as a loyal weather fan, want to be notified whenever there's extreme weather happening in my zip code. Well, in the old way of doing this, you'd probably need to set up a database where you keep track of each one of your users and their devices and their zip codes and do this whole select users where blah 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 query, then loop through the results and send notifications to each device that you get back from this database query. But with topics, none of that's necessary. Instead, your app simply tells GCM that you're interested in subscribing to, say, the weather 94043 topic. Then, next time there's rain in California, for us that counts as extreme weather.
Oh my gosh, there's something coming down from the sky. I don't know if it's water or if it's acid. I can't go out. I don't know how to drive anymore.
Yeah, that seems about right. So yeah, with topics, your server simply tells GCM to send notifications to all devices subscribed to the weather 94043 topic, and I will get notified along with all other devices subscribed to that topic. So there's no database required. Go ahead and throw it out. Oh, as long as you weren't using it for anything else, I guess. I probably should have mentioned that earlier. GCM has other useful features too, like upstream messaging, which allows your app to communicate to your server through GCM. This can be helpful in cases where you might want some lightweight communication from your clients to your server, but don't feel like dealing with the hassle of setting up and maintaining a full-blown server open to the entire world. Or read receipts, where in some, but not all situations, you can be notified that a user has received your message, something you can't normally do through APNS alone. Oh, and in case you're wondering, all this is free, as in please send us $0, and it's using much of the same infrastructure that Google uses for its own apps, so it'll probably scale for yours. So there's a lot to learn when it comes to notifications, and I encourage you to get started here with our Google Cloud Messaging documentation for iOS. We also have a couple of sample applications for you to look at. There's Friendly Ping, our cross-platform chat app powered entirely through Google Cloud Messaging, as well as the GCM Playground, which lets you easily experiment with sending calls through the GCM service. And keep watching Route 85. Maybe you'll see another Google Cloud Messaging video pop up in the future. If only we had some way of letting you know when that happened. Well, I'm stumped. So what if I told you there was a way you could compress nearly any stream of data by a factor of 10x or more? Wouldn't that be something you'd be interested in? Yeah, I thought so. Let's find out more on this episode of Route 85. So I want you to take a look at this array of numbers here. Imagine that we wanted to send this array of integers from a server to your user's device. Looks like just a bunch of random numbers, right? Well, that word random is actually the key to compressing these in an incredibly efficient manner. As you probably know, a random number generator isn't truly random. Supply a random number generator with the same seed, and you'll get the same results out every time. And we can take advantage of that fact to recreate that list of integers using a random number generator. You see, all I need to do to regenerate that array on a device is to supply 3 parameters: the seed for an agreed upon random number generator, an upper bound to apply to these results, and the length of the list. I simply supply those numbers to a method that looks a little like this, and I can recreate that original number stream. Just like that, I've built my array of 30 integers using just 2 integers and an int 32. That's a 92% compression rate. Now granted, finding that initial seed did take some work, but you know what? That work can happen in the cloud, so it doesn't really matter. What's important is that on the device, I'm able to decompress that number stream in order and time. And then of course, once you start looking around, you can see that there's a ton of data you can compress this way. I mean, need to compress a text string? Well, what's a string but a stream of encoded integers? Once I have my stream of integers, I simply figure out what seed I need to generate them, and voila, I've compressed my string down into just 3 numbers. It's a pretty amazing savings, right? Anybody with a username of stidjexmisdizixgoodquibpubpa will be singing your praises in their reviews. And my gosh, if you think about it, an image is really just a stream of numbers broken out into several channels. Take a look at this image here, and you can see how, using our random number generator, I've been able to replace it with just 3 sets of integers for the red, green, and blue channels, respectively. Now, once again, finding the right seed can take some time, and I haven't found the perfect seed just yet. So if you look at the results carefully, you can see that this is not quite a lossless compression scheme. But I think you'll agree that for this kind of savings, these trade-offs just might be worth it. Anyway, I hope you consider using this technique the next time you have data that needs to be compressed. Remember, the more efficient you are with your users' data, the more they'll love you. Thanks again for watching. Be sure to check out other episodes of Route 85. And remember that, as my coworkers on the Android team like to say, perf matters. All right, thanks guys. I think we're done.
Who let him into the studio again?
I couldn't say no to Elijah Wood.
But that's...
Elijah Wood.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer, so you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that. Welcome to Coffee with a Googler. I'm Lawrence Moroney, and I'm here in New York City to meet with Roman Nurik. And Roman Nurik is one of our material design gurus here at Google. So material design, tell me, what's it all about?
Oh, Lawrence, what is material design? Yeah, it's kind of hard to explain. There's actually a video with a bunch of the original designers that created material design, and they get asked the same question, and they don't know how to answer it. It is a complex kind of thing. There's a lot of things going on. I guess at the most basic level, it's a design language. It's a design system. It covers visual, interaction, and motion design. I feel like most design systems, design languages are treated as just visual languages, like here are the colors you should use and so on. But material is much more than that. It really kind of covers the model, the underlying physical model of a UI.
Okay.
So it basically tries to establish this physical environment within which your apps should live, on a phone, on a tablet, on a computer, basically any sort of screen. And then it basically establishes this physical environment in a set of basic rules and principles. And I like to think of it along these kind of 4 basic axes or 4 basic principles. And that's tangible surfaces, or kind of the material metaphor. We could talk about what material is at some point. Also, bold graphic design, this idea that we should take some of the best design ideas from the print world and see how that can help us make really great apps on on digital devices.
Right.
And the third is meaningful motion, basically how all these things, how the surfaces and the ink on that surface, the graphic design stuff, how that all kind of moves in a consistent way to help communicate what's going on. And the fourth thing, which is to me one of the most important things, is adaptive design, which is how can we take all these first 3 things and make sure that they work consistently and coherently across different devices, phones, tablets, and everything else.
Now, you have a video, right, of some really good examples of material design being used. So shall we roll that?
Let's roll it.
So some pretty excellent examples there, but it's like, how does somebody reach that level? For someone like me, I'm a developer and my design skills are non-existent. So if I want to become somebody who can build apps with those kind of design, how do I get started? And how do I learn this stuff?
It's a great question. I think first of all, I just want to, recognize some of those apps they're doing amazing jobs, and they have large teams. Some of them actually have very small teams. Some of those apps are created by one person. So you can absolutely reach that level of quality from these amazing showcase apps, regardless of your team size.
Okay.
But I'd say for the developers and designers out there that are just getting started, there are a lot of great resources out there. There's a great Udacity course that me, Nick Butcher, also from Google team here, and James Williams from Udacity put together. And that's available at udacity.com/Google.
Right.
And there's also a bunch of amazing resources on design.google.com, which will kind of tell you about how to come to Android if you're doing iOS stuff, for example, or how to kind of get started understanding what material design is. There's obviously the entire material design guidelines are there.
Okay.
So I'd say that the first thing, the Udacity course is probably the best kind of first step in getting started. But there's a whole lot of resources out there, and we link to others from the Udacity course.
And Udacity courses, if you're not familiar with them, they are very Socratic in how they teach, right? It's short videos and then challenging you to do something, and then a short video and then getting you to do something. And it's a good way that someone can incrementally learn rather than be thrown into like a huge design doc or something like that, right? So
yeah, it's definitely, there's a very clear progression. We specifically designed that course so that you can kind of start with some of the basics, the most elementary basic things about a screen, like what is a pixel, what is a density independent pixel, and then you kind of ramp all the way up to how do I make everything work on phones, tablets, and so on.
Right, and I have to assume that a design course is well designed, right?
We have some very nice color choices in our slides or our tablet drawings, so hopefully.
So back to material design again. It's like why material? What is it that?
So material goes back to that first principle. Right. So this idea of tangible surfaces, this idea that everything on a on your screen and your device exists on a surface. We like to think of them as pieces of paper. So basically, you can think of basically a sheet of material, or the word material representing one of those pieces of paper. And the reason we don't just call it paper is because it's a lot more than just paper. In the real world, paper, once you rip it up, you can't really just, put it back together, and paper can't go from being, a circle to a square or to a rectangle. And so we like to think of our digital pieces of material or sheets of material as kind of a smarter paper, a more kind of still a constrained paper. You can't just do anything. It can't just do all sorts of crazy things, but it is a physical thing that exists inside of this kind of environment, this
Right.
kind of like faux environment, but it is something that has a lot of thought put into it. And so the word material, to me really means the sheets of paper that everything in this world exists on. But for me, the main thing to think about, the reason that motion is so important in material design is that motion should always have meaning. Try not to just do like a flip of a button or like a double rotation or something just to kind of draw attention. Every time something moves, it attracts our attention. And so it needs to be really thoughtful and really kind of carefully planned out. And so in material, we use motion, or we kind of use just enough motion to convey the change in some object's state, or try to get a little bit of attention, but just enough motion, not too little, not too much.
I understand Android Studio has some templates to allow developers to at least get started with building material design into their apps.
Absolutely. So one of my philosophies for a long time has been, we can write about material design. We can write about a thing. We can make suggestions about that thing, and we can try to teach people about that thing. But one of the best ways to get the thing into people's hands, in this case material design, is to actually just build it into the tools. Just make sure that as a developer that's just getting started, even just on Android, if I just go to File, New Project, or New App, right, I should be able to get the latest and greatest. And so in Android Studio now, we're actually seeing new templates for material design. So you could do File, New Project, and then your default activity templates are going to come with material design in them.
Okay.
So it's going to use the material theme. It's going to use some of the latest support libraries from material design. So things like the Android Design Support Library, things like AppCompat.
Cool.
And so you're just going to get a lot of great stuff for free right off the bat.
Nice. So for someone like me, I'm a coder, not a designer, and so I can use Android Studio, get effectively the scaffolding done for me in these templates, and then learn from something like the Udacity course.
Exactly. I definitely suggest, even before you do the Udacity course, File, New Project, right? Just look around the code, see what you get. I think that's a great way to get started. I always valued, as a kid and growing up learning programming and stuff, I always valued experimentation. So definitely experiment with that. But as soon as you kind of hit some sort of if you hit an obstacle or something, obviously take a look at the guide and the reference and all that. But the Udacity course is a great way to say, what, let me just kind of see what Google thinks is the right way to kind of approach understanding this system.
Awesome. Well, thanks, Roman. This has been a whole lot of fun, and I've learned more about material design in the last 5 minutes than I'd had in a year beforehand. So
this is fun. I could always talk about this stuff. So
they've told me that about you.
This is my favorite thing to talk about.
It's cool.
It's been awesome.
And I'm going to check out that Udacity course, and I recommend that you do so too. And if you're an Android developer, take a look at those templates. If you have any questions for me about this, or if you have any questions for Roman about material design or other aspects of building for material design, just please drop us a line in the comments below. Thank you for watching this episode of Coffee with a Googler. For more great episodes of Coffee with a Googler and for more great videos on developer topics, please tune to the Google Developers channel on YouTube. Thank you.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers. They're all species of iris: Setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at Scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the dataset is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from Scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left, otherwise go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the 4th feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
Pop quiz, hotshot. You've got 48 milliseconds of work to do, but only 16 milliseconds per frame to get it done. What do you do? My name is Colt McCandless, and while threading on Android can help cure your performance woes, it can also end up creating some huge problems if you don't understand how it's all working under the hood. So let's take a few minutes and make sure we're all on the same page. See, a thread by default does three things. It starts, it does some work, and as soon as that work is done, it terminates. Now, by itself, that's not too useful. Instead, what you want is a thread that sticks around for a while so you can feed it packets of work to operate on. But to do that, you need a little more scaffolding. First, since threads die when they run out of work, you need to have some sort of loop running on the thread to keep it alive. Just make sure to put it in an exit condition so you can terminate that loop later. In addition, you'll need some sort of queue that the loop can pull blocks of work from to execute on. And of course, you'll need some other thread that creates work packets and pushes them into the queue for execution. Now, if you've ever tried to write this setup yourself, you know it gets a little gnarly to get all of that machinery working correctly. Thankfully though, Android has a set of classes to do all that for you. For example, the looper class will keep the thread alive and pop work off a queue to execute on. And rather than always inserting work at the end of that queue, the handler class gives you the control to push work at the head, the tail, or set a time-based delay that'll keep some work from being processed until that time has passed. And don't forget that units of work in Android are explicitly defined as intents or runnables or messages, depending on who's issuing them and who's consuming them. And then the combination of all these things together is called a handler thread, which lets this look like this. Pretty nifty, huh? So let's look at how you can use this in your application. When the user launches your app, Android creates its own Linux process. Alongside with this, the system creates a thread of execution for your application called the main thread, which at its core is just a handler thread. This main thread handles processing of events from all over your app. For example, callbacks associated with lifecycle information, or callbacks from input events, or even events that are coming from other applications. And most important is that these callbacks can trigger other work that runs on the thread too, like making a change to the UI will create work packets that allow the UI to be redrawn. Basically, this means that any block of code your app wants to run has to be pushed into a work queue and then serviced on the main thread. The takeaway here is that with so much work happening on the main thread, it makes a lot of sense to offload longer work to other threads as to not disturb the UI system from its rendering duties. And this is how the entirety of Android's threading model works. Now, lots of packages of work being passed around between threads and worked on as needed. So, with all this in mind, some of Android's threading classes make a little bit more sense. See, each threaded class is intended for a specific type of threading work, so picking the right one for your needs is really important. For example, the async task class is ideal for helping you get work on and off the UI thread in the right way. Handler threads are great when you need a dedicated thread for callbacks to land on, and thread pools work best when you can break your work up into really small packets and then toss them to a bunch of waiting threads. And intent services are really ideal for background tasks or when you need to get intent work off the UI thread. And like everything else, there's not a silver bullet here, but knowing which primitive is best for what situation can save you a lot of headaches. Now, if you ever want more insight into how your app is leveraging threading, make sure you spend some time getting comfortable with systrace. It's a fancy tool that'll school you on how that mumbo jumbo is working underneath the hood. And if you're looking to get schooled more, make sure you check out the rest of Android Performance Patterns videos. And don't forget to join our Google Plus community for more tips and tricks on threading. So keep calm, profile your code, and always remember, perf matters.
Hey there, Polycasters, Rob here. Welcome back to the show. As we've been working on Polymer, one of the probably biggest requests that comes in from developers is when are we going to get a CDN for Polymer and for web components? Because it's kind of a pain in the butt every time you want to sort of like hack on an idea and you've got to use Bower and install a bunch of packages and wait for everything to download just so you can, play with stuff. So recently, the Polymer team has put out a brand new project, which is called PolyGit. It is a development CDN, which I'll talk about what that word means in just a second. But basically, it is a CDN that includes Polymer, all the Polymer elements, and the web components polyfill. So if you want to hack around using something like JSBin and Polymer, you can totally do that. So if you go to the website polygit.org, you see that it bills itself as the Polymer Magic Server. And what it's actually doing under the hood is it's just using GitHub's rawgit CDN and extracting things from there and pulling them into, JSBin or wherever you want to use the CDN. So what I want to do here is just sort of like show you some examples of how you can use the CDN, how you can configure it to actually pull in your own packages as well, and basically just get hacking really quick. So over on jsbin.com, I've already set up this little sample bin. And the main thing to notice here is I'm using this base tag right here. And if you're not familiar with a base tag, in HTML, a base tag or a base element, it just allows you to set a URL. And then any sort of subsequent URLs that you use, like for script tags or imports, they will all be relative to that base. So what we're saying here is we want the base URL to be polygit.org/components. This components directory is where Polymer and all the Polymer elements and all that good stuff lives. And from here on out, if we have any relative URLs, it'll just pull stuff from that directory. So I'm pulling in web components.js. It's coming from that directory. I can import polymer.html. That'll also come from that directory. And so since we've got all this working off of our CDN, now we can actually sit here if we want. We can just create our own Polymer element right on JSBin. So I'm going to do that, write out a DOM module here. I'll give it an ID of like xfoo. And I'll give it a template that just says like hello from xfoo. And I'll also give it a little script tag. And inside of here, we will call the Polymer constructor. And we're going to say it is an xfoo element. And then the last thing we want to do is we want to just make sure that we use our xfoo tag somewhere in the page. And now you can see it showing up over there in our output. So this is really great if you're hanging out on the Polymer Slack channel, you run into a bug or some issue, and you're not quite sure how to explain it to folks. You can just go throw together a JSBin using PolyGit and then share that JSBin with people so they can help you get unstuck. Now, I also mentioned that all the Polymer elements that we built are included in this CDN as well. So what you can also do if you find maybe a bug or an issue with something like paper tabs is you can go over here and you can just write an HTML import for paper tabs. So instead of just Polymer, I'll also pull in paper tabs. And then you can just start using that element in your page here. So I'll say I want a set of paper tabs. And then inside of here, I will write out maybe like 2 or 3 paper tabs. So we'll say this first tab is called foo. Second one is going to be called bar. And the last one will be baz. Foo, bar, baz. And there we go. Now over here in our output, I've got these 3 paper tabs working just as I was expecting. And if I had some issue, I could then take this. I could save this JSBin. I could go file a GitHub issue and point the engineer at this particular JSBin. And that way, it's going to help them triage that issue a lot faster and help them debug the actual problem that you're running into and hopefully get things fixed. Now, one of the coolest things about PolyGit is that it is configurable. So not only does it pull in Polymer and the elements that team has created, but you can add your own GitHub repos to it as well. So if you go back to the polygit.org website, you scroll down here to the bottom, you can see that there is this sort of interesting configuration syntax. And it might look a little weird when you first see it. It took me a few times kind of working through it to understand what it's doing. But basically, what you want to do is when you are defining that base URL, you can configure it by saying, oh, I would also like to include this component. And this component might live like inside of some particular org. And maybe you want a particular version, like version 1.2.3. Or maybe you want a branch, right? Maybe you want like the master branch. That's some good handwriting right there. Or maybe you want just the latest tag. So if you include an asterisk, instead of pulling a particular version or a branch, it'll just give you whatever the latest tag happens to be. So to show you an example of that, I've again got a little JSBin here. And I'm just going to paste in a better URL here. So what I've done is I've configured Polygit to pull in 2 additional dependencies. The first is the markdown.js library, which is in the chjj org on GitHub. And I've told it to grab the latest tag. And I've also told it to pull in the mark-down element, which is something that I wrote myself. That lives in the Rob Dodson org on GitHub. And again, I've just told it to pull in the latest tag there. So now both of those are available in that CDN components directory. So I can just go ahead and write an HTML import to pull in the markdown element. And then over in my body, I can just start using it. So I can have a markdown tag. And we'll just drop in like a hello world for the header there. And we can see we're getting this sort of like huge H1 rendering over there in the output. So if you're working on an element or a project or something like that, and you want to show that to folks on JSBin, you can absolutely do that using Polygit as well. The one caveat there is that it has to have been published for at least 1 hour for it to be picked up by the rawgit caching CDN. But once it's been published for about an hour, it should be available to you on Polygit. Now, the last thing I want to mention here is at the very beginning of the show, we said that this is a sort of development time CDN. And what I mean by that is it's not a CDN that you want to use for production. And the reason is because we're not doing any sort of like vulcanization or anything like that to optimize the elements that we're sending down. Instead, you're getting an individual dependency for everything that you import, which is actually pretty expensive in terms of HTTP requests. So it's great for development time. It's great for hacking on ideas. But when you get to the point where you want to launch something into production, you still want to use a package manager like Bower. You still want to use a process like Vulcanize to make sure you're sending down the absolute smallest payload possible. But if you just want to mess around with some ideas, it's perfect for that. So that about covers it for today. If you have any questions, please leave them for me down in the comments. Or you can always hit me up on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time.
There's something really satisfying about getting your app to look great on your device. But just because there's over 11,000 other Android devices out there doesn't mean you need to build 11,000 other layouts to make a great-looking app. Not if you're using responsive UI principles. You may have noticed that I'm not Ian or Joanna. My name is Mike Denny, a design advocate on the Google design team. First things first, thinking about specific phones and tablets is only going to get you into trouble. There's a wide spectrum of devices and not that much difference between the largest phone and the smallest tablet. Instead, think more generally about how much space you have to work with. This can come in 3 different flavors: width, height, and smallest width. Width is super important and should be the basis for breakpoints in designing and building your UI. For example, 600 dp in width is the first point where you could consider having a side-by-side summary and detail level view. Any lower and you won't be giving each level the full attention it deserves. Height is less common when designing responsive UI, but keep in mind that something like a vertically scrolling container is going to be difficult to use if you can only see 1 or 2 elements at a time due to a constrained height. Smallest width, unlike height or width, is designed to be rotation insensitive, as it's just the smaller of the 2 values. This gives you a better idea of how much space is available and is an easy way to ensure that your app remains consistent as the device is rotated. You don't want to force your user to relearn your navigation structure every time they rotate their device. This is particularly important in the multi-window world. When your app is resized, your width, height, and smallest width are going to be updated. You might be going from full screen on a tablet down to what amounts to a portrait-oriented phone worth of space. Here's where a good responsive UI can make for a smooth transition. There are a number of common patterns you might consider when building that responsive UI, such as revealing previously hidden content as the screen size grows, transforming your navigation pattern or switching from a list to a grid, dividing your screen into multiple sections side by side, reflowing specific elements, expanding the size or margins of individual elements, or even changing the position of specific elements like a floating action button. Check out the blog post for more details on designing responsive UI and specific patterns you can use to build better apps.
Hey there, Polycasters, Rob here. So before coming into the studio, we tweeted out a question to see what folks wanted to see in the next episode of Polycast, and a lot of folks wrote in and said they wanted to know how to lazy load Polymer elements to improve the performance of their apps. So that's exactly what we're going to cover today. Now to do that, we're going to start off over here at the Polymer docs, and we're going to go down to the API reference. And some folks might not even realize that we have an API reference, but it's kind of hidden down here in the sidebar for the documentation. You can go click on that, and that's going to take you to this sort of kind of classic Polymer doc layout if you've seen this before on other elements. And this is where you can find all of the properties and methods of the Polymer object itself. So a lot of really cool stuff inside of here. This is also where, for instance, like the Polymer templatizer documentation is. So if you wanted to create your own version of DOM if or DOM repeat, you could use templatizer to do that. Just a helpful tidbit there. But what we're interested in here is this Polymer base object. And Polymer base is sort of the base prototype for all Polymer elements, and it's where we hide interesting like methods and properties and stuff like that. The one I'm into is called import href down here. We can hit the embiggen button to make it larger. And so what import href is going to do, it's going to give us the ability to dynamically load an HTML import at runtime. It's got a few arguments that it takes. The first argument is we're going to give it an href, so basically just a path to some component or some HTML import that you want to pull in at runtime. And then it wants callbacks for on success, on error. And lastly, it takes an option which specifies whether or not you want the link tag to have an async attribute on it. So what I'm going to do is I'm going to use import href, and I'm going to build sort of a sample application. This is the app that I have thrown together. It is called Polymeal. It's a social network for foodies, and I guess people that like stir fry, because there's a lot of pictures of stir fry. And you can either go to the sort of the browse section, and you see here that I've got all sorts of yummy photos. Or you could go to the activity feed, and you could see maybe like I'd be posting status updates from all the cool, awesome restaurants that I am eating at, right? Now, the main thing to take away from this is that these two sections have very, very different content, right? This one is a whole bunch of cards with some paper buttons on it, right? And this activity feed is instead just sort of these like little status blurb things. So there's no reason to load all of this, all these card elements if the user is just starting off in the activity feed, right? It would just make more sense to load that at runtime to kind of like reduce the bandwidth for our total application. So to do that, we're going to use import href over here in our code editor. So this is my XApp element that I have started off with. And what I'm going to do is I'm going to have an XApp element inside of XApp. I will chuck in a little iron pages here. And inside of iron pages, we'll have sections for the different bits of our app that we are interested in. So I've got a browse section and an activity section. And we've also got the page.js router loaded into XApp as well. So if we go down to the JavaScript definition, we can see that I've got kind of a basic route stubbed out. And what I want to do is when the route changes to either the browse section or the activity section, I'm going to call Polymer's import href method, load in my element definition. Once that's loaded in, I will then tell Iron Pages to switch over to that section. Now, the first thing I want to do, though, since we're starting off just at like slash, right now what we're doing is we're actually just loading a shell that looks kind of like this, right? We don't have, we're not hitting either the browse or the activity section, so the user's kind of got, nothing to look at. So we'll start off by redirecting them, page.redirect, over to the browse section. So this way we just have kind of like a nice starting point. I'm going to write another handler for browse, so page/browse. And you'll notice here that I'm using ES6 fat arrow functions. That just makes it a little bit easier to deal with the scoping of the this value inside of these handlers. So I'll say page.browse. And what I first want to do is see if the element has already been loaded. Has this page been loaded before? Because if it has, there's no reason to import it again. So we'll call Polymer's isInstance method. And this is something that I don't even think it's well documented. It might seriously not even exist anywhere in our docs, but I spoke with our tech writer. This is a thing. You can use it to sort of check to see if an element is an upgraded Polymer element. So because both our browse element and our activity element have IDs, we can reference them using automatic node finding. And we could say this.$.browse. So if this is already a Polymer element, let's just go ahead and return. No reason to do anything. No importing or anything like that is needed. But we will set the selected value to browse. And then what that's going to do is that's going to tell our Iron Pages up here to switch to that section. So you can see we're binding its selected attribute to that property. Okay. Now, if the element has not been loaded, if it hasn't been upgraded yet, now we're going to import its definition. So we'll call polymer.base.importhref. And we're going to pass it a path to the HTML import for the browse section that we want to load. So elements/xbrowse/xbrowse.html. And then we'll give it a success handler to run. So we're going to say, all right, cool, the element loaded in. Let's now set this selected state to browse. That'll tell Iron Pages to update. And now we can return, exit our route here. We should be good to go. If we go back and we look at our application now and we refresh the page, it should redirect to the browse section, and it should start loading in all of those cards. Awesome, right? Now we need to do the same thing for the activity section. So I can just grab this entire route right here and do some dangerous copy and paste work here. We're just going to go through, and any place where it says browse, we'll just flip it out for activity. Activity. Thank you, spell check. So when we go to /activity, we're going to check to see if the activity element is upgraded. If it is, return. If it's not, import it. Let's go give that a look. So refresh the page, and we see our browse section looking good. We go to the activity section, and boom, we got our status feed showing up right there. Now, there's still a lot of unanswered questions to this. I kind of showed you the quick and dirty version of using import href, but what we didn't talk about was, do we need to vulcanize these things into different bundles? And if so, how do we exclude common dependencies? Or can we just use HTTP2 to maybe like server push all the things or multiplex stream all of our dependencies? So there's still a lot of things that remain to be worked out. And what we're going to do is we're going to talk about those in an upcoming episode of Polymer. But today, for what we've done here, if you have any questions, please leave them for me down in the comments. Otherwise, you can always ping me on a social network of your choosing at #AskPolymer. As always, thank you so much for watching, and I'll see you next time. Otherwise, you can ping me on a social network at... I'll keep all the fun stuff up here, top 2/3 of the screen.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
Let's be honest, you're an awesome engineer with an awesome app and you are using threading to the max. Sadly though, managing all those individual threads and assigning work between them is causing you to lose your hair. My name is Colt McCandless, and please, don't join the bald club. Instead, use the thread pools class, which is an ideal primitive for breaking up lots of work into little buckets. See, historically, it was commonplace that applications would use a dedicated thread model. That is, one thread that only deals with database rights, while a separate thread only handles streaming of music, and a third one only handles networking. These setups are okay because the amount of work per thread isn't that large, and it's okay to handle this work in sequential order. But there reaches a point where this model starts to fall over. Say, for example, that you've got 40 bitmaps to decode, and each decode takes like 4 milliseconds or something. Putting all of this work on a single dedicated thread is a bad idea, since it'll take 80 milliseconds total to get all that work done in a sequential fashion. On the other hand, if you created 10 threads and let each one decode 4 bitmaps, then you'd end up only taking 16 milliseconds total. But then, of course, you run into the problem of how to properly pass the work around between those threads, schedule that work, and then managing of those threads. Before you start stressing out about writing all that code, don't worry. This is exactly what thread pool executor primitive is for. Basically, this class will just let you spin up a number of threads and toss blocks of work to execute on it. Thread pool executor handles all of the heavy lifting of spinning up the threads, load balancing work across those threads, and even killing those threads when they have been idle for a while. Basically, it handles all the heavy lifting of super parallel processing on your behalf. All you have to do is split up the work. But there's a small caveat here. How many threads should your thread pool have? I mean, technically speaking, you have the ability to create as many threads as you want, but that's not ideal. See, CPUs can only execute a certain number of threads in parallel. Once you get above that number, then the CPU has to start deciding which threads get the next free block of processor time based on how important they are. Which means that if you keep eventually adding threads, you'll hit a break-even point where your computation isn't getting any faster, even though the number of threads that you have has increased significantly. And it's also important to note that each of these threads aren't free. Each thread costs you about 64K of memory in minimum, and that adds up quickly, especially in situations where the call stacks can start growing pretty large. As such, your app needs to find a sweet spot between the number of cores and the point of diminishing return with the number of threads. Thankfully, once again, the thread pool executor class has got you covered. When creating your thread pool, you can specify the number of initial threads and the number of maximum threads. As the workload in the thread pool changes, it'll scale the number of alive threads to match. Oh, and a quick note, the value returned from get available processors may not reflect the number of physical cores in the device. See, some devices have CPUs that will deactivate one or more cores depending on the system load to save battery. So if your device has 2 CPUs but one of them is asleep, this value could return 1. And of course, thread pools won't solve all of your threading problems. As mentioned earlier, unless you're dealing with lots and lots of work packets all the time, this thing's kind of overkill. It's best to use things like handler threads or async task loaders for specific types of work blocks and only throw the massive computing problems at the thread pool. And for you power users out there, remember that render script might be a better alternative to large-scale parallel work on Android devices, but that's a whole separate set of videos that we haven't gotten into yet. And don't forget that systrace is an amazingly powerful tool that lets you visualize how work is flowing through the threads in your application. It's a great way to validate that things are working as intended and also see all the other crazy threads that are being worked on by other parts of your app. And that's the trick with performance, isn't it? I mean, you can make assumptions, but things don't always work the way you think, which is why you need to check out the rest of the Android performance patterns videos. And don't forget to join our Google Plus community to ask a lot of hard threading questions as well. So keep calm, profile your code, and always remember, perf matters.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right. And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, you know, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of Service Worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the Service Worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support Service Worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of like actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get like a really good first paint, even in like Safari and like mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, like super simple apps. This might be overkill.
Yeah.
But if you're building something that's a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like Inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into the sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I
pretty
roll.
much. Impact. That's worth checking out.
That's the format of this
It's
show,
a mediocre
Eddie.
article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about App Shell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
Yep. And in that article, we also link out to tools that can help you get started with the application model like really quickly that we're working on. So check that out.
Yeah, build a weather app.
Hey gang, did you know you can send notifications to iOS devices using Google Cloud Messaging? Well, you can. Why would you ever want to do that? Maybe that's a better question. Let's find out the answer on this episode of Route 85. So, notifications. They're a great way for you to engage with your users. They let your customers know you have important new information for them, and when used responsibly, they can be a great way to keep users coming back to your app. But they're not super fun to implement. There's a lot of steps required to set up notifications in the first place. You need logic on both the client and the server, and if you're developing a cross-platform mobile app, and most of you are these days, you have to do this for Android and for iOS. And I'm not just talking about two sets of client logic either. It turns out sending notifications to iOS and Android devices requires different logic on the server too. See, if you've done any notifications work in the past, you're probably used to talking to APNS, that's the Apple Push Notification Service, to deliver notifications to iOS devices, and to GCM, that's Google Cloud Messaging, to deliver notifications to Android devices. And while sending notifications through these two services is similar, they each have slightly different features, use different protocols, accept different message payloads, and return different responses, all of which means that you got to keep track of what kind of device each of your users has and use two completely different code paths to send a notification. Or do you? Well, no. No, you don't. You see, one pretty great feature about Google Cloud Messaging that a lot of people don't know about is that GCM can relay to APNS any notifications you want to send to an iOS device. Now, granted, you'll need to do some setup work like upload your APNS certificate to GCM and make sure your client sends its device token to the GCM service. But once you've done that, you can use GCM to send all of your notifications, no matter what platform your target device is, and GCM will deliver your notifications to the correct device using the appropriate service. What all this means is that you don't need to care about what device your user has anymore. You just have to write and maintain one code path, and as we all know, less code means less room for mistakes. But it's not just about using less code. By using GCM to handle your messaging for you, you can take advantage of some of the other nice features that GCM offers to developers, like topics. Topics allow your app to subscribe to notifications about any particular topic that you or your users want to. For example, let's say you've got a weather app and I, as a loyal weather fan, want to be notified whenever there's extreme weather happening in my zip code. Well, in the old way of doing this, you'd probably need to set up a database where you keep track of each one of your users and their devices and their zip codes and do this whole select users where blah 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 query, then loop through the results and send notifications to each device that you get back from this database query. But with topics, none of that's necessary. Instead, your app simply tells GCM that you're interested in subscribing to, say, the weather 94043 topic. Then, next time there's rain in California, for us that counts as extreme weather.
Oh my gosh, there's something coming down from the sky. I don't know if it's water or if it's acid. I can't go out. I don't know how to drive anymore.
Yeah, that seems about right. So yeah, with topics, your server simply tells GCM to send notifications to all devices subscribed to the weather 94043 topic, and I will get notified along with all other devices subscribed to that topic. So there's no database required. Go ahead and throw it out. Oh, as long as you weren't using it for anything else, I guess. I probably should have mentioned that earlier. GCM has other useful features too, like upstream messaging, which allows your app to communicate to your server through GCM. This can be helpful in cases where you might want some lightweight communication from your clients to your server, but don't feel like dealing with the hassle of setting up and maintaining a full-blown server open to the entire world. Or read receipts, where in some, but not all situations, you can be notified that a user has received your message, something you can't normally do through APNS alone. Oh, and in case you're wondering, all this is free, as in please send us $0, and it's using much of the same infrastructure that Google uses for its own apps, so it'll probably scale for yours. So there's a lot to learn when it comes to notifications, and I encourage you to get started here with our Google Cloud Messaging documentation for iOS. We also have a couple of sample applications for you to look at. There's Friendly Ping, our cross-platform chat app powered entirely through Google Cloud Messaging, as well as the GCM Playground, which lets you easily experiment with sending calls through the GCM service. And keep watching Route 85. Maybe you'll see another Google Cloud Messaging video pop up in the future. If only we had some way of letting you know when that happened. Well, I'm stumped. So what if I told you there was a way you could compress nearly any stream of data by a factor of 10x or more? Wouldn't that be something you'd be interested in? Yeah, I thought so. Let's find out more on this episode of Route 85. So I want you to take a look at this array of numbers here. Imagine that we wanted to send this array of integers from a server to your user's device. Looks like just a bunch of random numbers, right? Well, that word random is actually the key to compressing these in an incredibly efficient manner. As you probably know, a random number generator isn't truly random. Supply a random number generator with the same seed, and you'll get the same results out every time. And we can take advantage of that fact to recreate that list of integers using a random number generator. You see, all I need to do to regenerate that array on a device is to supply 3 parameters: the seed for an agreed upon random number generator, an upper bound to apply to these results, and the length of the list. I simply supply those numbers to a method that looks a little like this, and I can recreate that original number stream. Just like that, I've built my array of 30 integers using just 2 integers and an int 32. That's a 92% compression rate. Now granted, finding that initial seed did take some work, but you know what? That work can happen in the cloud, so it doesn't really matter. What's important is that on the device, I'm able to decompress that number stream in order and time. And then of course, once you start looking around, you can see that there's a ton of data you can compress this way. I mean, need to compress a text string? Well, what's a string but a stream of encoded integers? Once I have my stream of integers, I simply figure out what seed I need to generate them, and voila, I've compressed my string down into just 3 numbers. It's a pretty amazing savings, right? Anybody with the username of stidjexmisdizixgoodquibpubpa will be singing your praises in their reviews. And my gosh, if you think about it, an image is really just a stream of numbers broken out into several channels. Take a look at this image here, and you can see how, using our random number generator, I've been able to replace it with just 3 sets of integers for the red, green, and blue channels, respectively. Now, once again, finding the right seed can take some time, and I haven't found the perfect seed just yet. So if you look at the results carefully, you can see that this is not quite a lossless compression scheme. But I think you'll agree that for this kind of savings, these trade-offs just might be worth it. Anyway, I hope you consider using this technique the next time you have data that needs to be compressed. Remember, the more efficient you are with your users' data, the more they'll love you. Thanks again for watching. Be sure to check out other episodes of Route 85. And remember that, as my coworkers on the Android team like to say, perf matters. All right, thanks guys. I think we're done.
Who let him into the studio again?
I couldn't say no to Elijah Wood.
But that's...
Elijah Wood.
People love to use different mobile devices in different ways that suit their situation and lifestyle. Michael uses a phone to play games on the go, while Tony enjoys using a large tablet as he relaxes on the sofa. And Jen carries a small tablet in her purse for reading on the bus. But they all want to use your app on the devices they prefer. So you'll want to make sure they each have a great experience, regardless of screen size, OS version, and the features of the app they use the most. It can be taxing to test each one of these situations so that all your users can be happy. We know you'd rather not have to buy and store stacks of devices and test your app in all these circumstances. That's why we built Firebase Test Lab for Android to make it easy and affordable for you to test your app with a variety of devices and be sure it works great for all your users. Our device lab, hosted in the cloud, offers a variety of physical devices ready to test your app. The selection of devices is always growing, so your tests will stay current with the latest hardware and operating systems. The easiest way to use Firebase Test Lab is to run a robo-test. This is an intelligent, automated test that crawls your app to discover and exercise its features. You won't need to write any additional code to make use of a robo-test. For more advanced testing, you can also script the interactions with your app to simulate specific use cases and verify that everything works as expected. Test results include a detailed report for each device used, including screenshots, device logs, and any crashes that may have occurred during the test. This allows you to verify that your app is working correctly on the variety of devices and configurations you selected. It's easy to make Firebase Test Lab a part of your daily development routine, and we have multiple ways to help you test regularly and spot errors early. First, you can use the Firebase console to upload and test your app. There is also a command line interface for testing with continuous integration servers, so you can automatically test every build. During Android development, you can deploy your app directly to Firebase Test Lab using Android Studio 2.0. And finally, in the Play Store Developer Console, there is a special automated launch test that will run for Android apps published to an alpha or beta channel. To get started using Firebase Test Lab and learn how to regularly test your app on different devices and configurations, you can start with the documentation available right here. Happy testing!
Welcome to the Googleplex. This is an incredible place with lots of great stuff being worked on every single day. Before I worked here, I always wondered what it would be like to come to the Googleplex, meet up with a Googler, and have coffee with them and just chat about what they do, how they do it, and why they do it. And today we're going to do exactly that.
Welcome to Coffee with a Googler. I'm Lawrence Moroney, and I'm here in New York City to meet with Roman Nurik. And Roman Nurik is one of our material design gurus here at Google. So material design, tell me, what's it all about?
Oh, Lawrence, what is material design? Yeah, it's kind of hard to explain. There's actually a video with a bunch of the original designers that created material design, and they get asked the same question, and they don't know how to answer it. It is a complex kind of thing. There's a lot of things going on. I guess at the most basic level, it's a design language. It's a design system. It covers visual, interaction, and motion design. I feel like most design systems, design languages are treated as just visual languages, like here are the colors you should use and so on. But material is much more than that. It really kind of covers the model, the underlying physical model of a UI.
Okay.
So it basically tries to establish this physical environment within which your apps should live, on a phone, on a tablet, on a computer, basically any sort of screen. And then it basically establishes this physical environment in a set of basic rules and principles. And I like to think of it along these kind of 4 basic axes or 4 basic principles. And that's tangible surfaces, or kind of the material metaphor. We could talk about what material is at some point. Also, bold graphic design, this idea that we should take some of the best design ideas from the print world and see how that can help us make really great apps on, on digital devices.
Right.
And the third is meaningful motion, basically how all these things, how the surfaces and the ink on that surface, the graphic design stuff, how that all kind of moves in a consistent way to help communicate what's going on. And the fourth thing, which is to me one of the most important things, is adaptive design, which is how can we take all these first three things and make sure that they work consistently and coherently across different devices, phones, tablets, and everything else.
Now, you have a video, right, of some really good examples of material design being used. So shall we roll that?
Let's roll it.
So some pretty excellent examples there, but it's like, how does somebody reach that level? For someone like me, I'm a developer and my design skills are non-existent. So if I want to become somebody who can build apps with those kind of design, how do I get started?
Well,
how do I learn this stuff?
It's a great question. I think first of all, I just want to, recognize some of those apps they're doing amazing jobs, and they have large teams. Some of them actually have very small teams. Some of those apps are created by one person. So you can absolutely reach that level of quality from these amazing showcase apps, regardless of your team size.
Okay.
But I'd say for the developers and designers out there that are just getting started, there are a lot of great resources out there. There's a great Udacity course that me, Nick Butcher, also from Google team here, and James Williams from Udacity put together. And that's available at udacity.com/Google.
Right.
And there's also a bunch of amazing resources on design.google.com, which will kind of tell you about how to come to Android if you're doing iOS stuff, for example, or how to kind of get started understanding what material design is. There's obviously the entire material design guidelines are there.
Okay.
So I'd say that the first thing, the Udacity course is probably the best kind of first step in getting started. But there's a whole lot of resources out there, and we link to others from the Udacity course.
And Udacity courses, if you're not familiar with them, they are very Socratic in how they teach, right? It's short videos and then challenging you to do something, and then a short video and then getting you to do something. And it's a good way that someone can incrementally learn rather than be thrown into like a huge design doc or something like that, right? So
yeah, it's definitely, there's a very clear progression. We specifically designed that course so that you can kind of start with some of the basics, the most elementary basic things about a screen, like what is a pixel, what is a density independent pixel, and then you kind of ramp all the way up to how do I make everything work on phones, tablets, and so on.
Right, and I have to assume that a design course is well designed, right?
We have some very nice color choices in our slides or our tablet drawings, so hopefully.
So back to material design again. It's like why material? What is it that?
So material goes back to that first principle. Right. So this idea of tangible surfaces, this idea that everything on a on your screen and your device exists on a surface. We like to think of them as pieces of paper. So basically, you can think of basically a sheet of material, or the word material representing one of those pieces of paper. And the reason we don't just call it paper is because it's a lot more than just paper. In the real world, paper, once you rip it up, you can't really just, put it back together, and paper can't go from being, a circle to a square or to a rectangle. And so we like to think of our digital pieces of material or sheets of material as kind of a smarter paper, a more kind of, still a constrained paper. You can't just do anything. It can't just do all sorts of crazy things, but it is a physical thing that exists inside of this kind of environment, this kind of like faux environment, but it is something that has a lot of thought put into it. And so the word material to me really means the sheets of paper that everything in this world exists on. But for me, the main thing to think about, the reason that motion is so important in material design is that motion should always have meaning. Try not to just do like a flip of a button or like a double rotation or something just to kind of draw attention. Every time something moves, it attracts our attention. And so it needs to be really thoughtful and really kind of carefully planned out. And so in material, we use motion, or we kind of use just enough motion to convey the change in some object's state, or try to get a little bit of attention, but just enough motion, not too little, not too much.
I understand Android Studio has some templates to allow developers to at least get started with building material design into their
Absolutely.
apps.
So one of my philosophies for a long time has been, we can write about material design. We can write about a thing. We can make suggestions about that thing, and we can try to teach people about that thing. But one of the best ways to get the thing into people's hands, in this case material design, is to actually just build it into the tools. Just make sure that as a developer that's just getting started, even just on Android, if I just go to File, New Project, or New App, right, I should be able to get the latest and greatest. And so in Android Studio now, we're actually seeing new templates for material design. So you could do File, New Project, and then your default activity templates are going to come with material design in them.
Okay.
So it's going to use the material theme. It's going to use some of the latest support libraries from material design. So things like the Android Design Support Library, things like AppCompat.
Cool.
And so you're just going to get a lot of great stuff for free right off the bat.
Nice. So for someone like me, I'm a coder, not a designer, and so I can use Android Studio, get effectively the scaffolding done for me in these templates, and then learn from something like the Udacity course.
Exactly. I definitely suggest, even before you do the Udacity course, File, New Project, right? Just look around the code, see what you get. I think that's a great way to get started. I always valued, as a kid and growing up learning programming and stuff, I always valued experimentation. So definitely experiment with that. But as soon as you kind of hit some sort of if you hit an obstacle or something, obviously take a look at the guide and the reference and all that. But the Udacity course is a great way to say, you know what, let me just kind of see what Google thinks is the right way to kind of approach understanding this system.
Awesome. Well, thanks, Roman. This has been a whole lot of fun, and I've learned more about material design in the last 5 minutes than I'd had in a year beforehand. So
this is fun. I could always talk about this stuff. So
they've told me that about you.
This is my favorite thing to talk about.
It's cool.
It's been awesome.
And I'm going to check out that Udacity course, and I recommend that you do so too. And if you're an Android developer, take a look at those templates. If you have any questions for me about this, or if you have any questions for Roman about material design or other aspects of building for material design, just please drop us a line in the comments below. Thank you for watching this episode of Coffee with a Googler. For more great episodes of Coffee with a Googler and for more great videos on developer topics, please tune to the Google Developers channel on YouTube. Thank you.
Hello, I'm Timothy Jordan, and you're watching the Day 3 live stream of Google I/O 2016. Stay tuned for more sessions on all 4 live stream channels for the rest of the day. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the live stream between sessions. And if you want us to track someone down with your questions, use the hashtag AskDevShow. Hi there, I'm Timothy Jordan, and you're watching The Developers Show, a special Google I/O 2016 on-location edition. In this episode, we're going to check out the cool stuff going on at the Google Cloud Platform tent. Okay, now I'm at the Google Cloud Platform booth, and I'm about to play Query It with Felipe. And just before we start, I'd like to ask the crowd, is Felipe going to win? No. What about me? The crowd's on my side.
All the different news in the world, everything that is happening, from 30 years ago until the last 15 minutes. What country besides the United States was mentioned with Greece the most last year?
Oh yeah, I know that one.
Not close.
Turkey?
I think you might be right, but...
You're just screwing with me now. Don't let me
They're
win,
super
Felipe.
close. SQL query, analyzing all of the news from last year. This is a real-time query.
So cool. It's also beautiful.
Yes.
I mean, the cool part is how fast it's querying. It's also beautiful.
I do love this animation. 20 gigabytes, analyzed in 20 seconds, over a million. Germany. Turkey. Turkey was the second one.
Okay, now I'm here with Brett, still in the Google Cloud Platform tent, and we're going to take a look at the Cloud Vision API. But first, we need to take a few photos. All right, Brett, so this is the Cloud Vision API detecting facial emotions. Tell me all about it.
So the Vision API does a lot of things, one of which is emotion detection. So it's actually analyzing these faces, and it's going to get us a likelihood of different emotions. So joy, sorrow, anger, and surprise. And it does it by looking at different facial features. So like where your nose is, position of your mouth, position of your ears, and so forth. So we can see in these, it's going to color it appropriately. So this is very likely to be joy, so you can see that there's like yellow on it. This is angry, so it's red, and sorrow, so it's blue. So our photos are starting to come in now, you can see.
That's an angry Timothy.
I would say that it's very likely to be angry. Surprised. And then, what is this one, joy? All right, so it's actually zooming in, and you can see all these dots are actually spots recognized by the Vision API. So midpoint between the nose and eyes and so forth.
That's amazing.
And there's a whole lot of things that the Vision API does. It can analyze images to see what's in a photo. It can tell you, for example, this is a photo of a dog or furniture or chair. It can do text extraction, so you can upload an image and it can read street signs, for example. It'll take a picture of a page in a book and it'll give you the text back. An interesting thing is it can do safe search detection. So you can upload an image, tell you if it's not safe for work. It's powered by the same algorithms.
That's really useful.
Yeah, it's powered by the same algorithms that power Google Safe Search on the web. Yeah.
That's really cool.
So you can plug them in to anything that can make a REST API call. So you can use it from your Android app, you can use it from your web app, from your iOS app. We also have Speech API, which if you use like Google Now and as you talk, like it sort of transcribes your text as you go. So we have a version of Speech API. We've got a Prediction API, Translate API, and a lot more on the way.
Awesome. Thanks, Brett.
Yeah, you bet.
Did you know that the average user has 36 apps on their device and doesn't use 3/4 of them most of the time? And of those, about 1/3 of them have only ever been used once. Well, what if that's your app? You've done the research, you've written the code, you've performed the testing, you've perfected the design, you've gotten the installs, and then nothing. So, how do you prevent this? App indexing helps you re-engage with your users through tight integration with Google Search. As well as appearing in search results, it surfaces your app through autocomplete and now on tap. All you have to do is get your app in the index. And when users search for the content that's already in your app, they'll be able to see your app directly in the search results and be able to launch it right from there. It's as easy as that. But how does it work? If your app and site have similar content, you associate them with each other. Then, your app can receive incoming links from search. On Android, these are achieved using standard Android app links, and on iOS, using standard iOS universal links. When a user searches for your content, they can then find your app. If you have the app installed, it will allow you to link directly to it. When the app launches, it sees the address of the index content and decides which screen to load to show it. It's really as easy as that. You can also use the App Indexing SDK to submit content to the search engine based on how people use your app content. When people use your app, your search position can be improved. With app indexing, you get into the index, putting your app into Google Search, and allowing you to re-engage your users.
Hello, I'm Timothy Jordan, and this is The Developer Show. I'm standing here with Susan Koger, who is the co-founder and chief creative officer of ModCloth. Susan, welcome.
Thank you.
How are you?
I am wonderful.
Me too. So we're going to talk about entrepreneurship and maybe some advice that you have for startup founders that are happening to be watching. But first, and I know you've told the story like a billion times, I'd like to talk to you about the origins of ModCloth. Is that okay?
Yeah, of course.
Okay, so here's my very specific question. You're sitting there in 2002 with Eric, your then boyfriend, now husband and co-founder, and you're thinking to yourselves, wow, Susan's really good at antiquing. Maybe we should spend all of our free time making this into a business. Like, how do you cross from one idea to another?
Yeah.
How did that happen?
Yeah, I love it. Like, I built ModCloth while I was an undergraduate at Carnegie Mellon. You know, just for me and like my style of leadership and like, you know, what I know about myself, I lead very instinctually. And I think we did a lot of things, you know, just me and my husband being in the business and, you know, kind of almost like having a beginner brain kind of approach to things. So you do have to, so I think it was very instinctual at first. You do have to like codify those things and actually step back and think about them and think about, you know, what's working. These are the things that we've kind of just done. What's working from this list? What can actually scale and what doesn't? What needs to go away? What new things need to be added in? You know, for me, it was starting ModCloth, like deciding to work on it full time once I graduated from CMU, because I did it part time while I was at school. You know, I was at the stage where I was like, man, if I can just like do this and I can support myself and maybe, you know, hire a few people to do the stuff that I don't enjoy doing so much, like packing boxes is really fun, but you don't necessarily want to spend 4 hours a day doing it, which is kind of what I was doing when I hired my first employee. Yeah, you know, like I was like, man, if I can just support myself and like create this job and like, you know, let's see where it goes. And it's just like continued to go and grow. And yeah, I feel really fortunate to be able to do it.
Okay, so here's a question based on kind of what you were saying about having like this job for 14 years. I can't imagine it's the same job. And I have some data to back that up. In 2012, 50% growth to 100 million in sales, and in 2015, 150 million in sales. There's no way that you can get that growth and still be doing the same thing every day. But I'm curious, like, what the rate of innovation is. How often does your job change, and how often do you have to find new strategies to grow even bigger or to deal with that growth?
Yeah, it's a really interesting question, and I think there's been so many phases, and I used to feel like my job was changing almost every quarter. Because honestly, it was just like we were growing so quickly. I want to say in 2010, we had 100 people at the beginning of the year, and we hired 150 that year. So we went from like 100 to like, I think 225-ish by the time the year was out. But it's so different, and like there's no way that you can hit the level of scale that we've gotten to, or hit any scale at all, without being able to let other people in and, you know, empower them to do the things that they do really well. So part of the process for me has been learning like how to be a leader. As much as we've gone from nothing to where we're at today with like 350 full-time people across 3 locations, you know, the sales numbers that you referenced, we're still a small fish in the big fashion sea. Like, it's a huge industry, and one that is ripe for innovation, and we're doing things differently and in a very cool way, I think.
Okay, so clearly you've been at this a long time, and you've used a number of different ways to really help keep the spirit of the company alive. Let me just kind of like tag a few of them that I think I heard. One is that you had to be really innovative, and you approached it with like this beginner's mind. Like, that's such a cool idea that it's like, what's the company we want to work at? And you put that into ModCloth from the beginning. And I think the other big thing that I heard is that you built that into the culture, so that throughout it wasn't just like a list of rules, but something people carried with them as part of ModCloth.
Yeah.
Does that sound right?
Yeah.
That's really
definitely.
cool. Okay, I have one more question for you, and this is an advice question. There's somebody out there who was where you were in 2002. They have a passion for something that they think they can make into a successful startup. Where do they start?
I think, you know, the first thing that I would say would be to ask for help and do it all the time and be very concise and know what you're looking for at all times, right? You know, if you're doing something for the first time, if you get better, your taste is going to get better. And you're going to look back on that stuff that you did early and you're going to cringe at it. You know, like I look back at the first logo that I designed for ModCloth at our first website, you know, at our first photo shoots, and I'm just like, oh my God, God, you know, it looks so bad to me now. And I didn't think that when we launched it. You know, obviously, like, I cared very deeply about it. It was the best I could do. So I think that sometimes we get scared to just put something out there because, you know, it's scary, it's vulnerable. You're putting something out there, people might like it, they might not. It's like, oh my God. But here's the thing. If you're gonna succeed, you're gonna get better. So you gotta start somewhere.
Okay, so don't be afraid to ask for help. And you just gotta get out there.
Yep. You gotta get out there and put something out into the world. And you know what? It's probably gonna suck, and that's okay. Or it'll be great, and then you'll look back at it 5 years from now and you'll say, wow, that kind of sucked. I mean, I'm sure, yeah, you know, and then you'll look back at it and you'll be like, oh, this is actually kind of cute and retro.
Susan, thanks so much for joining me today.
Yeah, thanks for having me.
For more information about ModCloth and maybe we can put some of your favorite blogs and blog posts in the notes as well.
Amazing.
Check out the show notes below. See you next time.
What's more fun than pair programming? Asynchronous, remote, massive scale pair programming. In 2011, I presented an I/O session, Pro Tips for Building Context-Aware Apps. Those tips went into a sample app that targets Android Honeycomb and supports Cupcake. That's Android 1.6 if you're keeping track. That covered 98% of active devices in 2011. Today, it's less than 3.2%. Clearly, it's time to do an update. I asked if you'd like to watch me go through the process of updating the app, and you said yes. So, despite some skepticism...
You know they're just trolling you, right? Nobody wants to watch you write code on YouTube.
I don't know, there's like the Facebook movie, Silicon Valley, CSI Cyber, Scorpion. These are all really, really popular, and this is a lot like them.
This is nothing like them.
Well, wait, you haven't been telling people that this is like them, right? Because this is nothing like them. This would be boring.
Strong skepticism. I'm giving it a shot. The result is pivotal. It's a lot like Serial.
It's not like that either.
Each episode is part of a larger story. Having an app targeting an API that's fallen off the sliding scale of relevancy is a great opportunity to replace tricks, hacks, and deprecated APIs with a robust modern architecture. That means integrating the Android support library, the Fuse location provider, the job scheduler, material design, enhanced notifications, Android Wear, and all the features of Ice Cream Sandwich, Jelly Bean, Kit Kat, Lollipop, and Marshmallow. And everything else I don't yet realize needs to be updated. You won't see much of me, but imagine me here, dressed neatly at a tidy desk with a warm cup of tea. Definitely do not picture me with my feet up on a messy desk, and absolutely not me at home in my pajamas. Picture me here, in my happy place.
Rado, we're gonna need you to clear out of here. We've got another shoot. Can't you do this at your desk?
I'm Rado Meyer. Join me on the Android Developers YouTube channel as I bring an old app back to the future, here in my office. Welcome to Pivotal.
There's something really satisfying about getting your app to look great on your device. But just because there's over 11,000 other Android devices out there doesn't mean you need to build 11,000 other layouts to make a great-looking app. Not if you're using responsive UI principles. You may have noticed that I'm not Ian or Joanna. My name is Mike Denny, a design advocate on the Google design team. First things first, thinking about specific phones and tablets is only going to get you into trouble. There's a wide spectrum of devices and not that much difference between the largest phone and the smallest tablet. Instead, think more generally about how much space you have to work with. This can come in 3 different flavors: width, height, and smallest width. Width is super important and should be the basis for breakpoints in designing and building your UI. For example, 600 dp in width is the first point where you could consider having a side-by-side summary and detail level view. Any lower and you won't be giving each level the full attention it deserves. Height is less common when designing responsive UI, but keep in mind that something like a vertically scrolling container is going to be difficult to use if you can only see 1 or 2 elements at a time due to a constrained height. Smallest width, unlike height or width, is designed to be rotation insensitive as it's just the smaller of the 2 values. This gives you a better idea of how much space is available and is an easy way to ensure that your app remains consistent as the device is rotated. You don't want to force your user to relearn your navigation structure every time they rotate their device. This is particularly important in the multi-window world. When your app is resized, your width, height, and smallest width are going to be updated. You might be going from full screen on a tablet down to what amounts to a portrait-oriented phone worth of space. Here's where a good responsive UI can make for a smooth transition. There are a number of common patterns you might consider when building that responsive UI, such as revealing previously hidden content as the screen size grows, transforming your navigation pattern or switching from a list to a grid, dividing your screen into multiple sections side by side, reflowing specific elements, expanding the size or margins of individual elements, or even changing the position of specific elements like a floating action button. Check out the blog post for more details on designing responsive UI and specific patterns you can use to build better apps.
Hey gang, did you know you can send notifications to iOS devices using Google Cloud Messaging? Well, you can! Why would you ever want to do that? Maybe that's a better question. Let's find out the answer on this episode of Route 85. So, notifications. They're a great way for you to engage with your users. They let your customers know you have important new information for them, and when used responsibly, they can be a great way to keep users coming back to your app. But they're not super fun to implement. There's a lot of steps required to set up notifications in the first place. You need logic on both the client and the server, and if you're developing a cross-platform mobile app, and most of you are these days, you have to do this for Android and for iOS. And I'm not just talking about two sets of client logic either. It turns out sending notifications to iOS and Android devices requires different logic on the server too. See, if you've done any notifications work in the past, you're probably used to talking to APNS, that's the Apple Push Notification Service, to deliver notifications to iOS devices, and to GCM, that's Google Cloud Messaging, to deliver notifications to Android devices. And while sending notifications through these two services is similar, they each have slightly different features, use different protocols, accept different message payloads, and return different responses, all of which means that you got to keep track of what kind of device each of your users has and use two completely different code paths to send a notification. Or do you? Well, no. No, you don't. You see, one pretty great feature about Google Cloud Messaging that a lot of people don't know about is that GCM can relay to APNS any notifications you want to send to an iOS device. Now granted, you'll need to do some setup work like upload your APNS certificate to GCM and make sure your client sends its device token to the GCM service. But once you've done that, you can use GCM to send all of your notifications, no matter what platform your target device is, and GCM will deliver your notifications to the correct device using the appropriate service. What all this means is that you don't need to care about what device your user has anymore. You just have to write and maintain one code path, and as we all know, less code means less room for mistakes. But it's not just about using less code. By using GCM to handle your messaging for you, you can take advantage of some of the other nice features that GCM offers to developers, like topics. Topics allow your app to subscribe to notifications about any particular topic that you or your users want to. For example, let's say you've got a weather app and I, as a loyal weather fan, want to be notified whenever there's extreme weather happening in my zip code. Well, in the old way of doing this, you'd probably need to set up a database where you keep track of each one of your users and their devices and their zip codes and do this whole select users where blah 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 query, then loop through the results and send notifications to each device that you get back from this database query. But with topics, none of that's necessary. Instead, your app simply tells GCM that you're interested in subscribing to, say, the weather 94043 topic. Then, next time there's rain in California, for us that counts as extreme weather.
Oh my gosh, there's something coming down from the sky. I don't know if it's water or if it's acid. I can't go out. I don't know how to drive anymore.
Yeah, that seems about right. So yeah, with topics, your server simply tells GCM to send notifications to all devices subscribed to the weather 94043 topic, and I will get notified along with all other devices subscribed to that topic. So there's no database required. Go ahead and throw it out. Oh, as long as you weren't using it for anything else, I guess. I probably should have mentioned that earlier. GCM has other useful features too, like upstream messaging, which allows your app to communicate to your server through GCM. This can be helpful in cases where you might want some lightweight communication from your clients to your server, but don't feel like dealing with the hassle of setting up and maintaining a full-blown server open to the entire world. Or read receipts, where in some, but not all situations, you can be notified that a user has received your message, something you can't normally do through APNS alone. Oh, and in case you're wondering, all this is free, as in please send us $0, and it's using much of the same infrastructure that Google uses for its own apps, so it'll probably scale for yours. So there's a lot to learn when it comes to notifications, and I encourage you to get started here with our Google Cloud Messaging documentation for iOS. We also have a couple of sample applications for you to look at. There's Friendly Ping, our cross-platform chat app powered entirely through Google Cloud Messaging, as well as the GCM Playground, which lets you easily experiment with sending calls through the GCM service. And keep watching Route 85. Maybe you'll see another Google Cloud Messaging video pop up in the future. If only we had some way of letting you know when that happened. Well, I'm stumped. Consider the simple URL. A few years ago, these were pretty straightforward. You clicked on one and 9 times out of 10, you went to a web page. Then things changed. People started using their mobile devices for, well, everything. And these devices in turn started supporting the idea of deep links. Click on one of these deep links and it could take you not just anywhere on the web, but anywhere in an app as well. So you could use a deep link to point directly to a specific restaurant inside a reservation app, or give your new customers a personalized welcome based on the link that brought them to your app in the first place. At least, that's how they worked in theory. In practice, deep linking had issues. The same link wouldn't necessarily work on an iOS or Android device, and they behave very differently, or didn't work at all, for users who didn't have your app installed. And for people who did install your app through a deep link, all of that great link info was typically lost during the installation process, leaving your personalized warm welcome out in the cold. So while deep links were great in theory, their uses were a little more limited in practice. Enter Firebase Dynamic Links. Firebase Dynamic Links are deep links that work the way you want them to. So you can create one single link that behaves one way on iOS, another on Android, and even a third on a desktop browser, and it will take you to a place that's appropriate to that platform. You can also set up dynamic links to change their behavior depending on whether or not your user has your app installed. For users who don't have your app installed, maybe you send them to your website, maybe you take them to the Play Store, or maybe you show them an interstitial describing the benefits of your app before you take them to the App Store for a smoother transition. More importantly, these links can survive the App Store installation process. So if your user installs your app when clicking on a dynamic link, all of that information is still available to you when your user opens up your app for the first time. So what does this mean? It means you can use dynamic links the way you've always wanted to use deep links. You can use them in marketing campaigns, from email to social media to banner ads to, heck, even QR codes. And in addition to install attribution tracking, the kind that lets you know which campaigns are getting you the highest quality users, you can also give your users a customized first-time experience based on the campaign that brought them there. So if a user installs your music app because you showed them an ad for classical music, you can make sure your app takes them right to Chopin's latest hits when they first open it up. Dynamic links are great for sharing too. Your users can use them to share recipes, links to their favorite level in your game, or even coupon codes. In fact, dynamic links are the technology that powers Firebase Invites. And because dynamic links are a Firebase product, you can see their stats directly through the Firebase console. Find out how many people clicked on a link, or use Firebase Analytics to find out which of your users first opened your app through a particular link. To find out more about dynamic links, check out the documentation here and give them a try. And deep link away.
Bitcoin represents a way to transfer money anonymously and at almost no cost. And since it's an arbitrary currency with no nationality attached to it, you're free to exchange it with anyone in the world. What is money? Resources are limited, and they hold explicit value to people. Most resources are physical, and such needed to be traded in a physical form: diamonds, gold coins, chickens, or bikes. At some point, it becomes too difficult to physically transact those objects, and it's easier to agree, collectively, on the value of cash instead of gold. As we know today, this has many advantages. Credit cards and the modern banking basically gave us another abstraction layer on top of cash. There is a centralized system which defines who owns what resources. All of these trades are made virtually. This is the backbone of why Bitcoin is a valid idea. What is Bitcoin? Bitcoin is decentralized, anonymous, digital-only currency that recently received public attention. Bitcoin was originally developed in 2008. Like in any good mystery, someone using the alias Satoshi Nakamoto published a paper describing how Bitcoin could work. There's a very interesting story about this guy too. He must be very smart, but he never came forward to claim ownership or any part of the revenue. Just 1 year later, in 2009, Bitcoin started being traded. Where do they come from? Think about gold. You could buy it or mine it, and it's the same concept with Bitcoin. You do this by using your computer to hunt for 64-digit numbers. By having your computer repeatedly solve complex mathematical puzzles, you're competing with other miners to generate the number that the Bitcoin network is looking for. If your computer generates it first, you receive Bitcoins. The Bitcoin system is programmed to generate a fixed number of Bitcoins per unit of computing time. It is also self-sustaining, coded to prevent inflation, and encrypted to prevent anyone from disrupting its code. In the year 2140, the total number of Bitcoins in circulation will be capped at 21 million. So how much is a Bitcoin worth today? You'll need to Google it. Just type Bitcoin in US dollar, for example. You could also check it out at priv.com. Why are they anonymous? Bitcoin are pseudo-anonymous because they are built upon this centralized system. The Bitcoins themselves are anonymous. The wallets are not. Here's why. The base algorithm creates anonymity, but as the recent court cases show, if your Bitcoin wallet is identified and attached to a person, then someone can go through and track every transaction you've made. Bitcoins exist entirely on their own because there's no central infrastructure to shut down. You are identified by nothing more than your Bitcoin wallet address, a string of randomized letters and numbers. There are absolutely no identifying characteristic beyond that. For the paranoid dude, you can simply create a new wallet for each transaction. Here are some interesting startups that push the technology forward. We are still in the initial phase of Bitcoins, and there are many challenges and opportunities ahead. Exchanges, wallets, merchant services, security, and more. But this is something for another episode. Until next time, eat your vegetables and listen to your partners.
One word that's the bane of both the novice and expert programmer alike: threads. I'm Joanna Smith, and threading can be one of the greatest perf improvements you make, but it will also likely drive you crazy. Tom Sawyer illustrated threading perfectly a long time ago when he needed to paint that fence, because when you've got a large chunk of work to do and it's the same work over and over again, you call in some friends to get it done quickly. So for computations that are taking a long time, consider calling in reinforcements with threads. By allowing multiple threads of execution to operate on your dataset in parallel, you reduce the overall time required to complete the task. With Android, threading becomes especially important because the entire app runs on the main thread, which is also called the UI thread because it updates the UI. And when the UI stops responding, users stop using your app. So, when you want to perform some complex action in response to a button being pushed, for example, you'll want to move that off the main thread until it is finished so that the user can continue to interact with your app. Because there are few things worse than the dreaded application not responding dialog. However, integrating threads into your system is not for the faint of heart. You're going to have to rethink your entire approach to computational complexity and to your memory model in order to properly integrate threads. So, to avoid the rabbit hole, take advantage of the Android framework, which has been built to help you out. Careful thought and planning about your app's structure and flow will enable you to determine whether a thread should affect the UI or be entirely hidden. APIs like Async Task and Thread both help you manage the work and keep your app from hanging, but Async Task will also allow you to affect the UI, like when you want to display a progress dialog. So take a walk through your own app and see if there are places where it stops responding or gets exceptionally slow in response to a user action, and then move all of that extra work off the main thread. But, thoughtfully. Don't just change things willy-nilly. Because while threading may be intimidating, it shouldn't scare you. What is scary, though, is bad performance, which is why you should check out the rest of our Android performance patterns content and consider joining our G+ community for tips, tricks, and help. But most importantly, keep calm, profile your code, and always remember, perf matters.
and welcome to Supercharged. Now this is a kind of TLDW. Last week I did a live stream with Surma where we made some swipeable cards. Now you probably recognize swipeable cards from things like Google Now, where you just kind of take a card and you dismiss it. And you can actually see what I've got on screen. This is what we ended up making. There you go, you see? Dismiss it and all that kind of good stuff. Now the idea is, if you've not got an hour to watch that live stream back, although if you can, I would recommend it, and you can find the link to that below. If you can't, that's exactly what this is for. I want to step through the things that we learned, the things that we did, and just so you can get an insight into what actually went into it. So, before we actually get started, what I want to do is I want to step over to Theory Corner. Oh yeah, theory. Love theory. And what we can do in Theory Corner is discuss what we need to do. Join me. Welcome to Theory Corner. You can tell it's Theory Corner because there's some theory in a corner. Now, this is what we have. We've got the cards. You can tell it's a card because it says card. The cards have will, change, transform on it. The idea I have here is that we want each card to be transformed around the screen. And so we want to give each card its own layer. The compositor then can move those around with the help of the GPU. So long as we stick to transform, opacity, and we set will change, we should be good. So we move the card as you touch and swipe. But as you get across to this side, we have this marker of like 0.35. Now I picked that at random. You could pick a different number. 0.35. If you go past that point, we basically say, well, this card is being dismissed. So we slide it off to the side. The other thing that we're going to do is we're going to change the opacity. So the further you go across, the lower the opacity in both directions. So that works there. Okay, so we're going to put each card on its own layer, and shift it side to side, and fade it out. Let's go back to reality. What we're going to do here is we're going to step into the code so you can actually see bit by bit what we actually did. Here's the cards, and what we do first of all is we basically create an array from the cards that we've got in the document. So we'd have to have some kind of code that adds or removes those cards later on, but don't worry about that. We'll just get on with what we've got here. The next thing to notice is that I've got these named functions on start, on move, on end, and update. Now the first three are our input events, and I choose to do it this way. What I do is I take a copy of it by calling .bind on this, and that takes it from the prototype into the actual instance. But it does another thing for me as well. It means that it's bound to the instance so that in those functions, when I say this dot whatever, it's actually applying to the instance and not to the target's event. No, wait, the event's target. Oh, one of those two. So it also does something else for me. It means that I can do add event listener and remove event listener, and I can call it by name. I can say like this dot on start, for example. You can see that down here in the add event listeners. So I do add event listener for touch start, touch move, touch end, mouse down, mouse move, and mouse up. All of them. Yay! And I can just basically say on start, on move, on end, and so on. And if I wanted to do the remove event listeners, I could do that, and that would just work out fine for me. So we've got our event listeners, and we have a bunch of variables here that are just sort of housekeeping, things that we need to keep a track on. The other thing I do is I start a request animation frame where I busily sort of kind of do an update. Now, if you're doing this in production, I would suggest you don't do it quite like this. I would start the request animation frame when the user starts interacting, and then when the animation's finished, I would stop doing the request animation frame loop. But for the case of this, just to keep things simple, I just start it right at the start, and I do a kind of busy loop through. So what do we actually do in the on start, on move, and on end event listeners? Wow, saying event listeners over and over and over and over and over again, that's not confusing for me. No. What do we do in those? Well, first, in the on start, the main thing is this. We basically take a marker for the start position of the interaction. Where does the user put their finger down on the screen? And then we get that with page X. The other thing we do is we take a copy of that for the current position, because as we move our finger, we're going to update the current position so we know where we started and where we currently are, and the difference is how far we want to transform the card. The other things that we do in this is we set the dragging card to say true, but as we discussed in Theory Corner, we set will change to transform. Now we can check that that actually works by going back to the code, bringing up DevTools, and in the rendering settings, we're going to show layer borders. Anything that's got its own layer is going to go orange around its border. You ready? So when I click, you can see that immediately the card gets its own layer, which is really cool. That means that we can transform and move it around cheaply, like we discussed over there in the Theory Corner. Here's what we've got in the on move. It's fairly straightforward. All we do is we take the current position of the input and we basically say that's the current X. Now inside the update, what we can do is we can say if they're dragging the card, the screen X, which is basically the position of the card on the screen, is the current minus the start. That's basically how far they've moved. And we can apply the transform to account for that. Ta-da! Now, when the user stops interacting, we actually have to make a decision. If you remember over in Theory Corner, we said if the user is past that 0.35 marker, so it's a sort of a 0 to 1 range, 1 being the full distance of the card, 0 being not at all. If they go past 0.35, which is what I've chosen, but you could choose a different number, what we want to say is they are dismissing the card. And we do this by setting a target X, which we use later on in the update. And here we do screen X plus equals the target minus the current screen X over 4. What this is going to do is it's going to ease the card to that final position, which will either be the center or it'll be off to the side, depending on whether we've decided that they've gone past the point of dismissal or not. Then there's a little bit of tidy up that we do here. We basically normalize the drag distance, and we use that to set the opacity so that the further across you get, the more fadey the card is. So good. So the last little bit is what we do when you dismiss the card, because what we want to do is we want to slide all the other cards into place. And we do that with this animate other cards into position function. Let me show you what it looks like without that. I'll switch off the layer borders. Okay, here's what it looks like without that.
I guess I should do that up here. There we go. Hi everyone, how y'all doing? Everyone's having a good I.O., so thanks for coming here. So let's get started with this session. So our session today is all about bringing Android apps over to Android TV. So my name's Wayne Pekarski, and I'm a developer advocate at Google. And I work in areas like TV and cast and the living room and wearables. And my goal is to communicate information about these products to developers, but also to talk to you more and find out about what your needs are and feed them back to the product teams.
So I'm Ryan. I'm a developer programs engineer at Google. And I build things for you guys, you developers, things like tools, API client libraries, and samples, just to make your lives more productive.
All right, so today we're going to assume that you have some knowledge about Android development, because the goal is we're going to teach you how to take your apps and how to get them working on Android TV. So what's the motivation for this talk? Well, I've been talking to lots of developers out there, and I say, hey, have you done an app for TV before? And they're like, oh, I don't think this is something I can do. It's too much work or whatever. And it turns out that most developers aren't fully aware of how similar Android TV is to Android itself. So I thought, wouldn't it be great if we did a talk about this and to show you the small steps that are needed to get your app onto the big screen? So if developers aren't doing this, why is this a problem? Well, right now, there are millions of Android TV devices that are activated out there right now. And the number keeps going up every day. You can buy TVs with Android TV included. You can buy little set-top boxes that include Android TV as well. And they're really cheap and affordable, and a lot of people have these devices in their living rooms now. And these customers are looking for apps to use on their devices. So the important thing here is that if you go to an Android TV device and start up Google Play, not every app in the Play Store will appear on your device immediately. It turns out, as a developer, you actually need to take a few small steps and tell Google Play that your app is ready for TV, and then it'll make your app available. So that's what we're going to talk about today. We're going to show you how to do this, and the good news is that Android TV is really easy to develop for. And so to quote my very famous colleague Ryan here, it's just Android. And so it uses the same SDKs, the same tools that you're familiar with, same Android Studio, and the same emulator tools, so you can get started really easy if you're familiar with Android right now. And so the basics are you got to tweak a manifest file, check a box in Google Play, and your app's ready. So that's the really cool thing about it, and that's what we're going to talk about today. So the other thing is that you can actually make a single APK that you upload to Google Play that supports both TV and phone. That's how similar these things are. So the first thing with this talk that I wanted to sort of point out is that a lot of people think, well, Android TV is only useful for watching TV shows and movies. But I really think there's so much more possibilities for what you can do rather than just those things. So imagine you could browse photos and artwork, you could look at restaurant menus or houses that you're looking to buy, or exploring maps or 3D models or playing computer games. So there's a whole bunch of possibilities that really make the possibilities endless. And so Android TV really breaks down the possibilities of what we thought TV could be used for into so much more other things. And the other thing is that Android TV is the largest screen in your house. Every house has this massive screen that's in the living room, in the center of the house, and so it has huge possibilities for what you can do with it. And so that's what we're trying to encourage today, is for developers to think of new platforms and new ways of taking their apps and getting them out to consumers out there. So today, we're going to help you redefine what a living room experience could be and really create amazing apps. So I'll hand off to Ryan now, and he's going to go through some more of the steps of how to do this.
Thanks. So the first step in bringing your app to Android TV is you're going to need to add a TV banner. This banner is going to provide the launch point for your app on the Android TV launch screen. So here's an example banner that I've taken directly from our sample app, which is available on GitHub. Here is our sample banner alongside some official Android TV apps. This is what it would appear like on the Android TV launcher itself. So there are a couple of requirements that we would like you to follow when you're creating your TV banner. The first is that the banner should be 320 by 180 pixels. That's because Android TV, this is the size that it's going to display it at, and if you make your banner any other size, it's just going to stretch it and skew it in a way that you wouldn't really like. The second is that your app name should appear readable in the banner itself. And the reason for this is, on Android TV, the name of your app doesn't actually appear below the banner. And so we ask that you put it inside the banner itself so that your users can understand what app they're clicking on when they open yours. So it's super simple to add. It takes a single line in your manifest. I'm sure you're familiar with this. In your application tag, just add Android banner attribute and point it at your drawable resource. Super easy, right? So if you did all this and you tried to run your app, nothing would actually happen. Just setting this banner doesn't get your app running on Android TV. And so next I'm just going to talk about how you would declare the activity to launch when you click on the banner. So let's jump into it. So here's an activity. This may be your main activity in your Android manifest. And you have an existing intent filter there with the action main and the category launcher. So here, we're just going to add a second intent filter to your existing activity with the category lean-back launcher. The reason that we actually separate launcher and lean-back launcher is because our best practices is that you're going to create your own TV-specific UI and layouts eventually. However, for the purpose of this talk, we're just going to say, why not get started, throw it in your existing activity, and see how much it works. Like I said earlier, it's just Android, so you'd be surprised by how much works right out of the box. The next big difference on Android TV is the TV hardware itself. So mobile devices, they can make phone calls, they can take photos, they use NFC, they have touch screens. TVs don't have any of these things. At least my TV doesn't have a touch screen. And so for these reasons, we actually need to tell Android that these features that we may have come to expect on a TV or on a phone will not be available on a TV. So the way that we do this is through our uses feature tag. And you guys, I'm sure, are all familiar with this. You declare the hardware features that you would like to use in your app manifest. And this is probably fine. For phones and tablets, it's going to automatically set require to true. However, for Android TV and for TV hardware specifically, this hardware might not be available on TVs. And so we need to update that to required false so that the TV itself knows that, hey, I can still operate without this hardware requirement. So one gotcha, actually, is that the touchscreen hardware requirement is, by default, required true, even if you don't declare that you need it. And so we actually need to take this snippet that you see here and add it directly right into your Android manifest. So another gotcha is that some permissions actually, if you ask for, like, say, a record audio permission, it's actually going to imply this hardware requirement for a microphone. And this makes sense, right? You want to be able to record some audio, so you're going to need a microphone. But you might not actually declare the uses feature itself. And so what we have to do to get around this is just go into your Android manifest, declare uses feature tag, and set required to false. OK, so this is the most important part about bringing your app to Android TV. This is the UI navigation and controls. So with no touchscreen available on TVs, we have to rely on these minimal controls. And this is what brings us to the D-pad. So the D-pad, which also stands for directional pad, is the de facto way to navigate on Android TV. Now, this D-pad is not an entirely new idea. Some of the first phones actually use D-pad for navigation. And when we say navigation, what we're really talking about here is this intuitive change of focus. Touchscreens have revolutionized our ability to, tell our interfaces, when I tap here, I want you to focus and take action at that specific point. However, on TVs, we don't have this same luxury because there's no touchscreen available. So in order to focus, what we need to do is progressively shift our focus from element to element through our UI until we get to the one that we want. And on Android, there are a number of different ways that focus is handled and manipulated. And so I'm going to discuss each one of these briefly. So first thing that you need to know about Android, focus on Android, is this attribute called focusable. And I'm sure you're all familiar with this. In simple terms, though, on Android TV, your users are going to be using a remote. So with any element that you want them to interact with, the element itself should be focusable. And to do that, all we do is we set this focusable attribute to be true. So as an example use case here, where you may be creating some custom playback layout, and it has a play pause button here, which we've represented with an image view. And you're going to want to be able to navigate to that play pause button so that you can eventually click it. So all we do is we just set focusable to true. Now, one thing to keep in mind here, a little bit of a gotcha, is that some views they don't set focusable to be true by default. Image view is one of these. So in this case, we have to set it explicitly to true. Great, so now we can focus and select our play button. But what if we want to, say, press right on the D-pad and have it focus on the fast forward button, or press left and have it focus on the rewind button? So we use these two other attributes, next focus right and next focus left. So by setting these two attributes as shown here, now Android's going to switch the focus automatically when you press those buttons on the D-pad. So there may be other times where you want to create your views directly in Java code. And so specifying this focus in the XML is not going to be available to you. For example, you may be generating a lot of views, like a grid shown here, and you're not going to necessarily be able to declare exactly what I should be focusing on at that specific point. So we need some way to ask Android to change this focus, and we do that through this request focus method, which is available on the view class. So request focus just does exactly that. It asks Android to bring that view into focus if it is focusable. And that's a key point, if it's focusable. So be sure to make sure that that view is focusable set to true before you request focus, or else it won't do anything. So the last thing that I'd like to discuss here about the D-pad is, what if you want to take some arbitrary actions when any key is pressed? So to do this, we're going to override the activity's onKeyDown method. This method fires when any key is pressed that isn't already handled by one of these views inside of your activity. So an example here is that you could combine this onKeyDown with request focus to change focus when any key is pressed. Or a really common use case is if I press play pause button on the remote, it's going to play, I'm going to play or pause my video. Or if you're making a game, like I'm showing here, maybe when you press the right D-pad button, you're going to move your player to the right.
Cool. OK, so Ryan talked you through a little bit about focus and moving things around and so forth. Now we're going to talk a bit about the screen. So it turns out with televisions nowadays, they don't quite operate in the same way that we would expect. You would think that if you've got a 1080 HDMI signal and you feed it through to a screen, that you would get a one-to-one mapping. It turns out that's not quite the case. So I'm going to talk a little bit about something called overscan protection. So if we actually go back in time, back in the days of analog TV, there were these edges on the screen that were not used. And TV stations actually used to embed little signaling and bits of data and things like that in that area that wasn't displayed by the television. It turns out that when we moved to HD, that stuff still happened. And so a lot of TV manufacturers will actually take a TV image and they'll chop off the edges and then stretch the image slightly so it fits the screen. So what this means is that you don't get a one-to-one mapping, and some of the pixels on the edge actually get chopped off. So you can disable this on some televisions. There's overscan or some other feature like that that you can remove with the remote, but a lot of users don't know how to do it. So you need to be aware of the fact that there are some people out there who are not going to see the edges of the screen of your app, and so we need to go about dealing with that somehow. And so if we look at this diagram here, you can see that we have our 1080p overall display, and we've also shown it in terms of DPs, which is device pixels, and then you can show the areas that are not included. And we have a guideline, which is that you should roughly stick to not using the outer 5% of the image, and that's usually a safe thing. So if we look here, you can see we've got some UI elements, and we've got the edges protected so that we don't use them. So once again, a 5% outer area is something that you should reserve, that your app shouldn't put anything important in. Now, if you have a background image, that's okay if that gets cropped, because it's just probably the interesting part is in the center of the screen. So background images can get cropped, but important pieces of text, labels, any kind of important information like that, you've got to make sure that you keep it out of that region. And so here, we have a custom layout XML that we're showing. We've got two relative layouts, and the inner relative layout, if you look at it, is padded with a 5% margin. So you can see we're setting margin top, bottom, left, and right, and we've set DP values that represent that margin, and anything we put inside that inner relative layout will not be cropped off by the television for any reason. Anything else that you don't care about, like the background image we talked about earlier, you can put that in the outer relative layout at the top, and that will possibly be cropped by the television. So this is pretty easy to implement, and it's not really a huge deal, but it's just something you got to keep in mind so that you make sure it works for all users. Next, not everyone programs their Android TV apps using the Android APIs directly. So there's actually a cross-platform gaming engine called Unity that's quite popular amongst game developers. And so the good news for Unity developers is that it actually supports Android TV out of the box. So Unity has support for the D-pad, so all that stuff Ryan talked about with handling the controls, that's already dealt with for you. And it deals with all the manifest tweaks and overscanning and making sure that everything's done right. So there's actually a code lab that we've prepared for Android TV. So if you go behind this auditorium, there is a code lab area where you can go and sit down and try out code and mess around. We have a code lab for Unity there as well that you can give a try. So that's the nice thing, is that a lot of these extra tools and so forth support Android TV out of the box as well. So if you've got a game that does 3D and OpenGL and all that, it just works. So now we'll go to Ryan to talk more about the Leanback library, which is a very popular way of implementing really nice TV UIs.
Thanks, Rain. So, you know, at Google, we're trying to make your lives easier as developers. And we know that you don't really want to implement all this stuff yourself. And so to help out, we created the Leanback library. It has a great selection of UI components that are specifically designed for Android TV. And these components come with support for D-pad, as well as overscan protection, already baked right in. So now I'm going to step through some of these components and explain why you may consider using this library. So the first component here that I want to discuss is this browse fragment. The browse fragment's good for well browsing, right? It allows you to showcase all of your content in one place. And so one of the best places to use the browse fragment is immediately when the user opens this app. So here's an example of it being used in practice. This is what it looks like being run in our Leanback sample live app available on GitHub. And you can see here that there's a sidebar with some header rows and a main grid of content. So if you jump into a category by pressing right on the D-pad, you can see a more detailed view of this content. Here we show some thumbnail images and title and category. These can be basically whatever you want. You could display a rating for your content. You could display a price, anything that you can imagine. So if you select on one of these cards, then that brings us into another fragment that we call the details fragment. So the details fragment presents all of the details for a specific piece of content. It allows your users to take certain actions, anything that you can imagine, like watching, renting, buying this piece of content. So again, here it is in practice, and you can customize, of course, all of these colors, text, buttons, to provide a personalized experience specific to that piece of content. So in this case, with our new dad video, we can click Watch Trailer, and then we get into another fragment that we call the Playback Overlay fragment. So this provides a large customized controls that overlay on top of the media itself. It also provides an at-a-glance view of what's currently playing. So again, here it is in practice. It has a primary row which provides things like play, pause, rewind, fast forward, next video, previous video, as well as a secondary row, such as closed captioning, picture-in-picture. Here I'm showing some thumbs up, thumbs down, and some repeat functionality. And then hidden at the bottom there is a related videos row. This is just a place that you can place, related content to whatever is currently playing. And so this could be where you recommend the next video to play for your user. So if the users can't find this, next great piece of content to absorb in this related video list, then maybe search is the next best thing. And being Google, we want to provide a great search experience. And so we've added the search fragment to the Leanback library. And so here again is it in practice, and we're searching for the word search. And I think the best feature of this whole search fragment is speech recognition capability. So you can use the microphone, which is baked right into the Nexus Player remote, to speak whatever you want and have it immediately fill in the field. So in addition to in-app search, you can also integrate with this universal search. So this is when a user searches from the main TV launcher for some related content, and that will get surfaced automatically by the Android system. So you can imagine you get home, you turn on the TV, and you search funny movies. If your app has some funny movies, you're going to want to surface that to the user. And so to integrate with search, there's just a few things that you need to do. The first is implementing a content provider. And you might already have one of these. Maybe you're already using one for your in-app search. And so you can see our documentation for all the specific rows that we support. But the key thing here is that the provider that you create, you should set this attribute, exported true, so that Android has access to it and can query it when a universal search is made. And then the next thing is this searchable XML. And again, you might already have one of these implemented in your app already. And so what you need to do here is just set this include in global search attribute to true so that Android, again, can access this content. So even before search, your app might actually have a good idea of what the user wants to see next. And so Android TV has this powerful way that we can help, which we call recommendations. So this recommendations bar is featured front and center as soon as the user opens up their Android TV. Android goes through each app and asks, hey, do you have any recommendations that you'd like me to present to the user? And so it takes all of these from each app and it merges them together. And so when a user clicks on a recommendation, which would appear in this bar, it'll immediately open your app to that piece of content. So here are a few recommendations on what you may want to recommend to your users. The first is continuation content. A good example is the next episode in a series, as well as new content, things like new episodes or a new series altogether, as well as popular or trending content. And then related content. This is things like based off the user's viewing history or behavior. And so all of these UI and fragments that we've shown you today, they're available through the Leanback and recommendation support libraries, which if you're using Android Studio, which we highly recommend, you might be familiar with Gradle. Of course, we support these Gradle dependencies, and so you just drop these two lines into your build.gradle, and Gradle will handle everything else. Wayne?
So one common thing I hear from developers when they're asking about Android TV is they're like, oh, hey, I can't develop for Android TV because I don't have a device on my desk. And so while it's nice to have a device, you don't actually need one because the emulator is actually available to help you do your testing. So a lot of people think the emulator also isn't good enough, but it turns out the emulator in Android Studio is actually really good. And so for Android TV, we've done a lot of work in improving its performance, and so it's actually really nice to use this for development. And so what we're going to do now is we're going to show you a quick little demo. So they're going to bring it up on the screen there. So this is Ryan's laptop running the emulator right now. And so this emulator here is the x86 variant. So it's very important that you run x86 when you're on an x86 laptop so that it doesn't have to emulate everything completely. And it's also important that you have the Haxum driver as well. So what you can see here is Ryan's running the sample that I'll give you the link to later. But the sample has a series of video clips, and he's browsing around fragments. And so do you want to fire up a video, Ryan? So this here shows video playback happening. So it's streaming the video, it's decoding it, playing it back within the emulator. So as you can see here, it's very performant. It's decoding the video in real time on his laptop. And so the emulator is quite useful. Also, if we look on the right of the screen, there is the extended controls. So an Android TV has its own remote with left, right, up, down, but it also has back, pause, play, and so forth. All of those controls are available on the emulator as well. So you can simulate every single button press and check that your code has all the right D-pad support and things like that, because not every button necessarily is mapped to the keys. So the great thing is that this emulator does all of the buttons that are available on regular devices, and you don't need to purchase a physical Android TV device. So this is pretty cool, and it's definitely, if you're interested in doing this, you should grab the sample, fire up the emulator, try it out, and then when you're ready, you can publish it, and your app will work really well on real devices too. So once you've built your app, so we've gone through all the different little manifest tags and things like that, we're now at the point where we need to talk about publishing your app to Google Play. So we have the, are we back?
We can go back to
yeah, if we could flip back from the, okay, great, thanks. So now we're going to talk about how to get your app and publish it to the console. So if we go to this slide here, you can see a screenshot showing what the developer console looks like. So this is the same place where you upload your regular APKs that you're uploading from mobile. And there is an option in device categories where it says Android TV. And if you look right at the bottom there, there's a checkbox that says distribute your app to Android TV. So by default, that box is not checked. So if you want your app to be visible on TV devices, you have to check that box as well. That then declares to the Play that your app is ready for TV, and there's a few little conditions there, and you can click on that Learn More link to find out more about what the requirements are. So you submit your app, it gets approved, and then after that, it'll then be available for people to find on Android TV devices. And then they can go to the Play, and then they can search for your app by speaking or typing it in, and then they can install it just like they would on a phone. And updates are rolled out in the same way and everything like that. So it's a pretty easy and painless experience. And as I said earlier, you can either have a single APK that contains all of the resources and activities for both phone and TV, or you can have separate APKs where one has the resources and everything for TV and the other one has for phone. What you do is going to be dependent on who your target market is and how concerned you are about download sizes, and also how much difference there is between the TV and the phone app. If there's no differences in the resources, you can just do a single APK. So we've gone through some guidelines in this talk. The guidelines are actually referenced in the documentation. And there's actually a link here on developer.android.com which has a complete checklist of all of the things that are important to get your app approved to be distributed on Google Play. Now, it's important that you get your app approved because if it's rejected, it won't be visible. So it's very important that you actually think carefully about each of the guidelines to minimize the amount of time it takes for you to get it on Google Play. So let's quickly walk through them and summarize quickly what they are. So Ryan mentioned earlier, you need to have a lean-back launcher in your Android manifest. This declares that your app is ready for TV, and it says what the activity is going to be when someone clicks on your app to start it up. You need a banner image that's 320 by 180 at XHDPI resolution. If you don't use that resolution, it'll be resized for you. You need to eliminate requirements for any unsupported hardware. Remember, TVs don't have touchscreens, so you need to have touchscreen equals false. And any other requirements you have, like if your app uses GPS, you're going to have to set that to false as well. And make sure that if your code is doing something like grabbing a location, check for errors to make sure that you don't accidentally fail and throw an exception. So as part of the new transition to the new permission model, apps have to check a lot more for these things. The same kind of thing here. You've got to make sure you don't expect a device to be available when it's not. Next thing, ensure any permissions you add don't add hardware requirements as well. Certain permissions like record audio that Ryan showed earlier also have requirements that you have to manually set to required equals false. Next, you can't assume that your app is running on a portrait device. Like a phone runs as a portrait orientation, and some apps lock themselves so that they don't run in landscape mode. It's very important, because a TV is a landscape device, that your resources are configured correctly for screens like that. Next, you really need to think about viewing everything from a distance. So this is no longer something that you're running very close to your face. It's running on a screen that's very far away in someone's living room. So you really need to think of large fonts and easy to read text and large images, and you should test it. So try to step back from the screen and check that it's actually readable from a distance like that. You know, some people have poor vision. They're not going to be able to read super tiny writing like that. Next, make sure you think about overscan. We talked about that before. Make sure you don't put anything important within the outer 5% of your screen. And so lastly, think about implementing the lean-back user interface. So if you've got an app that's like a game, you probably don't need to. But if you're building some kind of browsing, something that goes through media or food or pictures or photos, make sure that if you want to really make it integrate into the Android TV experience, that you use the lean-back library. Because the lean-back gives a consistent UI across the whole device, that it'll look the same between other apps and also with the Android TV system itself. So those are the guidelines, and that link up there is available in the documentation. You should definitely look through them when you're getting ready to publish your app. So that was a really quick overview of how to bring your app over to Android TV. So I hope you found it inspiring, and it sort of gave you some ideas as to how to think about taking your app and what would be involved in making the change. It's not really hard to do, there's just a few little things. So how do we get started with this? Well, the first thing is the talk's being recorded, so if you want to review everything later on, you'll be able to go back and go through everything. But we also have a lot of other great resources which are shown on this slide here. So the first thing we have is the documentation site. So on developerandroid.com, we've got training guides that sort of give an overview and sort of summarize some of the things we've said today. And then we also have the lean-back sample. So it's on GitHub and the Google samples. It's called Android TV Lean-back. And that demo that Ryan showed earlier is that sample there. So you can play with it, see how the videos stream, see how it works for you. And it's a really great way to sort of see how a well-built app works, and you could probably tear it apart and put your own code in there and so forth. The next thing I mentioned, we have the code labs in the other area where you can go over there and you can try out, you can sit down, play with some devices, and there are actually engineers on staff there who can help answer your questions as well. And we also have the sandbox. So there is an area over there with these large metal box crate things that we have an area showing TV and cast devices. Feel free to come by there, and we have people who work on the actual Android TV team ready to answer questions there as well. And also people like me and Ryan will be there too. So we're getting to the end of the day, so there's not too much time left, but please do come by after the talk and come have a chat with us, because the whole point of Google I/O is we want to share information with people and get information from developers. If you've tried to do Android TV and something didn't work out for you, come and tell us what happened so that we can think about it and maybe come up with a solution for you. And finally, for people who can't come here or for later, we have a great developer community on Google+. So the link is g.co Android TV Dev. And it's a great place where we post articles about what's coming up, what's new, and also it's a place where you can ask questions and chat with other developers, and it's a really good way to keep up to date. And finally, Me and Ryan have our Google Plus profiles up there as well. And definitely I recommend you follow us because I post a lot of articles about TV, but also I do wearables and auto and all these other things. And there's a lot of commonality between the platforms that Google offers. And so if you've got a phone app, you should consider TV and auto and wearables because these are all new, exciting platforms where users are waiting for really cool and exciting apps. And so there's definitely lots of really awesome things to do. So that's the end of our talk. So we have a few minutes for questions. We have some microphones up there if anyone wants to step up, and we'll be happy to answer them.
Thank you.
Thank you.
Hello, I'm Timothy Jordan, and you're watching the Day 3 live stream of Google I/O 2016. Stay tuned for more sessions on all 4 live stream channels for the rest of the day. We'll also be on the ground and behind the scenes finding the coolest and most innovative things to share with you right here on the live stream between sessions. And if you want us to track someone down with your questions, use the hashtag AskDevShow. Hi there, I'm Timothy Jordan, and you're watching The Developer Show, a special Google I/O 2016 On Location edition. In this episode, we're going to check out the cool stuff going on at the Google Cloud Platform tent. Okay, now I'm at the Google Cloud Platform booth, and I'm about to play Query It with Felipe. And I just, before we start, I'd like to ask the crowd, is Felipe going to win? No. What about me? The crowd's on my side.
Get ready. Gee there. All the news in the world, everything that is happening from 30 years ago until the last 15 minutes. What country besides the United States was mentioned with Greece the most last year?
Oh yeah, I know that one.
Not close.
Turkey?
I think you might be right, but...
You're just screwing with me now. Don't let me win,
super
Felipe.
close. SQL query, analyzing all of the news from last year. This is a real-time query.
So cool. It's also beautiful.
Yes.
I mean, the cool part is how fast it's querying. It's also beautiful.
I do love this animation. 20 gigabytes, analyzed in 20 seconds, over 1 million. Germany. Turkey. Oh! Turkey was the second one.
Okay, now I'm here with Brett, still in the Google Cloud Platform tent, and we're going to take a look at the Cloud Vision API. But first, we need to take a few photos. All right, Brett, so this is the Cloud Vision API detecting facial emotions. Tell me all about it.
So the Vision API does a lot of things, one of which is emotion detection. So it's actually analyzing these faces, and it's going to get us a likelihood of different emotions. So joy, sorrow, anger, and surprise. And it does it by looking at different facial features. So like where your nose is, position of your mouth, position of your ears, and so forth. So we can see in these, it's going to color it appropriately. So this is very likely to be joy, so you can see that there's like yellow on it. This is angry, so it's red, and sorrow, so it's blue. So our photos are starting to come in now. You can see
that's an angry Timothy.
I would say that it's very likely to be angry. Surprised. And then what is this one? Joy. All right, so it's actually zooming in, and you can see all these dots are actually spots recognized by the Vision API. So midpoint between the nose and eyes and so forth.
That's amazing.
And there's a whole lot of things that the Vision API does. It can analyze images to see what's in a photo. It can tell you, for example, this is a photo of a dog or furniture or chair. It can do text extraction, so you can upload an image and it can read street signs, for example. It'll take a picture of a page in a book and it'll give you the text back. An interesting thing is it can do safe search detection. So you can upload an image, tell you if it's not safe for work. It's powered by the same algorithms.
That's really useful.
Yeah, it's powered by the same algorithms that power Google Safe Search on the web. Yeah.
That's really cool.
So you can plug them in to anything that can make a REST API call. So you can use it from your Android app, you can use it from your web app, from your iOS app. We also have Speech API, which if you use like Google Now and as you talk, like it sort of transcribes your text as you go. So we have a version of Speech API. We've got a Prediction API, Translate API, and a lot more on the way.
Awesome. Thanks, Brett.
Yeah, you bet.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 live stream. It's been a great day so far, and there's lots more to come. Stay tuned on all 4 live stream channels for sessions throughout the day. We'll also be on the ground and behind the scenes, finding the coolest and most innovative things to share with you right here on the live stream between sessions. And if you want us to track down somebody with your question, use the hashtag AskDevShow. Hello and welcome to the Developer Show. I'm Timothy Jordan, and I'm standing here with Mary Grove, Director of Google for Entrepreneurs.
Hi, Timothy.
Hi, Mary. How are you?
I'm great. Thanks for having me.
Thanks for being here.
Absolutely.
Okay, let me jump to a question about Google for Entrepreneurs. It's been on my mind for a little while because developers ask it,
Right.
and I think it's fair, and I think we should give them an answer. Why is Google doing this?
It's a great question. I'm glad you asked. So there's 2 ways that I look at that. One is if you look at Google's own history, our own journey as a company, entrepreneurship is such a core part of our DNA, right? Google began as a startup in a garage now almost 20 years ago. We are a company founded by entrepreneurs, built by entrepreneurial people, and then makes sense that we are passionate about empowering the next generation of startups like Google to become successful, to launch, to use the internet to grow their business. So that's the first reason. The second reason, though, is actually an economic one, right? We believe that by investing in communities, long-term investing in startup communities, these are the next set of companies who are going to come online, use the internet, leverage Google's products as well. So really it's this notion that all boats rise, and long term it's also going to benefit our own business too.
Now, before you were the director of this huge, amazing thing, you were a BD principal at Google. And I'm curious, what did you learn doing those global partnerships that brought you into this new job?
Sure. So my personal story with entrepreneurship begins with my parents. So my parents are both immigrants from Thailand, and they moved to America, sort of personify the quintessential American dream. They were entrepreneurs and really showed me firsthand that you can really, create whatever future you dream for yourself. So at Google, fast forward many years later, I was working in new business development, as you said, looking at emerging markets for Google. And everywhere we worked, we looked for 3 things. One is how can we increase access, so internet and mobile penetration. 2 is how can we increase content created from these regions. And the third bucket, which was my personal sort of passion, was entrepreneurship. So how can we work with students, developers, any emerging entrepreneur ecosystem to really help them create the next generation of companies and really create and grow their own economies.
So let's say you're a budding entrepreneur out there with an early stage startup. What's your first step getting help from Google?
There's many ways to look at that, right? There's so many amazing groups and networks that Google has. Of course, Google developer groups being one of them, Women Tech Makers being another great example. We, at the heart of it, are a technology company, so we hope that our products, our platforms can help you be successful. Beyond that, in the Google for Entrepreneurs umbrella, our mission is really about bringing together startup communities. So working with partners of all types, whether that's physical space, co-working, tech hubs, to accelerators and educational curricula. We try to knit together this global partner community of about 50 organizations who are supporting entrepreneurs. So we encourage you to get involved with one of them. For example, Techstars is a global accelerator running all sorts of programs ranging from Startup Weekend to their vertical accelerators. And you can find all these resources on our website, which is google.com/entrepreneurs.
Awesome. Is there anything else that you'd like to say about the program that you don't often get to talk about?
I think that we're based here in Silicon Valley, but Google is truly a global company. The internet has really democratized access to entrepreneurship, right? You can launch a company from Sao Paulo, Brazil, and have users in Seoul, South Korea instantly. And so what I would say is we passionately believe that entrepreneurship's thriving all over the world. It's about getting more access, getting more opportunity, and helping companies really go global from day one and think about their market opportunity as not just their city, their country, but really the whole world.
Mary, thanks for joining me today.
Thanks, Timothy. Thanks for having me.
For more information about Google for Entrepreneurs, make sure to check out the show notes for all the links that you need. I'm Timothy Jordan, and I'll see you next time.
We all know from experience that people love to share things about themselves, such as photos, videos, and GIFs that express their feelings. So what do you do to let them store and share these files through your app? That's where Firebase Storage can help. Our storage API lets you upload your users' files to our cloud so they can be shared with anyone else. And if you have specific rules for sharing files with certain users, you can protect this content for users logged in with Firebase authentication. Security, of course, is our first concern. All transfers are performed over a secure connection. Also, all transfers with our API are robust and will automatically resume in case the connection is broken. This is essential for transferring large files over slow or unreliable mobile connections. And finally, our storage, backed by Google Cloud Storage, scales to petabytes. That's billions of photos to meet your app's needs, so you will never be out of space when you need it. So give your users space to share their lives with Firebase Storage, available right now for iOS, Android, and web applications. And to learn more about Firebase Storage, check out the documentation available right here.
So service workers are powerful for offline caching, but they're also really good for giving you instant loading performance benefits when it comes to repeat visits.
Yep.
Right. And you can achieve that using an application shell architecture.
Yeah.
Now,
so that's kind of the idea of kind of separating content from the actual visual UI. So in my head, it's kind of like native apps. You always have the banner, you've got the navigation drawer at the side, you might have some other bits. That could be common through like 90% of your app.
Yeah.
You always want it there.
So when we talk about the shell, we're talking about the HTML, the CSS, and the JavaScript that's making up the bulk of your UI.
Yeah,
Stuff that, you know, if you cache that, you can still just like load up content in the very middle.
Yeah.
And save yourself having to constantly reload that stuff, right?
Yeah, and it's super nice when it comes to like, let's say they're visiting a page they've never been to before. If you know the layout's always going to be the same, you can still load that while you go and get the content in the background.
And it just makes sure that your user has like really good perceived performance.
Yeah.
So the first time your app loads, you're going to have to render the shell itself. You'll cache that in your service worker, and you might show like a toast just to let them know, hey, this application now works offline.
Yep.
And that means that when they come back another time, like let's say they're in airplane mode, that shell will load up really, really quickly, and then it might go to the network to fetch the rest of the content. You can then cache that content so that that entire view is then available whenever they try accessing it without a network connection.
Yeah, exactly. Spot on.
We've got some performance testing we've done with the application shell model. This is using web page tests. So on first visit, we've got a relatively fast time to first meaningful paint.
And this is super important because I think that there can be scenarios where someone might take advantage of Service Worker to be like, don't worry about your first load, but I'm just going to serve up like megabytes of stuff that I'm going to cache. Afterwards, you'll be super fast. But that first load, if that takes so long to the point where the Service Worker doesn't even get registered, that's pointless. And plus, for other browsers that don't support Service Worker, you're then kind of just damaging yourself.
Yeah, that's going to make your users go and cry in a corner.
Exactly.
You don't want that.
So you still want to be serving up just that static render of your site, just so then it just loads up as fast as humanly possible, and then progressively enhance with Service Worker to then use the app shell model.
And if you are using the app shell model, as you can see here, we've got really good, we've actually slashed our load times for first meaningful paint on repeat visits. Speaking of like actually taking a look at what impact server-side rendering has on this, you don't have to use Service Worker to actually be able to get good gains. If you're building with the app shell model in mind, with server-side rendering in mind, you will get like a really good first paint, even in like Safari and like mobile Safari on iOS.
Yeah, all the other browsers that just don't have Service Worker.
Yeah. Now, if you're wondering, okay, well, should I be using the application shell model on all of my applications? There are going to be types of apps, like super simple apps. This might be overkill.
Yeah.
But if you're building something that's, a little bit more complex, a little bit more dynamic, this type of model makes a ton of sense. At Google, we're using it for things like inbox, and it's working really well there.
Yeah, I think it's one of those things you end up falling into sit there and figure out whether it makes sense for your site or not. But I think it's a good overall model that works for a lot of different scenarios.
There's a whole ton behind this model that we way too much to explain in just one video, but we wrote up a pretty amazing article on this, if we do say so ourselves.
Well, you wrote it up and I just read it. So
you just added your name to the end of it.
Yeah, that's how I
pretty
roll.
much. Impact. That's worth checking out.
That's the format of this
It's
show,
a mediocre article at best, but it's got pretty graphics.
Yes, it does.
People should go check that out.
Yep.
Learn more about AppShell.
And then there's also the Getting Started guide for your first progressive web app, where it actually talks about the application shell model, how you can take advantage of it, as well as how it applies to the demo app that you can build in this lovely code lab.
Yep. And in that article, we also link out to tools that can help you get started with the application model really quickly that we're working on. So check that out.
Yeah, build a weather app.
So what if I told you there was a way you could compress nearly any stream of data by a factor of 10x or more? Wouldn't that be something you'd be interested in? Yeah, I thought so. Let's find out more on this episode of Route 85. So I want you to take a look at this array of numbers here. Imagine that we wanted to send this array of integers from a server to your user's device. Looks like just a bunch of random numbers, right? Well, that word random is actually the key to compressing these in an incredibly efficient manner. As you probably know, a random number generator isn't truly random. Supply a random number generator with the same seed, and you'll get the same results out every time. And we can take advantage of that fact to recreate that list of integers using a random number generator. You see, all I need to do to regenerate that array on a device is to supply 3 parameters: the seed for an agreed upon random number generator, an upper bound to apply to these results, and the length of the list. I simply supply those numbers to a method that looks a little like this, and I can recreate that original number stream. Just like that, I've built my array of 30 integers using just 2 integers and an int 32. That's a 92% compression rate. Now granted, finding that initial seed did take some work, but you know what? That work can happen in the cloud, so it doesn't really matter. What's important is that on the device, I'm able to decompress that number stream in order and time. And then, of course, once you start looking around, you can see that there's a ton of data you can compress this way. I mean, need to compress a text string? Well, what's a string but a stream of encoded integers? Once I have my stream of integers, I simply figure out what seed I need to generate them, and voila, I've compressed my string down into just 3 numbers. It's a pretty amazing savings, right? Anybody with the username of stidjexmisdizixgoodquibpubpa will be singing your praises in their reviews. And my gosh, if you think about it, an image is really just a stream of numbers broken out into several channels. Take a look at this image here, and you can see how, using our random number generator, I've been able to replace it with just 3 sets of integers for the red, green, and blue channels, respectively. Now, once again, finding the right seed can take some time, and I haven't found the perfect seed just yet. So if you look at the results carefully, you can see that this is not quite a lossless compression scheme. But I think you'll agree that for this kind of savings, these trade-offs just might be worth it. Anyway, I hope you consider using this technique the next time you have data that needs to be compressed. Remember, the more efficient you are with your users' data, the more they'll love you. Thanks again for watching. Be sure to check out other episodes of Route 85. And remember that, as my coworkers on the Android team like to say, perf matters. All right, thanks, guys. I think we're done.
Who let him into the studio again?
I couldn't say no to Elijah Wood.
But that's...
Elijah Wood.
Hello, I'm Timothy Jordan, and you're watching the Google I/O 2016 live stream. It's been a great day so far, and there's lots more to come. Stay tuned on all 4 live stream channels for sessions throughout the day. We'll also be on the ground and behind the scenes, finding the coolest and most innovative things to share with you right here on the live stream between sessions. And if you want us to track down somebody with your question, use the hashtag AskDevShow.
Last episode, we used a decision tree as our classifier. Today, we'll add code to visualize it so we can see how it works under the hood. There are many types of classifiers you may have heard of before, things like neural nets or support vector machines. So why did we use a decision tree to start? Well, they have a very unique property. They're easy to read and understand. In fact, they're one of the few models that are interpretable, where you can understand exactly why the classifier makes a decision. That's amazingly useful in practice. To get started, I'll introduce you to a real dataset we'll work with today. It's called Iris. Iris is a classic machine learning problem. In it, you want to identify what type of flower you have based on different measurements, like the length and width of the petal. The dataset includes 3 different types of flowers. They're all species of iris: setosa, versicolor, and virginica. Scrolling down, you can see we're given 50 examples of each type, so 150 examples total. Notice there are 4 features that are used to describe each example. These are the length and width of the sepal and petal. And just like in our apples and oranges problem, the first 4 columns give the features, and the last column gives the labels, which is the type of flower in each row. Our goal is to use this dataset to train a classifier. Then we can use that classifier to predict what species of flower we have if we're given a new flower that we've never seen before. Knowing how to work with an existing dataset is a good skill, so let's import Iris into scikit-learn and see what it looks like in code. Conveniently, the friendly folks at scikit provided a bunch of sample datasets, including Iris, as well as utilities to make them easy to import. We can import Iris into our code like this. The dataset includes both the table from Wikipedia as well as some metadata. The metadata tells you the names of the features and the names of different types of flowers. The features and examples themselves are contained in the data variable. For example, if I print out the first entry, you can see the measurements for this flower. These index to the feature names, so the first value refers to the sepal length and the second to sepal width, and so on. The target variable contains the labels. Likewise, these index to the target names. Let's print out the first one. A label of 0 means it's a setosa. If you look at the table from Wikipedia, you'll notice that we just printed out the first row. Now, both the data and target variables have 150 entries. If you want, you can iterate over them to print out the entire dataset like this. Now that we know how to work with the dataset, we're ready to train a classifier. But before we do that, first we need to split up the data. I'm going to remove several of the examples and put them aside for later. We'll call the examples I'm putting aside our testing data. We'll keep these separate from our training data. And later on, we'll use our testing examples to test how accurate the classifier is on data it's never seen before. Testing is actually a really important part of doing machine learning well in practice, and we'll cover it in more detail in a future episode. Just for this exercise, I'll remove one example of each type of flower. And as it happens, the dataset is ordered so the first setosa is at index 0, and the first versicolor is at 50, and so on. The syntax looks a little bit complicated, but all I'm doing is removing 3 entries from the data and target variables. Then I'll create 2 new sets of variables, one for training and one for testing. Training will have the majority of our data, and testing will have just the examples I removed. Now, just as before, we can create a decision tree classifier and train it on our training data. Before we visualize it, let's use the tree to classify our testing data. We know we have one flower of each type, and we can print out the labels we expect. Now let's see what the tree predicts. We'll give it the features for our testing data, and we'll get back labels. You can see the predicted labels match our testing data. That means it got them all right. Now keep in mind this was a very simple test, and we'll go into more detail down the road. Now let's visualize the tree so we can see how the classifier works. To do that, I'm going to copy-paste some code in from scikit's tutorials. And because this code is for visualization and not machine learning concepts, I won't cover the details here. Note that I'm combining the code from these 2 examples to create an easy-to-read PDF. I can run our script and open up the PDF, and we can see the tree. To use it to classify data, you start by reading from the top. Each node asks a yes or no question about one of the features. For example, this node asks if the petal width is less than 0.8 centimeters. If it's true for the example you're classifying, go left. Otherwise, go right. Now let's use this tree to classify an example from our testing data. Here are the features and label for our first testing flower. Remember, you can find the feature names by looking at the metadata. We know this flower is a setosa, so let's see what the tree predicts. I'll resize the windows to make this easier to see. And the first question the tree asks is whether the petal width is less than 0.8 centimeters. That's the fourth feature. The answer is true, so we proceed left. At this point, we're already at a leaf node. There are no other questions to ask, so the tree gives us a prediction, setosa, and it's right. Notice the label is 0, which indexes to that type of flower. Now let's try our second testing example. This one is a versicolor. Let's see what the tree predicts. Again, we read from the top, and this time the petal width is greater than 0.8 centimeters. The answer to the tree's question is false, so we go right. The next question the tree asks is whether the petal width is less than 1.75. It's trying to narrow it down. That's true, so we go left. Now it asks if the petal length is less than 4.95. That's true, so we go left again. And finally, the tree asks if the petal width is less than 1.65. That's true, so left it is. And now we have our prediction. It's a versicolor, and that's right again. You can try the last one on your own as an exercise, and remember the way we're using the tree is the same way it works in code. So that's how you quickly visualize and read a decision tree. There's a lot more to learn here, especially how they're built automatically from examples. We'll get to that in a future episode, but for now let's close with an essential point. Every question the tree asks must be about one of your features. That means the better your features are, the better a tree you can build. And in the next episode, we'll start looking at what makes a good feature. Thanks very much for watching, and I'll see you next time.
thing I see over there, that's me standing in the mirror. What's that acid thing hanging around my neck? That's gold. Show me some respect. Oh, I thank God every day that I woke up feeling this way, and I can't help loving myself, and I don't need nobody else. Nuh-uh. If I was you, I'd wanna be me too. I'd wanna be me too. I'd wanna be me too. If I was you, I'd wanna be me too. I'd wanna be me too.
25-ish maybe.
Hey, good afternoon. I'm Alex Russell. I'm a software engineer on the Chrome team. I've been a software engineer on the Chrome team for longer than I should probably admit on a stage this big. But these days, I lead the team that has helped bring progressive web app technologies to Chrome in collaboration with folks in the web development community and our partners at other browsers. And if you saw Rahul and Dave's talk yesterday, what you may have taken away from it is that we're serious about helping you adopt and succeed with two technologies this year: progressive web apps and accelerated mobile pages, or AMP for short. We don't have time to get into all the technical details about each of those technologies today, so I recommend that you check out Jake Archibald's talk on progressive web app architectures and instant offline, and Malte Ubel's talk on how AMP achieves its performance. They go into details that I wish I could had all the time today to get into, but What we're going to talk about today is end-to-end performance across multiple pages and, in some cases, even across multiple sites. How we can build reliable experiences for users. So I think we all know that performance is money, and we kind of know it intuitively. But the data really helps sort of drive it home, and a big shiny graph doesn't hurt either. Soasta has shared this data with us, and what it shows is that users who experience slow sites bounce away from those sites much more frequently than users who experience fast pages. So we talk about fast and we talk about slow, and frequently we use confusing terms for that. Do we mean when something's loaded, how smoothly it animates? Do we mean how responsive it is to me tapping on a button? Something different than that? What do we mean when we say something is fast or it has good performance? To get clarity on this question, last year, Paul Lewis and Paul Irish introduced the RAIL model for web application performance. And RAIL is an acronym that stands for Response, Animate, Idle, and Load. Because we like acronyms, I guess, on the Chrome team. Apologies. But to recap, RAIL, the R stands for respond. We want to respond within 100 milliseconds to any user action. We also want to animate at 60 frames a second, which means that we have to get frames on screen consistently every 16 milliseconds. Now, the browser has to do some work when we go and change HTML, CSS, or DOM, and that means that it has to reapply that change and then go paint that all the way out to the screen. And so we've probably got less than the 16 milliseconds. A good rule of thumb is to try to get your main thread work for animations done in 8 milliseconds, or half the total frame time. We also want to avoid timers that run forever in the background, waking up the CPU, burning a hole in your pocket, draining your battery quickly. And so when we're idle, we want to do work in collaboration with the browser, but we also want to break that work up into small chunks, preferably around 50 milliseconds each. At that size, we can make sure that when the user taps next time, we can respond within the 100 millisecond window. The last bit of RAIL is load. We're going to talk a lot about loading today. The goal here is to try to get something to the user within a second. If it takes longer than a second, the user starts to lose focus. The user experience research on this is decades old now and pretty conclusive. People aren't able to really keep themselves in the task that they were trying to accomplish. So, if you aren't familiar with Ilya Grigoruk's high-performance browser networking, I recommend that you read it. It's maybe a good thing to put you to sleep at night someday, or something to read on the way home from I/O. But it goes into great depth and has lots of research about how mobile networks specifically conspire against us. And Ilya's research shows that because of resource transitions at the radio level, DNS, TCP, HTTP, and TLS setup, it may never be possible for a user on a 2G or a 3G connection to hit the L, to hit that 1 second load time. You can't even get Hello World done in that case if you have to transition out of a low power state on a mobile device. And Ilya said something to me the other day that really rang true, which was that a 4G user isn't a 4G user most of the time. And I commute using public transit in San Francisco, and I take a train that is occasionally connected. I see my phone jumping through a bunch of states all the time, and it frequently starts on LTE as I descend into the station, and then I go down to the train, I get 3G for a bit, and then I'm off, and I'm back onto something else. It gets up to 3G again, and then it transitions up to LTE. Even when I have those full bars on that 3G connection, it can still take seconds for something to come back. And the reason for that delay is the radio resource control and all of that setup time. So the web isn't today particularly reliable, even when we have full bars. It's also the case that we wind up using language that is confusing about what it means to be loaded. So even if we're trying to measure this experience, it's a little bit difficult because we don't share a common vocabulary. Some people say loaded, they might mean DOM content loaded. You'll see this in DevTools. And DOM content loaded is when most of the work has been done to construct the DOM, but if you've got asynchronous scripts, or if you're delay loading content, that may not actually correspond to what the user cares about. Same for onload. Onload doesn't take into account potentially the fact that you've got asynchronous work happening. So the structure of your page matters and makes these not necessarily reliable indicators of loading. There's DOM stability, which you can think of as like when it's actually sort of finished constructing, or visually complete. This is what a lot of industry professionals use when thinking about web page performance today, because it's less subject to the same sort of error in gaming that you see from other things. But visually complete doesn't mean interactive. A thing can be visually complete, and I can't maybe use it. I think what we really care about when we say something is loaded is time to interactive. When can I start using this thing? You put something on page, when can I tap? Our tools today take us away from that time to interactive goal in some really weird ways. And we're starting to see a new generation of frameworks and tools that are optimized for that first experience, that first paint, but it may not be interactive. Paul Lewis illustrated this pretty brilliantly on Twitter the other day, and I'm shamelessly borrowing his charts. And this is basically the first architecture that you could choose. Our tools make this possible today pretty fluidly. You can go and build a single page application, which trades away initial load time for eventual fast interactivity. And this is great. Once that initial JavaScript is loaded, I can do things in Gmail very quickly indeed. But I have to wait a long time. So this is great for experiences that you live in, but it's terrible for experiences that are transient. When you just want a thing, watching the loading bar is basically the worst thing in the world. More and more, we're seeing the uncanny valley, which is where you have a server-side framework that takes application state, it dehydrates it into some HTML that captures the current view state, re-inflates it on the client side, and then from there, it boots up all the JavaScript to finally make it interactive. This is super unsatisfying. And it's particularly unsatisfying on low-power devices, on flaky networks, like phones. So I think what we're really after is interactivity. The pattern, the purple pattern that Taylor Savage showed you yesterday, really highlights how we can do better here by putting interactive pixels on screen and only loading the resources that we need right now. It's also the case that articles wind up in this uncanny valley today because of third-party content. AMP was designed explicitly to address this for article content. So AMP and Purple and a lot of the new technology we're putting into browsers and into the web platform are necessary because today the web is slow. The web feels terrible because there's all this third-party stuff. It's all analytics, tracking, poorly structured pages, badly considered font decisions. And it's easy to miss how bad this is because we wind up doing most of our development and dev tools on the desktop. So the computer that I lug around with me every day is a quad-core i7 MacBook Pro. It's got 6 megabytes of L3 cache. It's got 4 cores that have a 14 deep instruction pipeline. It can dissipate 47 watts. It's got a GPU that's a separate chip. The other device I carry with me all day, every day, is my Nexus 5X. And if that thing dissipated 47 watts, it would release the magic smoke that causes computers to work. So these differences are everywhere, and they're most obvious in script execution. This is why mobile is harder than it looks. Here, for instance, is last year's I/O site. It was made with a pre-1.0 version of Polymer. Polymer's gotten a lot faster since. But what we'll see here is that we get DOM content loaded at 700 milliseconds on my desktop on a Wi-Fi connection. This is a fast connection. This is a fast machine. This looks great. That animation after onload, that onload happens at 1.5 seconds, and that animation is super smooth. The total JavaScript time for this load is only 600 milliseconds. That animation, again, transitions out very nicely, and we get to interactivity at 4 seconds. Pretty good. I'd take that. Feels good. This is the exact same document on the exact same Wi-Fi network, except on my Nexus 5 connected over USB to Chrome:/Inspect. Same dev tools, but a very different picture. In this version of this same site, We get DOM content loaded at 2.5 seconds. Script blocks the UI thread for 2 full seconds. Onload happens at 5.5 seconds. And we've got 4 seconds of total JavaScript running. We still don't get smooth animations for all the work that we're doing. And interactivity slips a full 3 seconds from where it was on the desktop. Again, this isn't the network conspiring against us. This is just the CPU. OK, so mobile's hard. This is Framework X. The names have been changed to protect the slow. The first render feels downright instant on my desktop. It's interactive at 500 milliseconds. The total JavaScript time is less than a second. And on my MacBook Pro, this absolutely meets Rail. This is an outstanding experience. They've done server-side rendering. But on the Nexus 5, the first paint is really fast. But it goes downhill from there. So the script gets started pretty quickly. Again, I'm on Wi-Fi. But it locks the UI thread for 10 seconds. That loading spinner that they put up in that initial paint stops. It stops spinning because the CPU is too bound. That's pretty bad. And we don't get the interactivity to 12 seconds. Our desktop dev tools are lying to us. This isn't good enough. This is nowhere near good enough. So we've been working with a lot of partners over the last year or so. And mostly, I just sit down with them with a phone, and I plug it in, and I show them what it actually feels like. And when we do this, engineers get serious feels. It's not great. It's sort of sad-making. Now, it is possible to continue to use a framework, but we have to do it differently. We have to use a different style of constructing our applications. We can't continue to pile into the JavaScript clown car and assume that it's all going to be fine. It doesn't work that way. If you saw Taylor or Kevin's talks yesterday, you might have gotten wind of a new style of constructing applications that the Polymer team is pioneering. They call their pattern Purple. And here's the shop demo, again, on my desktop, MacBook Pro. And like Framework X, it's interactive at 400 milliseconds. So what, right? Everyone can do that. And the total JavaScript time is 200 milliseconds, so it's less, but meh. You know, they hit Rail, so what's to see? It only shows up when you go to mobile. It only shows up when you're on real hardware. And the differences are huge. Our first paint does acknowledge to the user that we're doing work on their behalf quickly, but we're not seeing the actual sort of UI. This is just a thing at the top that says, hey, we've got some stuff. But when we do paint, those painted pixels are actually interactive. You can use them immediately. And the reason that they're interactive is that the additional work that happens later to do stuff in the background to fill out the rest of the application is all happening in small chunks. We can continue to scroll and interact with everything that's on the screen. This site feels fast on a 3G device. And on my desktop, it's interactive at 1.7 seconds, which, I don't know, I'd take that. It's doing a full second and change of JavaScript, right? We saw earlier how 2 seconds of JavaScript can be terrible, but this is different. That initial wad of JavaScript is getting run in, what, is 460 milliseconds? But then after that, it all gets broken up into fine-grained little chunks. And so you don't feel 1.3 seconds of JavaScript. You feel that the site is interactive. And the way that they've accomplished that is to use the platform, to lean on the platform to schedule the work, to use the platform to provide the component model, to use the platform to provide the loading mechanism, to use the platform to provide the caching mechanism, to do granular dependencies and use HTML imports to make sure that things only happen when they need to. And I can't stress this is enough. What we're doing today isn't good enough. And if we use the platform, we can get to good enough. It isn't just device limits. Our other assumptions screw us too. We tend to be connected on Wi-Fi when we're in the office testing stuff out. And Wi-Fi's got its own problems, but it's nothing like a real mobile network. Even DevTools emulation of mobile networks doesn't really accurately model the sort of wild transitions that the physical layer goes through. And our protocols aren't well adapted to those wild transitions. TCP doesn't know what it means to have a physical layer that does this. Also, a lot of our tool chains have legacy desktop assumptions built into them, from analytics frameworks to font loading tools to your JavaScript framework to start with. They're making fundamentally wrong decisions for mobile. And that really shows up when you're on a real device. So these problems can seem culturally and organizationally impossible to overcome. That makes the goal of using the platform to help us out seem impossible, even when we know what the right things to do are technically. That's what motivated the AMP team, in part, to develop a set of off-the-shelf web components that bake appropriate assumptions for mobile directly into the format. It's been amazing to me to watch the AMP team's progress over the last year, because once upon a time I helped lead the team inside the Chrome organization that designed web components. In 2010, we expected that there would eventually be a diversity of frameworks and toolkits built on top of web components that would be interoperable as a result. And what we're seeing today is that diversity in the wild. You can use AMP to build really fast articles, or you can use Mozilla's A-Frame to build 3D environments, or you can use Polymer or Vaadin to build these really expressive, immersive applications. Seeing all the diversity really drives home to me how many problems we're solving with the web. And it also shows how an interoperable component model can make us as developers significantly more productive. What we didn't anticipate, though, was what the AMP team did. They built a validator for their subset. So AMP takes a bunch of the misfeatures of HTML's legacy design decisions, but it marries those with a bunch of fixes that AMP brings along for the ride, and it ensures through the validator that all AMP content meets AMP's design goals. So, what are those goals? I'd say basically that AMP is trying to enforce content modesty. To do that, AMP follows some rules. And those rules are all enforced by the validator. AMP only allows JavaScript to run in the main document if it comes from AMP. That cuts out a huge set of anti-patterns, but it also means that you can't add custom non-AMP behavior to your pages. Next, AMP elements lay out only once, and they always have proportional sizing, which means that you'll never see that thing where you've got something under your finger and you're about to tap it, and then that doesn't happen in AMP documents. AMP also goes to great lengths to get content on screen as fast as possible, delaying things that aren't critical to the user experience. It batches work in the DOM to make sure that the layout engine can process things as efficiently as possible. It removes the scourge of the modern web, which is multiple analytics frameworks loading in, all to instrument exactly the same thing every single time. It federates that out from a single listener. And lastly, thanks to all those restrictions and some cleverness about knowing what state a document is being loaded in, AMP makes it finally possible to do smart pre-rendering from AMP viewers. And if all of this sounds restrictive, well, that's kind of the point. But the results speak for themselves. The AMP team reports that they're seeing under 1 second average load times from Google search results. And at the same time, 8-second load times are experienced by 99% of AMP page viewers. Taking the same corpus of pages and looking at their other formats, you see 22 seconds at the median. It's pretty bad. And AMP does so much better. AMP's careful design allows AMP content to also be hosted on the CDN. And that's what's happening here. The Washington Post has published these articles, which I see badged here with that AMP lightning bolt in the lower left. And when I tap in them, the transition is roughly instant because the documents were hosted on Google's AMP CDN, and they're the same documents that the Washington Post put on their own server. But they can be pre-rendered. So that's what happens here. Once I load Google News, I can see that at some point later, once the news has loaded, Google News goes and preloads that thing that I might tap on next. And it can do this intelligently. Now, it's only possible because AMP knows how to avoid doing too much work when it's being pre-rendered. If we tried this with arbitrary web content, it would make my phone really, really, really slow. But AMP's restrictions make it sane to do this. And what it adds up to is a reliably fast experience. When I tap, I get that document. This is a real trace I took. When I tap, I get that document rendered and interactive in half a second on a real device. That's incredible. So thanks to clever preloading, content restrictions, and cooperation between AMP viewers and AMP content, we can finally get to a reliable experience transitioning from browsing to reading. So let's see exactly what that looks like on a Nexus 5. Here we've got AMP via the Google News site, helping us transition to that experience as fast as possible. It's great. And what this does is it puts publishers like the Washington Post and their content in the very best possible light. Their brand experience starts instantly. That's a great way to get introduced to users. So changing gears just a bit, I want to talk a little bit about progressive web apps. If AMP is all about putting restrictions on content to improve first load, progressive web apps are all about improving experiences over the long haul. They're app-like. They blur the lines between web content and apps. But they keep the strengths of the web. They add reliability, home screen access, and push notifications to an already strong set of web capabilities. You keep the same easy discovery, but you become app-like through use. This reduces the cost to acquiring new users. They're more engaging, and they can be re-engaging over time. So progressive web apps, why are they called progressive web apps? Well, because they become apps progressively. You just start using them in a tab, and then over time, they wind up being first-class citizens. So this is airhorner.com. It's the canonical demo. You can go try it out on your phone now. No, not now. Someone's going to do it, aren't they? OK. But if I go to airhorner.com repeatedly, eventually the browser will prompt me to ask me if I want to install it. It's something I use, and therefore I might like. Once it's installed, it can launch full screen in an immersive mode. It can even be its own top-level activity in the task switcher. And that splash screen that gets generated for the app is pretty nice. Of course, just like a regular native app, it works offline. It'll always work. It doesn't require you to build a separate package, though. You didn't have to put anything in an app store. You didn't have to go do a dance and pray for the update gods to let your new version through. It's just a website. But it's immersive, and it's exactly the same code that you would run on any browser. Obviously, this works in every browser, but it gets supercharged in browsers that support progressive web apps. Browsers like Chrome, Opera, Firefox, and Samsung's S browser. So they're progressive in two ways. Websites become progressively enhanced with new technology. You just start from the same base of stuff that always worked, and you just add new stuff in. This isn't broken content on browsers that don't support the new stuff. They also become progressively appy. That is to say, they become apps because you choose to upgrade them in your experience to be apps. All these capabilities are available a la carte, including push notifications. So I don't even have to have it on my home screen in order to get re-engaged through push notifications, but I can do that too. For more on that, I recommend you check out Owen Campbell-Moore's talk on YouTube. It's also worth noting that these things install instantly. There was no sleight of hand there. When I tapped that button and said add it to home screen, that was true. It was already available offline. There wasn't a process to wait through. And that's because the same resources that are getting used in that full screen experience are the ones that you were already interacting with. By the time that we decide to prompt you to keep it as a user, the site will have already cached that stuff offline. You also don't have to worry about finding a login or digging it out of an Evernote document or somewhere in your Chrome password manager someplace. It uses the same cookie jar. What we're doing here is using the web's superpower, which is URLs, to bootstrap a deeper experience with users over time. You don't have to choose web or something engaging. The web can be something engaging. Now, to get there, we have a quality bar. And the first part of that quality bar is to make sure that the icons on your home screen are things that are actually good icons. And to do that, we introduced the web app manifest format. And the web app manifest is a lightweight JSON file that you can host centrally on your site. And it contains metadata that we need to understand what the app-like behavior of your site is going to be. It needs a few properties to ensure a high-quality user experience. First, this is the Washington Post's manifest file. First, we need a short name, which is to say what you're going to see on the home screen. We need a long name so that we can give the users more context. It'll have to have some icons, including one that's at least 144 by 144 pixels, so we can provide a high-quality icon on high DPI devices. You can provide a start URL, which is the URL that gets launched when you tap on the icon. You can tell us which mode to display it in this case, standalone. And for that splash screen, you can configure the background color obviously using the background color property. The other part of the quality bar is that we require a service worker for progressive web apps. Users expect apps that are on their home screen to be reliably fast. They have to start instantly, and service workers are a requirement as a result. To get the Add to Home Screen prompt, airhornet.com had to make sure that the URL listed in the start URL on the manifest will work offline. Service workers are supported today in Firefox, Chrome, Opera, and in Samsung's browser. And Microsoft committed this week to implementing service workers in Edge. I'm very excited about that. So service workers, what are they? Well, they're a programmable local proxy in the browser. For a lot more on that, you should check out Jake Archibald's talk, which I think is already up on YouTube. So let's see how it works. Traditionally, you need to traverse the network every single time that you want to put pixels on screen. And that can fail, particularly on mobile networks. So we're going to have to make that transition from the browser to the server at least once, right? But once we're there, and we've got content back to the user, we can install a service worker asynchronously in the background. Once the service worker is downloaded and installed, it will intercept navigations. And from there, it can hand back content directly from the cache. That is to say, you can boot the document without going to the network. You can do the same thing for content. And you can check for updated content on the fly. You could provide a loading screen or a spinner to say, hey, I'm getting you new stuff, while showing the user the old stuff. This is what the best native apps do, and we can do it now too. If we get new stuff back from the network, we can send it back to the document and show an updated UI. This is pretty good. This allows us to be reliable in the face of transient and flaky networks. We got pixels on screen without ever having to go to the network. It's also worth noting that this behavior isn't something that we baked in. It's not a one-off. It's something that you wrote. The developer of example.com, in this case, provided the service worker code. They can choose what to do in each of these cases. It's super powerful. So the life cycle goes like this. Because we don't want you to break the web by requiring service workers, again, progressive enhancement for the win. The first time you go to a page, it doesn't have one. That's OK. But once you do decide to install one, and it downloads in the background, it'll get an install event. And that install event is a chance to go cache assets offline. Once you've done that, and you've told the browser, hey, I'm done installing, you'll eventually get an activate event just before the next transition or navigation. If you happen to go idle at some point, the browser will kill the service worker and reclaim the resources that it might be using. But the next time that it's needed, say to handle a fetch event, we restart it and send the event then. The way to think about service workers is that they're progressive enhancement for the network level. So we're now to the point where between manifests and service workers, we can build applications that deserve to be on the home screen. They can be trustworthy. They can be reliable even on flaky networks. You can always load the app shell instantly, and you can show the stale data or UI state while you're going to the network to get new stuff for the user. I think this is an underappreciated advantage that native apps have had over the web until now. We don't trust the web because it isn't reliable, and we don't know which pages to trust, even if it were. By pulling some tabs out of the tab and onto the home screen, and ensuring that those applications have to meet this quality bar, we now have a way of communicating to users that these apps deserve to be on the home screen. And we can do it without mangling our URL structure or putting something in a store. So think of a site that you use every day. I think that site is probably going to be a painful experience to try to use in the commuting scenario, when you might happen to be going into a train or going underground. But now think of some content that you really want right now. You want to check something on Wikipedia that you've never looked at before. It would be a real pain in the butt to have to go get that from a store. Why should I sit there through an application install to get that? So websites are painful for continuous use, and native apps have been painful for upfront, one-off use. So why is that? I think it's because native apps have been able to amortize the cost of that upfront download over multiple interactions. So there's a tipping point at which you use an app often enough that the lack of variance in the time it takes to load the app and get to the content that you want tips the balance in favor, and you don't feel the pain of that upfront install quite so much. With service workers and progressive web apps, we've brought that power to the web without having to give up that lightweight first use. The web is now the best way to transition occasional users to engaged users. It lowers your acquisition costs, and it gives you the same great reliability that native apps have always had. So progressive web apps are websites that have earned the right to be on the home screen by delivering trustworthy performance. So this stuff has been pretty new for a while, and debugging it's been a pain. Over the last couple of months, one of the teams has been building a new tool called Lighthouse. It's a verification engine that helps you verify that your site meets the progressive web app installation criteria. It automates checks to see if you've got a service worker, if your thing works offline, if it has icons that are the right size, all that stuff. It also verifies a bunch of things that are fiddly to try to determine without a real browser running. And it does this by automating Chrome. So it works at the command line, but what you see here is Lighthouse wrapped in a handy Chrome extension. These are the shop results. You can get it on GitHub today, and even though it's in a bleeding edge state, where it only works in dev and canary versions of Chrome, it saved me tons of time. Highly recommended if you're building a progressive web app. So the Washington Post built a progressive web app. You might have seen it yesterday. It's an incredible reading experience. And I'd like to introduce Chris Nguyen, a senior engineer at the Washington Post, who's been involved in bringing both AMP and progressive web app reading experiences to their users.
Hi, I'm Chris Nguyen, and I've been working on making AMP a first-class citizen of the Washington Post publishing platform. So our newsroom really loves speed and performance. Literally, we have monitors all over the newsroom that display average page load times for desktop pages, for our mobile site, and more recently, our AMP pages. So I want to talk a little bit about that. So as a baseline, our responsive mobile site, it loads in about 3,500 milliseconds. And based on data since we launched with AMP, we've noticed that it's more than twice as fast. And when we see our content served from the AMP CDN, it's well under the 1 second espoused by the L in the rail performance model. It's impossible to ignore the performance benefits of AMP, but AMP does have some limits. Not having custom JavaScript means that AMP renders consistently fast and feels fast for users, but it's also difficult to build interactive content, and that's something publishers really like to do, like visualizations and quizzes. So how do we bridge this gap? As we've seen from previous talks, PWAs don't have these restrictions. They're normal websites that are progressively enhanced with new features. And it's up to us as developers to design and build the experience. We have full control over what we want to do. So in designing our PWA, we don't want to simply recreate our existing mobile site. We took some inspiration from our native apps and some inspiration from our AMP pages, and we used this tech demo as a chance to rethink what's possible on the web today. So can we switch to the video? All right, so we open up a browser and we navigate to wapo.com/PWA. So when sections load, they start caching stories for offline reading. And when you tap on the sections that you're interested in, those sections will also become available offline. As a result of this caching, tapping on an article feels instant because it's coming from the cache and not from the network. You can also swipe back and forth to move between articles in the same section, and that feels instant too. But what happens if we go offline? So we go into airplane mode, and now you can see that sections which I haven't visited yet are marked as such, but the sections that are in the cache can still be viewed. So lastly, if we keep using this app, Chrome will eventually prompt us to keep it to my home screen. So let's go back to it. There we are. Now you can add it to the home screen. and we've got an icon. And launching it from the home screen brings me to an immersive version of the Washington Post reading experience, but we didn't actually have to ship a different app or upload it to the App Store. So in building this app, we wanted to make sure that the app shell was really light. So because application assets are a major factor in load time, and we still want to design for browsers where we can't rely on an installed service worker. And to do that, we made the decision to forego libraries and write the app in bare bones JavaScript. And the overall application shell is only 280K. Sounds kind of big, but that includes scripts, CSS, images, fonts, the manifest resources, and that's everything to load the app offline. On a 3G connection, on a first visit, the experience is responsive in 3 seconds, and we're already working on improvements to shave off more time. So how does it work? What we're doing is we automatically cache each section the first time that is visited, and that's during the time that the user would typically scroll through headlines. And if you swipe to the next article, what's happening is it's a cache hit. So the user doesn't see that you're going out to fetch another article or another piece of content. It just appears on the screen instantly. And that removes the mobile connection variance from the load time equation. So on top of that, if you're on the subway and you lose connection for a few minutes, you can keep reading. You don't get the offline dinosaur. So one thing to note is that even when a service worker is intercepting content fetches, we want different caching behavior for different types of content. Naively caching all the articles might result in displaying stale content, and we don't want to waste the user's data by downloading something that they're not interested in. So to give readers a great experience, we looked at all the network calls that we had to make, such as our application assets, our section metadata, and article content, and we handled them through the service worker differently based on their usage characteristics. We took advantage of some great tools, namely SW Precache and SW Toolbox, which you can find on GitHub, to help us manage that caching strategy. So let's take a look at the configuration we use with SW Precache. So highly dynamic content, like the section listing, goes to the network first. And that way the user doesn't miss out on breaking news. Like the top stories, that changes pretty fast. But in the case of a flaky connection, we fall back to the section list in the cache. But article content doesn't really change as often as the list of articles in the section. So what we do here is we employ the fastest caching strategy, where we look up the article in the cache, fetch the content, and return whatever comes back first. The network fetch also updates the cache, so that the next time you do it, you don't see stale content. So with respect to images, those aren't really going to change. So we don't go to the network at all. If it's in the cache, why bother? So in the case of no connection, we try to fail gracefully by providing some visual cue that uncached content is not available. And through the magic of service workers, that's what makes the app still work. And now we have the same offline reliability of native apps in our web experience. So this experience loads quickly, and as you can see from the waterfall, when the service worker installs, it begins to fetch content for articles so there's always something to read. Despite this preloading, though, the overall size to load the whole experience, the app shell, the articles and images, is just over 1 megabyte. And the user didn't have to go through the App Store to get this offline-ready experience. So we also have a native app, and it features some of our best content and works reliably offline. But to get it, you have to go to the Play Store, you have to accept some permissions, and then you have to download it. And that's about 40 megabytes, which is great if you're on Wi-Fi, but that's a pretty hefty toll if I'm on cellular. So in contrast to the web experience, I can't use this app at all until it's fully downloaded. WAPO.com/PWA gets me content instantly, and it's also available offline, which seems pretty great. Something to keep in mind is that service workers are constrained by the web's same origin model. Earlier, we saw how AMP enables the edge of your site to extend outward into other hosts like the Twitter or the Google News AMP readers and the Google AMP CDN that powers many of these page views. And when users see a Washington Post article in one of these contexts, they're absolutely experiencing Washington Post storytelling, even though it might not be served from WashingtonPost.com. So once users are already on WashingtonPost.com, it's possible to install service workers to give them some really cool features. But what about users that have never visited the site before? So let's look at one user flow. Alice goes to news.google.com. She sees a Washington Post AMP article front and center, so she clicks on it or taps on it. And this loads instantly because of AMP's clever restrictions and the smart preloading that enables Google News to adopt it with confidence. Next, Alice taps on a link to the Washington Post PWA from the sidebar. If she hasn't been to WashingtonPost.com before, this might be unreliable, slow, or it might even get her the dreaded offline dinosaur. Assuming Alice gets to the Washington Post, the PWA can bootstrap its service worker, and subsequent visits will be reliable and speedy. But can we do better? Can we get rid of that offline dinosaur? As of a few weeks ago, it turns out the answer is yes. So working with our friends on the AMP team, we identified a way for the existing AMP install service worker element to register a bootstrap file across origins. So here at the Washington Post, we're now including this snippet in all of our AMP documents. The AMP element checks the origin it's currently running on, and if it finds out that it's running on the same origin as the URL for the source attribute, it directly calls the service worker registration method on the URL provided. And this means that if you visit an AMP document on WashingtonPost.com, the PWA will get bootstrapped directly. But what if the AMP document's on the CDN? In this case, the element looks for the data iframe source attribute. If it makes a call that this is a reasonable thing to load, mostly by checking to see if the origin document for the AMP file matches the URL in the attribute, it creates an iframe for that URL and then loads it. So here's a bootstrap file we're using on WashingtonPost.com right now. And as you can see, it's not complicated. All it does is load the service worker registration file. So let's take a look at it. So if the browser supports service workers, we call the browser's registration method to ensure that the service worker.js gets started downloading and installing asynchronously in the background. From here, we can handle a few special cases if our app needs to. So for instance, if there's already a service worker registered, we can listen to see if a new version was installed, or if it's not being used, or we can also log errors back to the server in case the installation fails. So let's look at our flow again. Alice goes to news.google.com. She sees the Washington Post AMP article, and tapping on the article loads it instantly. But this time, it does something different. The AMP document starts to install the bootstrap file from WashingtonPost.com. So now when Alice visits WashingtonPost.com/PWA, instead of a slow network experience or an offline dinosaur, she's guaranteed a reliable instant load. So it doesn't take a lot of data to install, and it runs quickly when we're in the browser. But how about when we start it from the home screen? Are progressive web apps really able to feel as fast and fluid as a native app? We took a half-speed recording of both apps starting up and stitched them together to find out. So this is in slow motion, but you can see that once it's installed to the home screen, the PWA loads as fast as a native app. I can start using either of these experiences at roughly the same time. I think this is a step in the right direction for the mobile web. So for more alternative design patterns and future directions, let's go back to Alex.
Thanks, Chris. I really love the progressive web app that the Washington Post launched. It has replaced my native feed reader, which didn't support offline, weirdly. I'm using it every day. What Chris showed us is a great way to get end-to-end reliability for web experiences, starting at the edges with AMP and getting to deep engagement with progressive web apps. And as a user, I can move between those experiences with confidence. AMP gets me a fast first load, and progressive web apps keep it snappy ever after. This is pretty great. But we can do a lot more. The approach Chris outlined isn't the only way to build experiences that combine AMP and progressive web apps. We've prototyped progressive web apps that act like AMP viewers, much the way the Google News viewer does. Thanks again to the AMP install service worker element, it's possible for a user to experience AMP documents directly the first time they land on a site, taking advantage of that fast first load. And once the service worker installs, subsequent navigations can serve up an AMP viewer from the local cache, exactly the way that the Washington Post progressive web app works today. You can get content from the same URLs, but they can get much more immersive. They can get snappier. They can load custom behavior. I think this is the future of AMP and progressive web apps. The web has always excelled in providing content on demand, and now we can extend that reach even further. Amortized across all the interactions that users have with your apps, the web is now the single best way to deliver those experiences with low friction. In addition to some of the tools we've talked about today and talks we've recommended that you go check out on YouTube, the code labs on developer.google.com/web are a fantastic way to get started building progressive web apps. If you've got questions about these approaches or want to chat with us, Chris and I are both on Twitter, and you can try out, again, the Washington Post progressive web app at wapo.com/PWA. Thanks for coming, and we can't wait to see how much faster you make the web with AMP and progressive web apps.
Hi, I'm Timothy Jordan, and you've been watching the Google I/O 2016 live stream. Thanks for joining us. I hope that you've had as much fun as we have. If you want to make sure not to miss a single session, head on over to the Google Developers YouTube channel. The playlist is now live.